Nice collection of PowerPoints there.
Yeah, maybe you should remove the ones that are already done yesterday. Yeah. Also, Ludo mythology presentation, yeah, all needs to go. So let's look into our panel. The first one is Jonathan L. So we figured out that we could open in PowerPoint. Tell me if it looks correct, Jonathan.
Yeah, it never looked good.
Okay. So then we open the second one. Which is Kayan. So they're going to be in this order instead of joining them together. There was a problem by joining them together because the background would need to be one for the entire thing.
Yeah.
Right? So we're going to put them in this line, in the order that we're going to talk, and we're just going to switch, okay?
Okay.
We tried it yesterday to join it, and I have a different background, and that would be applied to yours.
I know.
Okay, so number 3 is Renata, if I'm not mistaken. No, is Nele, right? And Nele's is this one. Number 4 is myself. So this one. All very different. And number 6 is Renata. So we're good to go. They're all in the right order. What's this? I don't know. So they're in the right order. We're going to go from one to the next. And we're going to start from this one. Are we sharing already or not?
Not sharing, but Zoom is on. Just remember to change the username.
Can you show me?
Yeah, sure.
Check mine on PowerPoint. I made the keynote on the Mac. But they're pretty okay. The blue is different. Not like. To grass? To grass? Is it to grass?
To what?
What's the color between blue and green?
It's in French. It's bleu vert, so it's green.
Okay.
In Dutch, it is apple blue sea green.
Oh, yeah. So that blue sea green is not doesn't have the right name. It's more like just blue, straight blue.
Yeah, in blue.
So let's see if we are doing it right. Not yet.
I'm sharing too much.
Okay. Stop sharing. And share screen. And which one do we share? This one. Okay. Share. We should be good to go after this. Yeah.
Let's do it.
It's split now. We can duplicate it if you want instead.
Probably. Does anybody use presenter notes?
No.
You use presenter notes?
So do you feel like I should
Just mirror it, maybe. Yeah. I mean,
Or just show it in editable mode. I'm more at home. But
So now you're going to show that one. Screen sharing is stopped because, of course, it was disconnected. Okay. So we can screen share now this one.
Because now we're gonna have to switch it with time.
Screen? Yeah, okay. Screen, and instead of presenter version here, we can go full screen. It should be like this.
you're not duplicating screen.
I think I am, but maybe. So, duplicate, okay? So it's gonna say disconnected now.
Yeah, no, just restart it.
Okay.
You can just leave it like that.
Why? We can try to have it better.
It really doesn't want to begin. Maybe.
Yeah. Okay. Whenever you want.
All right. Oh, do you want to opening words or do you want to do a
Yeah, let's see 2 lines. But you can like sit on there or maybe I'll sit next to you. Stefano, how do I? Stefano, how do I switch? After,
You press S and you go out from this one.
okay, and then I go to the.
And then you go to another presentation, simply, and then in the right order here.
Like this.
Right?
Okay.
So it's very
Neck user.
okay.
Super
And this
familiar
one-
with. Then you have this, I can write.
Yes, but F5 is the same thing.
Ah,
You should have full screen, and if it goes in,
one.
takes a while though to understand.
It doesn't.
It wants definitely given.
And you have to do duplicate slash.
If it's okay with you.
Yeah.
No,
Wait a little more.
yeah, good timing.
Yeah.
Professionals.
Sorry.
We're right on time, right? Super. You can comment on that too, like, it's great. We should thank them for getting out of bed for this.
Yeah, absolutely.
Yeah.
Can you hear me right? Yeah. It's not too loud. Okay. Yeah, good morning. Stefano just said that I should congratulate you on getting up early and coming here. So,
Oh, thank you, rather. Yeah.
thank you. Thanks to us. Also being here. And yeah, welcome to our panel on research creation as an applied method in game studies. And following 5 presentations, we are going to try to build a bridge between theory on game studies and actual design practice. And all 5 of us here also incorporate that as being both game scholars and also active designers. And the 5 talks will try to build an arc between research creation, making theory playable, research to design, critical making, as well. So I'm happy to quickly introduce Stefano Gollini, Jonathan Lesser, Nele van der Mosseler, and Bernardo Nevia, myself, Faris Pinari. I'm handing over to you.
Maybe before we start, a couple of words about the format. We're going to try to do something very, very quick and dirty, as in, once again, our presentations are very short and introductory, so that then we have time to discuss and maybe involve you, hopefully, in a conversation, because what we're going to try to discuss is not only what we do, but also what's happening institutionally How are the things that we're doing being accepted, evaluated, and so on and so forth? So you might have questions that are specific to your institution and your case, and we might be in a similar situation, being all from different walks of life and different institutions. So again, it's going to be something quick on our side, and then hopefully involving you and ourselves in a larger fashion. Sorry if I interjected. No, okay. Jonathan?
Hello. So thanks for being there. I realize I start with a provocation, which might not be so provocative, but especially this morning, I don't feel very provocative. So game design research creation, I'm Jonathan Lessard, and in our department, that's what we mostly do, research creation. So it's like we're used to it. It doesn't mean it doesn't come without problems. And as we supervise students, it's always like the issues come over and over again. So I wanted to throw a few things in the air so that we can discuss it. So yeah, my provocation is that I think you can't avoid it. If you want to make game design research and you go to the end of that, at some point it has to be in a game for it to make sense or to be really established. So, but I was provoked as well. So once a PhD student of mine just said, okay, so I can just make a game and get a PhD, right? Which by that he meant no reading and writing, which he was a great game designer, but he was not so involved in all the rest of the academic requirements. So that took me a bit back. I'm not sure you can do that. So I took a step back and it forced me to reflect, because in a sense that argument is, there's some arguments for it. I mean, one of the tenets of research creation is that new knowledge is embodied in the object. So if you do an object that is new, then research has happened. So maybe that's your PhD. And also I wanted to build upon that, is that in the wild, again, game designers, that's how they share game design knowledge. Most of the time, they don't say, oh, let's do like I read in that paper in our game. Nobody said that. They say, oh, did you see what these people did in their new game? That's what we want to do. So discussing upon the examples that are found in objects. So game design's knowledge mostly circulates through the object. So maybe that's how you generate it all and communicate it as well. So, okay. And in a sense, creation is always research. So the moment you're doing something new, you're giving form to something that was never done, that is unknown. In that sense, you're always breaking new ground. And therefore, I mean, research creation is oxymoron in a sense also. But, but game design research creation is already happening in the wild, and mostly happening in the wild. Like the volume of games that do new things out there is, of course, much higher than what happens in academia. And they do it in a very free way, it circulates very easily. So then the question is, why even bother go to academia to do this with extra requirements and make everything more complicated? So my question then, and I don't have tentative answers, is what's the added value? Why would someone do this? And what does it bring to them and to the world, possibly? So amongst things that I find useful is the idea of due diligence. When I read professionals writing, when they have the time to write, typically I'm a bit irritated by the fact that they don't read each other, they don't read the literature, and so they're always, not always, but often reinventing the wheel, saying, oh, I have a new word for this concept. And I'm like, yeah, but it's been discussed like for 20 years, just that you weren't aware. Also, explicit positioning in problem setting, I find that's interesting, because when you see just the game, you don't know what brought it about. What were the hypotheses, in a sense, or the ideas that led to that journey. Also, recoverability and transparency of the design process. So when knowledge circulates only as a game, then it's a black box. You can just make deductions or inductions from it, but you don't, it's all the threads that have led to that explicit form have been naturalized in the objects and you don't know about them. So you don't know all the paths not taken, which often are even more interesting than the object itself. And if you write about it, then there's the luxury of an explicit contribution. That's especially good for non-specialists, because if you're a specialist, you see the game, you immediately know, okay, this is what this is saying. But if you're not, or if you're a student, then having the text that says, okay, that walks you through what this game is doing, that might be helpful as well. focus. No problem. Okay, but there are problems. So so these are seems good things, but there are also problems. And one of the main problems I find is when it comes to saying what's your contribution, and the students struggle with this as well. Okay, I made that game, but when I want to say what did I bring to the world, it's hard. And one of this is the idiosyncrasy of the problem and the result. So I wanted to make a game about this, and I found this solution, which is a game about this. But what can be generalized from this? Is there anything that can be generalized, or do we only have now a recipe for that exact problem? For example, one of the first games I made in the context of research creation was a game that was interested in how you can use chatbots and natural language conversation to make games. And so I made a game with it. And in a sense, it worked. People were playing it, and there was interesting feedback and all that. So it's like, okay, yay. But what aspects of it are generalizable? Does it work because it's that game with those characters in that context with this interface? Or what aspects of it can be abstracted and can be applied to some other things. So one of the approaches that I found useful is a series. So if I did 3 games with this general same design, but with different settings and characters, and so I could do some kind of comparison, like what holds true with each game. And so that's a good lead. It's a bit more expensive in the sense it's more work. And then I want to conclude with the types of contribution that I think I've been trying to make. So obviously there's the working example, where if somebody's curious to make games like that, then the game itself can be useful. The design heuristics, so as you are designing, especially something new, you have to tackle problems that are fresh, and then you might find tricks or ideas that get you there. And then these can be shared and possibly generalized a little bit. One thing that I find useful is also adapting theoretical concepts. So as you're thinking your new kind of game, sometimes you need theoretical help from other fields, and you bring them, and it allows you to think what you're doing right now, and then they kind of exist in the tool sets to do other things. So I think that's also possibly a contribution. And then creating theoretical concepts. So to me, that was probably one of the most useful things is not only did I import concepts, but sometimes there was nothing available to describe what I was trying to do or a notion that I was trying to formalize, and then say a word to it, and now it helps you for future things as well. And when I read other research creation papers, oftentimes that's what I keep the most, like a word that signifies something that I can use again. So yeah, that's it to get started.
Cool. Thanks, Jonathan. And also might set the frame for some of the questions we might have.
Seems to be working.
Okay, so I'm going to walk you through 2 specific examples of using the design of serious games with children. So it's 2 basically participatory design and research through design approaches. And I'm going to throw in another new term, which I came across in my work. So I'm a professor of digital education and learning at the University of Vienna. And in the digital education space, we are now very much tasked with conveying programming skills, computational thinking to children. And maybe not in juxtaposition, but to expand on that, I found the term computational empowerment, which is also often referred to in connection with participatory design as a way of designing and working with a target audience that not only harvests research information, but empowers themselves to create and to realize their ideas and to, in the end, take part in technological development. So, first example is Sparking Games, a research project where we did not aim to create actual usable serious games, but to use the design process as a way of teaching and learning. So what we did is we worked with 3 schools, and the students would create learning games on topics from informatics and society. And we would have a course of workshops where we started with analog game prototypes and design workshops, and then did a lot of peer feedbacking and iterations. So they would create posters of their games, present it to the other students, and then put post-its on there with feedback, and then go back to iterate on their game ideas. And then in the end, they also would play the finished games, which were both digital and analog games together. And they also presented at a trade show in Vienna, so that added some kind of extra motivation. I'm going to show you some examples. Like the range of games was very broad, from like activity style quizzes to a strategy game where you have to breach a firewall, to simulations, and yeah, you won't understand that. It's very funny. It's a German word, the Bundestrojaner. I think we invented that. It's like a Trojan horse created by the government. Sorry, I had to share. It still makes me laugh every time. And there were also digital games. One open world RPG, which had this dystopian technology-centered narrative, which made you question the world you're playing in. And this very simple-looking game, which was very intriguing, where you woke up in a future where there were no analog media anymore, no magazine, newspapers, books. There were only digital media, and you had to like talk to people, find out what happened. So what did we learn from that project to embed that in the research frame? So we had pre-post surveys, both quantitative and qualitative approaches, group discussions, and so on. And we found that this using game design and this research creation process with students actually is a suitable method for teaching and learning, for project-based teaching in particular. And then you can use it like in the classic research to design approach to get artifacts, settings, game genres, mechanics that appeal to the target audience. And we could also see that engaging in the process worked in terms of increasing not only the sensitization towards the informatics and society topics that we aimed at, but also to increase media and in particular game literacy by engaging with the actual design process. The second project I'm going to show, and I'm going to be quick here, quicker than the first, is also a participatory game design process, but differently this time. It's in the context of a game for health called Interact, which we created with the St. Anna Children's Hospital in Vienna. And it's a game for a very small target audience. It's children after stem cell transplantation. So it's a pretty serious topic in a sense. Stem cell transplantation is something you do usually. Oops, yeah, what you do with children with leukemia as a last resort. After the stem cell transplantation, the whole immune system is severely down, and the most important thing you have to do is track health data across a variety of factors to be able to see if there are some crises, like there's some organ failure, for example. And so jump back one last time, and you need to track that in the best case several times a day, and you have to have very high compliance with entering the medical data. So the idea was to create a game for these children or a playful environment that helps them to be compliant with entering this data. Because you wouldn't believe, even in such serious cases, as soon as children feel better, they stop. So what we did is we did not design with this target audience because we could not, because it's a very small and very vulnerable group. So we used proxy design sessions. So we you call it proxy design when you use others as a placeholder stepping for the target audience. And so we went to schools and used healthy children of the same age, and we let them draw mostly avatars, and we gave them a sheet with comic book frames and very short stories, like draw an avatar that would strengthen you in such a situation, empathize with how it could feel like to be in such a situation, and draw an avatar that's your superhero that could comfort you, but also give you the strength to go through and draw what you would like to do with this avatar. And we used that as a base to then create the game. It was like a small openish world where you, like an RPG where you could like discover stuff, also fight with other characters you encounter, and like get skills and level them up. And that would also like help the data entry part of the game, where you could get some experience points to then help you. And like on the left side, you can see the interface for, in that case, entering where pain might be located, and the other side you can see one of the cat avatar, how it ended up being the game. Two of the characters, the cat and the penguin, that we took from the comic book frames, and how they got realized in the game. So what did we get out of this? Similar approach. We also had the health data, the gameplay metrics, but also the pre-post surveys, and also like a small controlled study. And we found that the proxy approach proved to be viable. I think this is not generalizable, but in this case, we could see that it worked. And again, like we found different game ideas, avatars, mechanics that appeal to that very specific target audience. And we could also see that the compliance with the health data tracking got up. So to quickly have some takeaways from these two projects, I found that combining the research creation approach, but also looking at this what I call computational empowerment perspective, where you try to give something to the people working with you, particularly allows you to focus on the creative part and the actual crafting in the process, and like I said, also give something back to the people you're working with. And it allows to put an emphasis on both empathy and intrinsic drivers, as opposed to just gamifying. So I don't want to do gamification bashing here, but I think if you're looking to design for intrinsic factors, then such an inclusive participatory approach can help you tap into that more. Yeah, and we could see like that the proxies worked. Also in the first project I showed you, we could see that the games the children created individually were interesting to the others as well. Okay, I hope I didn't understand that.
Thank you. My name is Leila van Mosselijn. I'm from the University of Antwerp, and I'm going to be talking about a game I co-designed together with Stefan, actually. And we call it a meta-reflexive philosophical game. It includes a lot of the research that I've done in my, how do I?
You already did on the screen. So.
But also on the Zoom or not?
I suppose.
So I'm going to try to explain what we mean with meta-reflexive philosophical game. If we are going to start. How do I do it?
Can I do it?
Yes, sir. So I'm going to start over.
Yes.
I don't know if you know the word by everything like it's called the treachery of images. It's better known as to see it as you need.
Yes, no, done.
Maybe just focus on it with the.
Stop sharing.
share next time. Where is your video?
Very important.
Yeah, it was a little bit. Let's do this again. You should be able to look at
No, it's. Then you first have to share it and then.
This is not very much.
I don't know. Which one? This one? Let's
No,
do
that's,
this
no, that's the you're sharing your screen. I think it's the.
one? Shall we draw like this?
Sorry.
Is it? No, because you're sharing the whole screen.
Okay, here it is, the treachery of images by FDG Room. And this is an example of a meta-reflexive philosophical work, right? Because what you see here is, of course, well, what we would call a pipe. But Mahmoud's point is, this is not a pipe because it's just paint on a canvas. So the painting is actually saying something about itself and the nature of representation. Now, this is paint on canvas, but it would also be interesting to look at a virtual pipe. For example, the pipe we could see in a video game. This would be interesting because, of course, here there are more interactive possibilities. We could actually smoke this kind of pipe through our avatar, unlike Mahmoud's painting. Yes, you could smoke Mahmoud's painting, but it's a bit illegal. And this is the kind of pipe that I want to ask questions about, and which is also what I did in my PhD. Philosophers can ask questions about anything, but for example, about this pipe, we could ask, is it a depiction or is it a pipe? Is it an interactive fiction, whatever that would mean? Is it a real pipe or just a realistic pipe? And we can come up with thousands of those questions. These questions are a bit silly, but it's also exactly what I did for 4 years during my PhD, asking these kinds of questions. And so this is also what I wanted to make a game about, together with Stefano and a team of the Institute of Digital Games in Malta. We didn't make a game about the pipe, that was a bit too hard, but we made it about an object that is a bit more ubiquitous in games, namely doors. You might recognize some of these doors, but we made an entire game around the concept of a door in a video game, and it's called Doors. You can find it on doors.bloody.com. And I'm going to explain a bit about the doors that you can find in this game. There are 11 doors in total, I think, and I will be describing 3 of them to kind of explain to you what we wanted our players to think about. Kind of the questions that tortured me during my PhD, I also wanted to give to players. The very first door in the game is the entrance door to the hotel or the inn where the game takes place. And when the player clicks on this door, it opens. And the game is very nice because it immediately gives you an achievement for opening this door. It says, congratulations, you opened the front door. But it wouldn't be a philosophical game if you then not immediately questioned that statement. So the game actually says, wait a minute, does that even make sense? Because you didn't open the door, player, but this character did, like the avatar opened the door, right? And you didn't even open anything at all, you just moved the cursor around on the screen. And also, this is not even a door, it's just a group of pixels on your screen. So it actually changes the text of the achievement. It says like, no, maybe it would be better not to say that you opened the front door. Maybe it would be better to say that you, taking on the role of the protagonist of this game, use your cursor to interact with this group of pixels, of which it can be said that it is a virtual model of a door, because it is an interactive computer-generated representation of a door, and thus you can be said to have fictionally opened the door that is represented to exist within the world of the game. I promise the game is also fun. This is just the kind of thing that it does. So this would be a more philosophically approved way of stating what happened here. And all the doors in the game does do something similar. A second door is what we call a non-interactive door. This door really pissed off a lot of players because when they saw the door, they of course tried to click it to open it, but it didn't work, so they tried to click it again, and then they got really frustrated because the door doesn't do anything at all. We designed it not to do anything. It's just part of the background of the game. And the interesting thing here is we call it a non-interactive door, but again, we kind of question what does it mean to be a non-interactive door. We want our players to ask this question when playing the game. Because of course, this door was approached by players, it was examined by players, it was clicked on by players, and only when they saw that it didn't do anything, they realized that the door was not interactive. But you see the paradox here, right? Players approached it, examined it, clicked on it, and then decided that it was not interactive because they had already interacted with it. So it kind of questions what it could mean to be a non-interactive object within an interactive fictional environment. The last door I want to take a look at is what we call the old door in the basement of the game. This door doesn't really open when you click on it, but it actually just breaks down. Breaks down into planks, and then one of those planks is very useful in the game. It should be used in a certain situation. I don't want to spoil it. And here the question that we ask to players is this less of a door because it broke down when you tried to open it? It didn't actually function as a door should function. Or is it a more complete and realistic door representation? Because just like wooden doors in real life, you can break it down into planks and then use the planks for something else. So again, kind of playing into this fact that is a simulation of a door something that should function as a door, or something that has the interactive possibilities that real doors would have. I'm not going to talk about more doors, I don't want to spoil the entire game. There are a lot more doors to discover in the game, so I say play the game, please. That's my first conclusive takeaway here. Play doors, you can find it on doors.180.com. I hope to also have shown the philosophical value games could have, or more precisely, the value philosophical games can have, especially meta-reflexive games like Doors that make a point about representation within games, for example. Doors is a game that constantly asks questions about itself, like, is this a door that I'm giving you? Is this interactive? What does that even mean? And yeah, so I think the meta-reflexivity of Doors is what makes it particularly valuable to ask the kind of questions that I did in my PhD. It investigates our experience of games through a game. Thank you.
Thank you, Lily. And I think she made it very clear that as scholars, we do not only produce texts, right? Sometimes we comment or discover or communicate things also with other media, and this is almost a part or a big part of what this panel is about. Okay, so about my little contribution here, let's see if I can make it work. This is 3, 2, 1. I'm taking it, whatever it is. Okay, so my name is Stefano, as they said already, and I work in an institution which is in that little island in the south of Europe. The reason why I'm putting this up is connected to what I was talking about at the beginning of this talk, which is institutionally. How is this taken? So I'm giving you a little bit of reflection about what the situation is in Malta. Before me moving there, there were no regulations about how things like the one you saw, like we made a game with a philosophical output for an academic purpose, would that be understood and appreciated by the institution? Would this be a valid output for us to produce as scholars? Before I moved there was no regulation. Now I'm helping the transition. It's the south of Europe, so it takes a little bit of time. But in the north of Europe, this is already closer to the norm. For example, I work with Malmo and Gothenburg, and it's already more common there for scholars to produce these kind of things. So, as Nelly pointed out, both she and I work in philosophy mostly, and so as a scholar, I produce books and texts. Yes, like many of you, like whatever. New one coming out, doesn't matter, but also I make games. I used to work in the industry, and one of the games that I made was shown by Nelly just now. I made a few others that you might have seen before, a game about the analytical definition of what soup is or can be, in case you played it. A few others about what does it mean to say here in a virtual world, and how can we play with that idea. Or in this one, by the way, Pippin plays the parrot, which is a cat, doesn't matter. There's another game which is about self-reflexivity. What can we say as game scholars about games through games? So those kind of experiments are something that I like to experiment with, or I liked to. After Doors, I think I'm going to take a little bit of a break, because that was a bit traumatic and long. But I'm not the only one working in this field, so to speak. I believe that Pippin, a colleague of Jonathan, for example, also worked in artistic/philosophical ways to express ideas. And often, more often than not, those ideas take the shape of interactions, experimental little clickable things, or something close to games. In case you're interested in knowing more about these experiments that are out there, or how can we use this medium for philosophy in the academic sense, there's a set of small articles on an encyclopedia that you can read. A couple more minutes for me, which is, I'm going to talk about something different. So Nele talked about games, everybody talked about games. I am also very excited about this idea. However, I tried to do something different in this past year, which is working with the idea of theory fiction, which is more or less the same idea, only in the field of, say, traditional arts, such as literature or movies. What do I mean by that? I'm taking the words of Mark Fisher, who in his doctoral dissertation described this idea of theory fiction, which is a close concept to research creation as the dissolution between theory and fiction. Imagine this could be rephrased as the dissolution between doing and producing academic work. Like, they might be the same thing after all. So if you think about it, especially in philosophy, the transition is quite easy because the dissolution has been around in philosophy for a long, long time. Think about, I don't know, the Socratic dialogues, right? We are exactly in one of the locations of the Socratic dialogues here. Are they fictions? You know, like this famous tale, sort of, in which Socrates goes into Athens and annoys people with questions, and then they get into arguments and we discover new and better truths from that. Are those fictions? Are those novelizations? Are they academic texts? Are they essays about justice, virtue, courage, and so on and so forth? Or should we not take them into account because they're just imaginary tales, so to speak? Think about also the idea of thought experiments, right? A common tool in philosophy. I'm presenting you with a little fictional situation for you to work with and elaborate your thoughts on. Is it less valuable because I give you something to do, I give you a fictional thing? And so, is your knowledge now less than the one I give you, for example, lecturing from a podium or giving it to you in a text? So, the idea here is similar. So far, I've tried to do this process in the context of philosophy with interactive fiction, so little experiences, games like the door game that Nele just showed you. And I'm going to try to do it with literature next. I mean, it's maybe less interesting to you, but I'm going to try to write a stupid science fiction novel, which also has a academic part. I contacted Routledge, and they were honestly stupid enough to say yes. And I'm saying, if they're stupid enough to say yes to an idea in which I write something and they write something about that something, and one can enjoy it without the other, and so on and so forth. If they're stupid enough, as I said, I'm stupid enough to write it, and so I'm going to try to do academia with writing in this case, but not academic writing. So it's in the same vein, but I wonder what my institution is going to think of it. Is it going to count as a book that furthers my career, or is it just a divertissement just because I had the opportunity of doing it and doing it? So I would like these kind of questions maybe to come up later in our discussion. I will not be much longer. Of course, you can play our games. Jonathan's nailed to mind in the ones that were already discussed, plus the ones that will be discussed by Renata next. Yeah, I'm just trying to experiment doing in a wider way than just games. Next one is going to be doing words. So hopefully this was interesting to you, and I'm sure the next one is going to be more interesting.
Thank you for having me on. No pressure. So let's stop sharing and start again, or does it work when it's late? So, hello, my name is Renata Delia. I'm a lecturer in School of Computer Science at University of Lincoln. And my take on this panel is going to focus on what I'm personally and academically interested in, how can we design historical trauma? Because as a player and as a tentative designer, the questions I have, and I would like to share with everyone here, is can we play everything? And actually, can we play trauma? and historical trauma at that. There's already literature that has discussed these topics. For example, Franska in 2000 has talked about the game has this sort of negation to trauma exactly because it has this iterative process with trial and error and the win and lose situation that doesn't allow for traumatic events to be properly explored and experienced. Linderoth in 2013 has called games narratives of empowerment. So the player starts off usually as a newbie, and as the game progresses, it becomes better and better at the big game. But trauma, historical trauma, doesn't work like that. Chapman and Linderoth also contextualized the problem of designing trauma in Goffman's frame theory, and they argued that in-game objects, while we play, become ludified, so that their attention is first and foremost what they can do with the game and inside the game, rather than being reflective and conscious of the traumatic event that is being represented. But while we have stated the obvious that there is difficulty in designing trauma, we can also understand the challenges as opportunities for development and overcoming the conventions that plague the medium at some times and confine us all. So as games, as opportunities of engagement and having a very powerful resonating effect instead of difficulty in expressing trauma. Obviously, there are already games that deal with traumatic and difficult situations, like First Please, The Harpoon, which is a game where you hunt whales through the darkest of times, which takes place before or when Hitler came to power. There was resistance going on in Germany. Buried in My Love, which describes the effort of Syrian refugees to reach Europe. My Child Lebensborn, I think it's also been mentioned before, which talks about children that were born in Nazi Germany that were adopted by other families and the stigma that they have faced. Attentat, which is a game about the resistance in Czech Republic during World War II. The Train by Brenda Romero, which is a game that discusses, or rather puts the player in a comfortable position of stuffing pawns in a train, and then they later find out that the trains are supposed to reach concentration camps. Spoiler alert if you haven't played the game. But from all above examples, and you might have already noticed that there is a glaring omission. There are no games that actually discuss, or not discuss, represent concentration camps. They discuss the Holocaust, or they represent it fictionally, like Wolfenstein, but they don't actually show the representation camps. And there's a certain taboo when it comes to representing the Holocaust and representing the Holocaust in games. But as I said before, I don't know if you've visited concentration camp. I have, and when I was going through the guide tour, I was a bit underwhelmed because the tour was very detached. I wasn't allowed to feel connected to what was happening there, what happened, the atrocities that happened there. And until I came across a certain artifact that was very mundane, it was just a shoe, but it looked so familiar that it completely struck me that I could be wearing that shoe and I could be there. And the only reason I wasn't because, well, first of all, I wasn't bored, but also because I didn't belong to that cast of people that were considered, perishable, basically. And as a player and a game designer, I realized that the power that the medium entails in putting the player in a situation that they wouldn't have the ability to do in non-game context. So I tried to manifest or translate this idea into game about the experience of the camps. And this is just my approach into how you can design and represent historical trauma in games. I focused on personal microhistories, so instead of trying to encompass everything that is the Holocaust or experience of camps, I focused on a very specific story. I removed any repercussions for the player, so there was no win or lose scenario. The player would survive the camps no matter what. So whatever it did in the game were only acts of compassion. And I realized, or I decided, that the best mechanic to allow that was the resource manager. So the game I designed is, my primary sources is inspired by Simon Ark, who was a Greek Jew, but because he was a boxer, he gave boxing matches in the camps, and this is how he survived. And also the recounts of Primo Levi, who was an Italian Jew that survived Auschwitz, and Georgia Gambett's reflections on Primo Levi's experience of the camps. So, as an academic designing this, I had to receive funding and also receive the okay from my institution. And one of my reviewers thought that the game was completely tactless and in poor taste, because why would we design a game about the Holocaust? Games are only for, collecting jewels and killing creatures. And also the job center, because I had to publish job positions to hire students to help me design the game, thought that my game impeded the decolonization of the curriculum for some reason. But my school believed in what I was trying to do, so I managed to get some funding to create only an alpha version of the game. This is my team, some very talented students that helped me design it. Here, the game is still under process, but it will be published and freely available online. This is the main map. The main gameplay is that exactly because based on Salomon's experience, he was able to work in kitchens, and this is how he managed to survive and also help other inmates. So you have the banquets where you sleep, the kitchens, and the boxing arena, and you can interact with the elements of the maps. Here are some screenshots from the game. This is the kitchen where you work. This is the boxing arena where you give exhibition matches. And this is the main gameplay area of the game where you can choose one of the figures to give food or other resources to. And as I said, there's no repercussions for the player, and also you don't have any say on the fate of the actual inmates. So whether they live or die doesn't. It's not affected by your actions. You just live out of mere compassion. So this is just my approach to designing historical trauma, and thank you for your attention.
So I think we took a bit longer than expected.
Surprise.
So we'll be very happy to take your questions.
Can I ask a question? Since maybe, I'm sorry for troubling you. She was talking about making a game in an academic context, and it was just fresh in the memory of everybody with the same picture, and I loved it. What do you think it means for you when you said, I work within an institution and funding for this game? What does it mean for you to be treated seriously as a creator? Not just as an author, but within the context. So is it about your possibility to write about it, to get money for it, to be recognized? Can the game itself be recognized as a publication or as output that needs to fulfill your quota? So since you just talked about it and went in some detail, we'd like to know how you feel your institution is embedding this practice.
Yeah, well, I can only talk as an early career researcher because this is actually my first game. So I completely felt validated in what I'm doing as research is considered research. And as you said, different institutions handle things differently. I come from the School of Computer Science, so games is only a small part of it, and the school recognizing that a research project like that can receive money is also an acknowledgement that games are also a valuable part of the school and of the institution. So it is considered a public a publication and a research output. But they still ask me if it can bring us more money. So this is always a question on the table, and also what more I can bring out of it. So I use that as a stepping stone for further research. So, but I think it's a great first step to finally receive some validation. It's not just the money, it's also the acknowledgement that this is great, basically. I don't know.
I don't want to say much because I feel like I'm really in a position of luxury where I'm in the fine arts faculty. And so if, like my colleagues in the other departments, if photography is considered a research output, so who's in a position to say that the games aren't? so it's all good. It's easy for me. But when I try to do collaborations with computer scientists, because we live right across in the department, it's very hard. And it's not bad faith. Like, oh, that's a cool project, we could do this together, we have technology, blah, blah, blah. But their own career requirements are so strict that it's usually a cost for them to engage in that research because they will get no credit for it because they have to publish in the IEEE and the game will not be considered as research. And so it's really hard to get these going. So that's maybe the downside.
Yeah, and I think I'm being supported by my institution, but the field of philosophy is not very accepting of games. So whenever I present this game at a games conference, people are nice and like it and stuff like that. But then 2 months ago, I presented this game, the presentation I have now, at a philosophy conference. It was an aesthetics conference, and I remember ending my presentation with the question, like, do you think that this kind of video game can be valuable to our field? And the first reaction I got was like, no, I don't think it has added value over paper. So now I'm going to games conference again. So it's hard to have an entrance into philosophy with video games.
Yeah, I can also comment for Austria, like you said, I used to work at the University of Applied Arts, and there it would be automatically count as a top in your CV, as an artistic work. Very much as opposed to working in computer science and education, which I also do. And there the only chance would be to get credit over funding money. Like if you get X thousand euros to fund a game production at university, then it's great because then you can put the money in your resume. But we like to in different areas as well. So we started that discussion at the University of Vienna, triggered by teaching changes. Like I need to produce content for teaching, for online teaching. For example, I produce a lot of MOOCs. And then the university noticed like they got 75 people to create stuff. So maybe the process might be started.
There was a question there.
Oh yeah, I wasn't sure if you should get the microphone. Quick comment for first of all. There's one person on Zoom, and I don't know if they can hear me. Yeah. Great, thank you very much. So just really quick comments. You're likely aware that very long-standing precedent for what you seem to want to do is in cultural anthropology. So ethnographic fiction is a thing that's existed since the 1940s at least. Not just textually, but you also have ethnographic film. So like John Bush is a famous director whose work we know is scripted and staged, but it looks like a documentary, and so there's this interesting tension between what's documentary evidence, what's fiction evidence. But the question is actually the plan. Sorry if I just pushed your name. So let me just look at my notes to remember what the question was. Oh yeah, so you mentioned that like the challenge of, not the challenge, but the tension between game designers, game designer communities outside of academia. They don't necessarily sort of engage in the same body of work. And I think there's a body of knowledge that exists kind of separately, right? Sometimes we use different terms for the same things. Yeah. And you'll talk to people who get all their knowledge from like GDC talks and channels on YouTube like Extra Credits or Game Maker Toolkit or whatever. They'll talk to you about things like emphasis and randomness, which was a recent conversation I had. Never encountered the term in an academic context. And the person I was talking to was a game designer outside of academia and never heard of like Costican's book on 11 types of uncertainty. because you could read those by T-Press if they're game design.
Mhm.
Right, so how do we reconcile what seems to be very complementary types of knowledge, but that exists in like two different spaces? Can we learn from each other?
While I give it to Jonathan, there's also like an important paper on research design for as a methodology for human-computer interaction that addresses the generalizability of this knowledge and in comparison with scientific knowledge. So there's already like quite a few studies by colleagues in Zimmerman and so on about this very topic, but Jonathan must have his own personal experience also.
No, what you said is right, and I just want to, the question of the parallel, the parallel, let's say, bodies of knowledge or even vocabularies. Yeah, it shouldn't. I mean, I don't mind. I don't think that the game designers in the wild or in the industry need to read the academic papers. I think that's a strong request. but at least it needs to go both ways. When someone writes a game design research, I think they have to know and engage and listen to the GDC talk, or else they're setting themselves apart. And then if you don't like those terms, at least in your writing, you do the translations and say, okay, when I say this, I mean also some other people name this, and that. So no, these have to talk together. Right? It doesn't always, but it should. You're right. I don't know if someone wants to add.
So let's say, let's say you hire a doctoral student. What would the path for that student look like? How quickly would you expect them to make games? I'm just gonna not use it. How quick? Sorry, there's a lot of questions that I think are related to this just general idea of what does the path look like. So, how quickly would you expect them to make games? How often would they make games? How would they split their time between making games and writing on said games?
That's a very good question.
After luxury of grabbing the microphone, I would expect them to start immediately. But I think that it can go many ways. So my background is HCI design, computer science originally, and there we try to make something as soon as possible, to learn as much as possible, to have some kind of base for iterations. And as for the actual time split, I think I would, knowing also the institutional barriers we discussed in the first question, I would really try to emphasize that there should be a lot of empirical work, theory, writing, to live well in that system. So I hope that's answers it.
If I may, I'd like to add something. So that's a good question, because I think being a student, you have to be particularly wary of your time and resources, because you're not like more precarious situation. And it seems research creation sounds fun, and sometimes students get into that saying, oh, it's going to be easier because I just make something and then write less, or the theory requirements will be less. But what we find is that it's typically twice the work. Like, it's just 2 times harder, because you have to be good at the making, but you still have to make your proofs, at the theory and all that. So it's like double. So yes, the making is, you have to be wary of how much you invest. And the truth is, to be able to do research creation and make claims about your creation, sometimes you don't need a fully realized game that would require years. Sometimes just maquettes, prototypes, game ideas, and all that can be research creation that you can talk about. And then your question about expectation for the trajectory of students, it varies so much. So I can't comment on that. It's really just a matter of the meetings and where people come from. But sometimes people come from with little experience, then they learn as they go, because there's time in the PhD. Or master's, there's little time, so typically take someone who's already kind of knowing what they're doing, and they can get going immediately. So really different.
Yeah, if I can add something in that. First of all, if you think your idea is not big enough, rethink it because it's definitely more than you can handle. And so I think it's something, a fallacy we all fell into while going to PhD. And you have to be as specific as possible. There's always things to be said and done. And in terms of the actual development and the progress of your PhD, I think it depends on each person's strengths. In our school, for example, we can have students with very strong in coding, so this part takes them less time than the actual research, or other students are better researching and having the theoretical background, so this takes them less time, and we need to focus more on the actual coding, because for us it's a requirement that you produce a coded artifact. So you need to be aware of your strengths and your limitations. I mean, and this is also very personal perception. Your supervisor will help you with that, but it's something you have to decide for yourself and be honest about. So yeah.
I think we can have it as a very quick last question.
I feel bad wasting the last question on this particular question then. Yeah, this is a thought experiment for my question, I guess. So we're not the only field that engages in making practices by far. So I'll be a complete generalization. You know, I'm a scientist, I'm working in a lab with a group of other scientists, and I'm making something, I create something, and then I get my PhD based on publications that I do or write with it. Why is this? And yet, you know, I have my students who come in and it's like, well, I'm going to work on this game project, and do I really actually have to write something? Do I really have to like engage in these other practices around? Aren't I doing enough? I'm making the thing. And I honestly don't know how. And I mean, like Jonathan, I don't know how I feel one way or the other. Is what we're doing really different? Like, what is the like, exclusive case where it's just like, oh no, our creation is standalone, definitely.
Did you want to comment? So just to be sure that I understand that you say, in a sense, why isn't it standalone? Is
Why is it?
yeah, yeah. Good question. I mean, in the fine arts, the MFA, they don't have to write. They just do the masterpiece, and then that's it. You can write like a 5-page or 10-page artist manifesto that explains that. That's what I wanted to do. Blah blah blah. So is that good enough? I don't know. But there's also the case. I mean, there's the thing. I had to write a PhD, so you got to do it too. But I don't want to be that person. But so when I was asked, I asked around like the people in the fine arts, is this something you can do? And everybody's like, no. So I didn't go any further, but I don't have any answer to that question. Did you want to add to it? No. Okay.
I think it's also a matter of, once again, let's not abandon this, but it's a matter of institution as well. Like different disciplines have different requirements. In computer science, yeah, you need to. If then you need to be employed, it depends on why you want to do the PhD. If you want to be employed by fine arts, maybe you don't need to write. But if you want to be employed by a computer science department, yes. By philosophy department, yes. So I think it depends also how you see your own PhD process and what you want to achieve out of it and where you're doing it.
I'm going to be standing Stefano and also say that in a field like philosophy, there are no citation rules when it comes to games.
Yeah.
So it's very hard to actually make something that will be picked up because even if people talk about it, there's no way to cite them. So it's very strange. People play that game, but they can't actually do something with it in philosophical papers because the journal doesn't even list it.
Mm-hmm.
Yeah.
That's a very good point.
Yeah.
Okay, and Jonathan didn't just abandon us, he's cheering upstairs.
Just jump the ship. I'm
I'm done with this people.
Okay, I think we have to close it at this point. Thank you very much for
Thank you.
the attention and questions.
Thanks. All right. We're trapped here.
Yeah.
Yeah, the citation thing is terrible. I have games that I found out like were used in classes and like, but like I have no tracks of that. Yeah. Yeah, all that effort. Oh yeah, sorry. As usual, just asking the questions. Yeah, but okay, you have to do one PhD as well with research creation. Yeah. What do you do? Yeah, I guess it's the question of my discussion with the student, or it's if you don't want to engage in theory and model writing, then you really don't have to. Like nobody's asking you to do that. Just go out there, make the game, share it, and that's it. But if you want to sanction it and engage, yeah. So, but did you resist this?
I did, but I'm just external.
Yeah.
I've never written on it.
I was, yeah, I've been in that situation a few times as well. Okay, it's research creation, like the pieces are like kind of banal, and the thinking is kind of superficial. Are we doing this? Like I don't want to be an asshole, but
Yeah, that's exactly. Fresh in my mind. And also, with the added awareness,
oh yeah. Circumstances.
So, because I don't know what exactly happening here.
I'm sitting there, the presentation is
Okay, you are in the first one. Okay.
and
And I have to download Dagmar's presentation. I think she's the second one. Okay. Dagmar, okay. So
That's the hard requirement. That's what it's the story of it.
the one by Dagmar.
Then that should be good. But often it's either the case,
Sean.
and then you have to. Yeah, something that really stands out or speaks, I guess, an expressive output that's really significant. I don't know if it's always true, but at least that's the part. Yeah, it's showable. Yeah. Yeah, I guess it's a good word. But yeah, I always notice. It's hard to know these.
Did you see an attachment?
Ordinary,
Maybe you forgot that.
people around see the things in the same way. You're like, okay, this is right to do.
Yeah, the slides are not here.
Yeah. But it's also a new thing that
There's a lot of
mind design. The PhDs now. So
In part of the reason why I got here is to try to put together a PhD.
Yes.
I don't know.
yeah, but that's it. It's kind of being made up right now. So yeah, I think it's the school lectures that probably has to enter that way, and then you find out.
I don't know. You can send it on Discord, and I will forward it to my email.
Yeah. But also because you have, I don't know.
But yeah, maybe we can have a conversation.
Sharing and then I don't know. Do you want to bring your remote control? That's also a wireless mouse. It's like yeah, you can even use that mouse to watch. I don't know if you can talk to the microphone myself. Yeah, probably. There's yeah, you can see what this one, and I think for something so you use this mic for the room. This one is for Zoom.
Okay, so I'm speaking in this one.
Yeah, if you sit in this chair, I think you're fine.
Okay, and if I want to stay down, like,
maybe you can use this mic, and the sound from the AV system will go through this, but people won't see you through the.
okay,
Okay, so yeah, maybe you can stand over there.
I'm sitting.
If you want to stand, yeah, stand in front of the TV. Maybe we can check the position. So if you stand right here. Yeah, right in the back.
Yeah, no, I'm almost up. You can go back.
And then
it's not comfortable. I'm just sitting.
in any case, if you're also showing the slides, your window will be very small, so
Yeah.
doesn't matter that much.
Oh,
I don't know why.
can I just extend it?
Yeah, whatever you wish.
Okay. Yeah. I know. It's fine anyway. Just walking.
Okay, hello everyone, sorry for the delay. So this is the DNA session. I'll be sharing with Enchanti, which Diana predicted, and let's just start directly. So the first paper is by John Baptiste, which is automated ISO-based computation for Minecraft.
Oh no, yeah. Can you hear me right now? Okay. Okay, and so people also can hear me.
Okay, cool.
Sorry about it. Okay, I'm Jean Baptiste, and today I'm presenting my latest paper that I co-wrote with my supervisor, Dr. Sander, which is somewhere in the university. And it's called Automated Isolation Computation for Minecraft. So last year, first a brief summary of how the presentation is going to be. So I will go through our previous paper and how we started investigating the whole isolate thing. Then I will introduce you all to the space syntax and isolate theory. And then I will go through our experiment we did with this new theory and the results that we got out of it. Last year we presented at FDG another paper which was about comparing PCG metrics with human evaluation in Minecraft. And we were basically testing common PCG metrics against Minecraft settlement and see how well these metrics were performing and how easy it was to translate it. So in order to do so, we use this data set we got from the DDMC competition. I'm going to briefly go into the competition. It's basically a competition where people send us generators that create Minecraft settlement. We run them on unknown maps. And then we have human judges that rate those settlement according to 4 criteria, so aesthetic, narrative, functionality, and adaptivity. So we have plenty of those settlements, plenty of those generators, and so we decide, hey, we have like a large range of generators that have been humanly measured on a wide range of criteria. Let's see if there is some correlation well-established PCG metrics and those human-rated. And so the results were a bit mixed. So the major takeout we had from this previous study was so the most performing metrics were domain-based metrics that were well acknowledged in the Minecraft domain. Also, the counting-based metrics were performing, I mean, the metrics counting recurrence or occurrence of elements in the level were kind of okay, while the layer-based metrics that try to capture the structure of the level were failing. And also, we had quite a struggle to turn this metric into the Minecraft domain. So after this, we decided to went out there trying to find and establish new metrics that match our own requirements. So first of all, like capturing the player experience, regardless of the dimension. So it could be narrative, could be aesthetic, whatever. And also metrics that are not domain-based that we could use in any kind of level in any 3D video games. And so while looking out there and talking about it with other members of our labs, we discovered space syntax. So space syntax is a theory coming from the architecture field, which is well established in that field. And it's basically looking at how different spaces, so a space can be a street, can be a neighborhood, can be a room in a house, how those spaces are connected and how that connection establish some sort of, a graph that can be then integrated. And so in those domain architecture algorithm, there's several research that establish like human and social behavior based on those relations. So using space syntax, you can predict which street in your town is having the highest rate in community rate. And also, if you drop some people in a building they don't know, you can kind of predict where they will go first if you give them a random task. So all of this was very fascinating. It was perfect for us, so we decided to implement that into Minecraft. And we failed. The main reason being, like, as you can see on the left side of the slide, it worked very well in 2D. It's very easy to implement because, like, you can just establish the layout of the room and extract your graph and then run your analysis. But in Minecraft, in 3D, we were all around trying to figure out, okay, how do we establish what is a surface, what is a place, what is a space. For instance, the blue roof in the middle of the right screenshot. So it's technically one single space you can traverse without a fall, but also when you're on one side of the roof, you consider the side. So it was getting very tricky, and that's where we tried to refine a bit what we were looking for, and we focused on the isolate map of these two blocks, that is space syntax and the isolate theory in general. So isolate is a subset that is used in space syntax, but it's its own theory at the same time. An isolate being a point in space, what can you see from that point? And the isolate is the whole field of view. So in terms of implementation, it was very straightforward, even in 3D. So we were very happy with that. Even if it's very power consuming because you have to do a lot of recasts and so on. Also, it's locally based in the sense that with space syntax, you look at one space as a whole. So a single room, even if it's huge, you treat that as one entity, while isolate, you can define your own resolution and work like that. And doing so, it offers a way better precision. So what is an isolate? How do we establish what is an isolate? So an isolate is basically composed of three components, four technically. The centroid, which is the little black dot you can see on the three figures, which is from where you're casting your rays. The perimeter, which is like all the surface blocking your field of view and terminating it. But it can also be, as you see on the third figure, it's the end of your environment. The area, which is the surface covered by your isolate. So here's the gray area. And the radials, which are basically what we would refer to as ray in computer science. So basically, each end of radial, each point terminating a radial is part of your perimeter. So even if this theory has been mostly applied in 2D, we were able to port it into 3D very easily. So here you have one of the first examples that we had. And as you can see here, all the visible blocks are turned into black. So, I mean, that was one of our debugging methods. And yeah, with a few optimizations, we were able to compute a large number of them without any trouble. So we established a bunch of metrics based on this. So either this comes with its own range of metrics, and so which are all defined by the same constant, so the area, the perimeter, and so on. We turn most of these metrics into 3D based metrics. I'm not going to go through the whole list here. You can go in the paper if you want to have the mathematical explanation of all of this. I just want to point out that our diversity metric is the only domain-based metric. So basically, it's whenever we array touch a block, we capture the block type it is, and then we use that to compute how many different blocks the user can see at a specific location. And also, since we are working in 3D, the concept of area is not exactly the same. So we are not computing the volume because it's not something commonly used on iris, and in our view, it would be a lot of empty blocks there. But what we're doing is we are using all this position where a player could stand as part of the area. The twist being, like, if you are, for instance, have a fence that is blocking the block behind it, this is not part of your field of view, and so we exclude it from the area. So what is the experiment that we ran? So last year in 2021, we got like 20 entries in our, no, sorry, so yes, we used 10 generators from the last year of the competition, 2021. Both were run on 2 maps that were then judged by the judge. So we used that as an entry point, and then we extracted 1 out of 10 locations here because, so as I said, iris are quite intense in terms of computation. So we couldn't, like some maps, we could have computed up to 100,000 points, I guess, which was quite a lot. So yeah, here we just picked 1 block out of 10, but not fully randomly. You can go on the paper to have a look at that. I'm running out of time. So first, with the results that we got, the data that was extracted, we rerun the same experiment that last year, so trying to establish correlation with the judges' score. And what we observe is, again, our domain-based matrix is the one that is performing the best. So too bad, I guess. But also, we also were able to see that we have 2 metrics here, perimeter and openness, that are very layer-based, that are capturing, that seems to capture some part of the sediment. But again, isolists are very locally defined, and at the same time, we are computing some sort of average and can bring that to a score, so to a score that scores the global entirety of the sediment. So we were not super happy with that. So we ran for the test. First of all, we acknowledge that for a given sediment, we have very characteristic values of isolate. So that was very encouraging to begin with. It means like there is something happening. Isolates are characterized by the environment. And also we had a look at our raw data set, and we extracted some of the experiment on some maps, and we were figuring out that some values are actually capturing features of the level design. So here's you can't see it. Too bad. I guess, so basically we have like low openness isolist led to very close corridor where the player are very little freedom of movement, and creates this like a kind of claustrophobic atmosphere. And same with mean value, when the variance of the radial is not very huge, like we have like this sense of emptiness and everything. I can show you that later. Another experiment that we run is, sorry about that, is we computed ISIS as a way higher resolution on 2 of the base maps, so namely the maps that won the competition last year, and also the map that was ranked as the most beautiful one. And so we compute ISIS as a rate of 1 out of 2. And we established a heat map, as you can see. And what we saw there, and what's very interesting is some of the matrix were capturing some features of the environment. So as you can see, for instance, if you look through the perimeter, seeing on the very top one, with the bare map without any construction, you can see that different Minecraft biomes end up having different parameters, and the same goes with some of the other figures we are detailing this in the paper too. This tagging, yeah. In conclusion, so we did some encouraging findings. So some of those metrics, even if now currently they are not having groundbreaking correlation, we are pretty confident in the idea that with fine-tuning we could have some automated way to obtain better results. It's a new way to actually capture local features that previous metrics were focusing on more of, I mean, some of them were focusing on the entirety of the artifact and not like some specific point. And then we also have started this discussion of, okay, if we were to establish an explicit range analysis of these metrics, how we would do that, because computing an average for one of this level doesn't make any sense. So you want to capture some local features here. So we have started to discuss how we could represent like an artifact based on its local feature and not the entirety of the artifact. And also we are planning to do some empirical tests with humans, giving us feedback on certain location based on their as features. Okay, I rushed through this. I thought I would take way more time. But so then you have plenty of time for questions.
Any questions? Let's also need to check the Zoom.
Nice talk, thank you. I was wondering, these metrics that you're showing, can you use them only to analyze the settlements afterwards, or can you also use them to like have the generation process to avoid generating that?
That's exactly what we are looking for, actually. So far we are still just using that as the evaluation process. And once we will be happy with the metrics, one of our goals is, okay, now that we have like desired values, can we use that to drive the generation process? In the case of Isobis, it gets a bit tricky because, as I say, they are a bit time-consuming in terms of computation. So integrating them into a real-time pipeline might be tricky, but yeah, that's the direction we are aiming for, absolutely.
Another question?
Nothing in the chat. No, I have a mic. It's not working.
You can hear me, that's fine.
No, but then there's no, so that's for the Zoom only.
Let's see, in nature, the repetitions of patterns that are persist over several scales.
Mm-hmm.
You make very clearly this is out and there are those going to be and so on. And I know they have metrics for this sort of it's not like fractal kind of metrics, but they exist. Did you look into that?
Into pattern? Yes.
Oh, yes.
I mean, do we look at the existence of theories regarding patterns, or look for patterns into the data that we extracted?
Yes, and use that as a way of localizing.
Yeah, so we try to do that a bit, especially we try to, using the data that we extracted, can we compute a heuristic that is able to tell us are we inside of a building or not, for instance. So answer will be we don't have a very high precision rate for this task only right now. And the same goes for the other side. But it's also something that we are interested in and could be a really cool use case for this new approach. And yeah, absolutely, that's something that we are considering. And that ties exactly with the previous question. Then, for instance, if you want to avoid some sort of pattern, if we have like a way to compute the occurrence of those patterns using those data, that's exactly what we are aiming for.
So, because we are a little bit late, so we need to go to the next speaker. So, thank you, John. So, next speaker is Dagmar. Sketch between video to video synthesis from Spark animation and sketches. Also, there is a chocolate for the speakers. It's not this chocolate.
Yes. So. Is it better if I use the mic or no?
It's better just for
people here? Okay.
Do you want comments?
Yes, I do.
You know why?
I think I know what they're going to do.
Okay, if you know so.
There you go. Welcome, thanks for attending everyone. I want to present the work Sketch Between, Video to Video Synthesis for Sprite Generation, which is a work by me and my supervisor Matthew Gutstyle at the University of Alberta. So games come in many, many different forms, and one of those forms is the classic 2D game. So we've seen 3D kind of rise into the spotlight, but 2D games are still as alive and beloved as ever. And for a lot of 2D games, 2D sprite animation is a way to breathe life into the mechanics of those games, to help players feel connected to the world and characters, and to create a satisfying experience visually for people to enjoy. However, unfortunately, single animation can take several hours to do. You can see the slide wall. So this is what my animation process looks like. So this is what I do, but workflows can vary. However, this is a fairly standard approach, I just wanted to say. So you start by putting down keyframes, and the keyframes define the action. And then to create the illusion of motion, you add in-betweens. Next steps are to clean it all up, lay down flats and shading, and voila. The frog jumps, your little character bounces, and the blue hedgehog runs. So we've been doing animation for a really long time. We've always liked it, but it's always been super hard work. It's been time-consuming and tedious. But throughout time, we have developed tools and kind of shortcuts to really help us make this process easier and to give more people access to telling the stories that they want to tell through this medium. Recently, we have seen some tools leverage machine learning, and I want to talk about two of them. But the kind of problem that I have is that they don't really adhere to workflows that animators tend to use. So I want to kind of highlight two groups of existing methods very briefly. One group uses previous frames to predict future frames. And that's a very cool thing to do, but for an animator, it's not super useful because it takes away a little bit of that creative control because you're not really defining the action or motion, you're kind of letting the model decide what happens after your frames. And another issue is that you do still have to fully render a bunch of very similar frames in a row. So another very cool method takes a driving video or a driving animation and takes the motion from that and transfers it onto a source image. So this is done using key point detection on both of these images, and then how those key points move in the driving video is transferred onto the source image. Very cool. But as an animator, if I wanted to use this, I would need a driving video in the exact motion that I wanted, in a style that can use the same key point detector as what I want to do. So that's not necessarily ideal. So we can move on now to what our contribution actually is. So firstly, we want to propose a problem formulation that more adheres to this standard animation workflow that I was talking about earlier. So we propose a method where you still have to sketch and render the keyframes, but then for the in-betweens, where you're kind of adding this illusion of motion to your art, you only have to do the sketches, and we propose that you should be able to then render them based on the information from the rendered keyframes. This formulation allows you to shave off some of the more tedious and time-consuming parts of animation while still retaining a great deal of creative control. So to do this, we use the MGIF dataset, which is a dataset of animations of creatures performing actions, namely walking, running, and jumping. The animations are of a lot of different kinds of creatures. They have varying styles, and they all have different lengths, which actually is a little bit of a problem for us. So our first pre-processing step was to take every 5 adjacent frames in an animation and create one data point from those 5 adjacent frames, like so. All right, we ran into another problem though. So the MGIF dataset only includes fully rendered animations. And what we want to do is only have artists sketch the 3 frames, right? So we really need a data set where sketches are also included, and that's not the case here. So we compensate for this by generating the sketches in between to get some kind of approximation between the sketches using canny edge detection. All right, so we have our input here defined, we have our desired output, and now the problem is to kind of figure out how to get from A to B. So what we need is some kind of generative model that can really represent complex data distribution for images. But we also needed to have some kind of idea of a temporal component, right? Because we have 5 frames in a specific order, as opposed to like a single image. And what we decided to go with is the vector quantized variational autoencoder. So traditionally, this doesn't necessarily have a temporal component, but we thought the simplest solution here is to just kind of squish the images together, stack them into like a 3D image, where the dimensions are now X, Y, and time. So since we're a bit late on time, I'm going to do a very brief explanation of how VQAEs work, just to kind of give you an intuition. So we have our 3D image, and it goes through an encoder. The encoder's job is to kind of compress the data that's in the image as much as it possibly can into a very small representation. So we're going from a pixel in pixel space having red, green, and blue values to instead this much smaller thing where instead of having red, green, and blue, we have 8 values that describe a chunk of the image and not just a single pixel. And that, the next step in the VQAE is then to take all of those vectors that describe chunks and actually replace them with vectors in a learned codebook. So this allows us to discretize the space. And then those vectors go into the decoder. And the decoder essentially does kind of the opposite of the encoder. So it takes this very dense information-rich representation of our animation, and it's trained to output the fully rendered thing. Both the encoder and decoder are convolutional networks, and there are implementation details available in the paper if you're curious, as well as available open source code. All right, so to evaluate our system, we perform 3 experiments. Firstly, we compare our system to a baseline to see whether the QBAE is performing the suggested task well. And then we perform an ablation study where we see if all components of the formulation are necessary in order to kind of get what we want. And then finally, we do a little case study to see how well our system handles real life data. All right, so since we suggested a new kind of problem formulation, it's very difficult for us to find something to compare to, right? So we kind of had to rack our brains a bit and come up with some way to still get an idea of whether our system is doing something. So we decided to take the key point-based methods, namely one called the first order motion model by Alexander Chavin et al., and adapt it a little bit so it is a bit more comparable to our situation. So we retrained their model on a data set that contains both the rendered animations and all the animations as sketches. So we kind of overcome the problem of needing a key point detector that works on both. So this is something that we feel we can comfortably compare our model to, and we decide to use this as a baseline where we transfer the motion from a sketch animation onto a rendered first frame using the first order motion model. Now, for our quantitative evaluation, we decided to use 2 metrics. The first one is the peak signal to noise ratio, which is basically just a measure of how much noise is present in a reconstructed image. This is a tried and true metric for image reconstruction, so we thought it was appropriate to include, but we also decided to include the structural similarity index metric, which is more new, and it kind of compensates for some of the problems with the PSNR. Namely that it better compensates and evaluates certain types of distortions, namely, and very importantly to us, blurring. So for both of these metrics, a higher number is better, and you can see on the table that our model does outperform the baseline. Visually, I also want to just talk about some of the differences in the kind of artifacts that the models create. So both of them have kind of visual disturbances or visual artifacts present in the animations, but the baseline kind of struggles with these dynamic soft body elements, such as, for example, a horse's mane having different numbers of locks showing to kind of give the illusion of flowing hair in the wind, or the cat's tail changing shape kind of drastically to give this feeling of a release of tension. So the baseline model struggles a bit there because it's really only transferring motion and it doesn't really have a good way of dealing with these sorts of situations. All right, next we did an ablation study, where since we're kind of suggesting this as a formulation, you kind of have to ask yourself, does every part of it make sense? And we decided to train models using the same structure with different inputs. So basically we wanted to check, are the sketches really necessary? And is the second keyframe really necessary? So I want to talk about that a little bit. In short, yes, both do add valuable context to the problem. However, the final keyframe is much less valuable than the sketches. And there are absolutely situations where an artist might not need to do the second render, but I also want to talk about some situations where it is pretty important that it does happen. So if you imagine occlusion of a body part, for example, in the first frame, but then it's revealed in the second or the last keyframe, if you don't define that by rendering, like define what colors it is, by rendering the final keyframe, you lose a little bit of that creative control. And if you are, for example, making a lot of sprites of the same character, you might want them to be fairly consistent. So there is still value in the second keyframe, but definitely worth leaving out for some people. All right, and since our model is trained using these kind of generated sketches, but the ideal situation for us is that actual people, actual human animators get to use it, we thought there was some value in doing a case study even if it's small. So we gathered a bunch of our animator pals and we asked them to draw a quick 5-frame animation where they fully rendered their first and final keyframes, but then like leave the in-betweens still in their sketch form. And So this is what that looked like. So there's a couple of things that I want to talk about here. Namely, first, these sketches are notably different from what we are generating. This is a small sample size, of course, but you can kind of notice still that the artists, at least the ones that we talk to, don't really tend to include patterns in their sketches, which can edge detection, being an edge detection algorithm, tends to do. So the model compensates, in some cases, fairly well. We can still notice that the edges of the patterns are a little bit blurry. And secondly, this also helped us to realize that our model is fairly biased to frame rate of animations. So a lot of the animations in the end of data set have a high frame rate. And what that means is that, okay, it's like, sorry, Zoom. All right. Should I wait or should I keep going?
We should wait. There's people on the Zoom.
Oh no, Zoom friends.
Just... Sorry.
Yeah, I wonder if they're gonna rejoin or no. Do we want to post the Zoom link or?
Yeah.
Okay, I'll wait for kind of a go-ahead maybe. So should I keep going? Okay. All right, so yeah, so our model is sensitive to the frame rate. And as I was saying, a lot of the animations in the MBIF data set have a high frame rate. And what that means is that they use a lot of pictures, a lot of frames to describe, smaller motions. Oh god, okay. Animation. Okay. Yes, so they use a lot of frames to describe small motion, and that's fine, but there are also artists who don't necessarily do that, and there are situations where that's not what we want to do. And we noticed that our model is kind of weak to that, because that's what happened with some of the animations that we got. Like this bunny doing an entire jump in just 5 frames is atypical for our data set. So that's definitely a weakness that could be improved in further versions. All right, so to just summarize the experiments and the results of them, our model does outperform the baseline of the first order motion model. And the ablation study shows that all of our components do add value, but there are situations where you might be okay skipping out on the last keyframe. And the results of the case study show that our model does kind of compensate okay, it does all right, but there are definitely ways that you can take this in the future to make it do even better. And as takeaway, I want to highlight kind of a little bit of a summary. So we've suggested a problem formulation for sprite animation generation. We have produced a QBAE that does this problem fairly well. And we've identified a lot of very fun ways that we or someone else could take this kind of research in order to democratize one of the big parts of 2D game development, which is 2D sprite animation. All right, so if we have any time, I'm happy to take questions, or if you think anything later, my email and Twitter are here. I'm also about to finish my master's and looking into PhDs, so if anyone's into like fun generative art stuff, I'm very open to talk.
Hello, thank you, that was great work. I have a meta question, but definitely into funding PhD student for generative system. One remark and one question. The remark is your frame rate problem doesn't seem to be a problem because it would be easy to augment your data set by cutting frames in the data set and having a model and knowing those high frame And my question is, did you play with the latest flexibility to see if you can allow for variations on what the system generates around what the system the way itself?
So this is definitely something that is very possible to do with a VQAE, and would be a very fun kind of avenue to take this to see what kinds of things, the VQA is learned to do and kind of explore the latent space. I haven't done it, but I think it would be very fun. Yeah.
Any more questions?
Maybe you mentioned a bit of this in the augmentation, but you try to, for example, change the sketching parts to make variations in the data sets, to have like many different ways of sketching. For example, this.
So actually, yes, I did do this in a very early version of this. I was working with exclusively pixel art. That's actually kind of how I ended up doing a VQA, as opposed to just a VA, because there's a paper coming out by my lab member in NSAC that shows that VQA is really good for pixel art. And we had a bunch of different sketch styles because the pixel art was scaled differently. I did take it out for this version just to kind of speed up convergence. I wonder why I didn't try it with this as well. I think it would be really interesting to improve the model again. Thank you.
Okay, one last question.
Did you ask the artists what they thought about the generated images? I'm curious what they said, like if they feel that it's ready for use and would help them.
Yeah, so I did, of course, show my artist friends what their generated art looked like. I think it would be mean not to. So if we go back to that slide, actually, my friend Fishy, who drew the fish with the cookie in its mouth and human legs, turned this into a Discord emote. So I mean, there's definitely some use for this already in its current state. Yeah.
So thank you, Edward. Now we're going to go to the next speaker, Michael, next initiative story, co-creation with healing.
Oh. Awesome. I will make sure that you're actually sharing screen because in the last one actually screen two. Okay. So, hi everyone. Welcome to our presentation. Like I've mentioned, this initiative Historical Creation with Telmaker. I am Michael Bueno, and I will be presenting on behalf of myself and my co-author Rafael Vidal, who is also here in the audience. We are members of the Computer Graphics and Visualization Research Group at Delft University of Technology. So humans are naturally drawn to tell stories, and many storytelling games have been invented as a fun and creative way to create stories together. There are storytelling card games, board games, improvisational games, and even more. Usually in these games, players introduce characters, locations, situations, and/or objects, which then they use to unfold a story. However, these games possess non-trivial creative challenges which, if not properly supported, may hinder and discourage less skilled players, as well as impair the quality of the story. Also, most of the stories are not stored anywhere, and with time, they are forgotten by the players. We argue that keeping them is important from both a cultural and a research perspective. To address these challenges, we designed a digital game called Tale Maker, a competitive and collaborative multiplayer online game that follows a mixed initiative approach which allows a group of players to co-create a story in turns, one sentence at a time, and where stories are not forgotten but instead stored in a database. Our mixed initiative approach focuses on providing creative assistance, allowing players creativity, and encouraging collaboration and competition between players. The core aspect of our approach lies in a hand generation method that provides a selection of words as tokens that might be of interest to the player and which also serve the story. And during each turn of the game, players collect tokens served by the hand generator and then use them to compose a sentence that might convince other players that it belongs in the story. All sentences are submitted for a voting round in which players vote for each other's sentences, and the most popular sentence is appended to the story and its author is rewarded. And this is the essence of each turn of the game, which is repeated over and over again until players decide to end the story. So the game is played by 2 to 8 players. Each player uses a separate mobile or PC version of Tale Maker while connected to the game server. And then they go through the 8 phases of the game loop to incrementally co-create a story. And I will explain the phases of the game now. The first phase involves creating a story prompt, in which a player is randomly chosen to introduce 2 characters and a location, for example, a parrot and a parrot in this case. The same thing applies for the location, in this case an island. After that, the players have to develop the story centered around these elements. A turn of the game starts with players selecting 3 piles, which are specific categories of tokens. Then, the hand generator determines the tokens that each player gets from their selected piles. Players have to decide which tokens to keep in their collected hand and which tokens to discard. Players use those tokens to compose a sentence, which also involves their available characters and other pre-included tokens of the game. For example, in this case, prepositions as well. During the 5th phase, players anonymously vote for other players' sentences, and the sentence with the most votes gets appended to the story. It becomes the next sentence of the story. During the 6th phase, players are encouraged to keep making great contributions to the stories by receiving rewards. Gold is for every vote received, and a diamond is for their sentence being selected for the story. The 7th phase is when players are asked whether they want to change location, which includes adding 2 new characters, and they also can decide to end the story or continue in the current location. If players decide to end the story, they must suggest a title. Players submit their titles to a final voting round, and the winning title is displayed above the story, following the same pattern as with the sentences. So, in Tale Maker, the final story is composed of the sequence of sentences that were added after each turn of the game. It includes the title that is chosen at the end of the game, and where in each sentence we have the sequence of tokens that were arranged by the players. The sentences also have a location associated to it, and the sentence must have at least 1 character and an action. So we encourage an active sentence instead of a passive. They cannot have more than 1 verb. In the game, players interact with tokens to create their sentences, which from the perspective of a player, a token is simply a word. However, internally, tokens are associated with a synset in wordlets, which allows us to equip a token with an illustration, a word, and a description. And also, this allows us to equip a token with a corresponding category or part of speech, which is the file indication of a token. Players can use this information to ensure that the meaning of a token corresponds with what they are trying to convey in their sentences, as well as to better understand the sentences of others. Also, internally, synths are associated to a vector within an embedding that encodes contextual associations between synths. This embedding is a product of our prior work, and basically is what our hand generator method uses to compute new tokens. And I'm going to show how we do it. So now that we know the important features of Tailmaker, I will describe how we serve tokens to players through our hand generation method. So in the token collection phase, players receive tokens from their chosen files. We call these the served hand. These tokens are selected by the hand generator for each player. Then players can choose some tokens and keep them in their collected hand. The served hand, the hand above, is constructed iteratively by randomly choosing a bag and sampling a token from it. These bags are what we call in the paper bags of rank tokens. Each bag contains an ordered list of tokens that are ranked differently. And the probability of sampling a given token depends on the ranking position within the bag, with the top ranked tokens most likely to be selected. This allows players to not receive a similar hand of tokens. And when sampling from a specific pile of tokens, we simply filter the bags to only sample tokens from that category. So we design each of these bags with a different purpose in mind, with the idea that each bag will benefit the story and players' creativity in distinct ways. In the related bag, we have tokens that are ranked by their relatedness to other tokens in the story. For this, we use the synset vectors of tokens, and we compute the cosine related scores of all tokens to the sentences in the story. This bag allows players to receive tokens that keep context of the story consistent. For example, an island is typically associated to tokens such as coconut, swing, sand, shipwreck, and so on. In the history bag, we extract the tokens that are already appearing in the story, and we rank them by their relatedness to the story calculated from the related bag. This allows players to stay on topic with the story. For example, a treasure map might be convenient to operate against so that players can further develop the story with it. In the player bag, tokens are ranked by their predicted relevance to each individual player. We do this by using a relevance feedback technique in which we assign a score if a token was discarded, collected, or used in a sentence. Then we use the synset vectors of those tokens to feed a model, which then we use to predict the relevant scores of all the tokens in the game. So this bag aims at supporting players' creativity and planning. For instance, a player planning a love story might collect tokens such as love and kiss, and the same player might wish to receive other tokens such as hug, gift, date, and so on. In the group bag, tokens are ranked according to the predicted relevance to the whole group. This is done similarly to the player bag, but instead we use the number of votes received by the sentence as the relevant score of each token in the sentence. This bag is meant to encourage players to consider the previous contributions of others. And finally, the random bag includes all possible tokens, which are simply sampled at random. So tokens obtained from this bag are meant to stimulate players to think creatively about unrelated tokens, possibly coming up with new associations or story directions. Experiments. The main focus of our experiments was to study the influence of our mixed initiative method on players' choices. The players' choices that we were interested in were collecting a token from a specific bag, using a token in a sentence once collected, and discarding the token once collected. We also were interested on the perceived story quality of the stories made with Tailmaker and some important game aspects. Our hypothesis was that players tend to collect more tokens from the specialized bags, the history-related player and group bag, than those randomly selected from the random bag. We argue that validating this hypothesis can confirm that our method provides players with tokens perceived to be more valuable for the story than those obtained by random sampling. Our experiment had a simple design with several game sessions in an online and casual environment. First, a single turn was played for players to familiarize with the game mechanics, and we stored players' choices throughout the game. So in total, we had 22 participants from diverse backgrounds, 11 groups varying from 2 to 6 players, and we collected 11 co-created stories. After each game, players received in-game questionnaires. One was for evaluating the perceived story quality, to measure different qualities of a story, with answers given on a 5-point Likert scale. Also, another questionnaire was used to evaluate aspects of the game. So after the experiment, we found that players are more likely to collect tokens that have previously appeared in the story, those of the history bag, followed by the related bag and the player bag. You can see this stair shape here. This is the history bag, the related bag, player bag, and group bag. These findings partially support our hypothesis that player prefers tokens from our specialized bags. However, players collected tokens from the group bag about as the same as from the random bag. This might indicate that players have a preference for their own envisioned story direction, rather than for considering other players' attempted direction. We also found that once tokens are collected in players' hand, tokens from each bag are equally likely to be used. This may be explained by the fact that players are maintaining their own collection of tokens, so most tokens that they keep are those that they are actually planning to use. For the choice of discarding tokens, it appears that tokens from the history bag are less likely to be discarded once they have been collected, while from the other bags they are equally likely. Moreover, the sentences selected to be part of the story have tokens that were mostly collected from the related bag, most likely because players were more interested in creating sentences that kept the context of the story consistent. And with respect to the perceived story quality of the stories created with Telmaker, in general, players consider the stories to be of good quality, and in average, stories got a score of 4 on a Likert scale. We found that stories in Telmaker were in general a bit less true to life and emotional, I guess because it's a game. In general, players enjoy creating a story with Telmaker. Also, the game was considered fair, which highlights the strength of our voting system that enables players to create a better story. Additionally, given the competitive nature of the game and its ability to support collaborative play, rewards were helpful for some other players, but not for everyone. In average, players found it easy to construct sentences with the served force, confirming the effectiveness of our mixed initiative method for supporting players' creativity. And I'm almost done. At discussion, we observed that players were positively engaged when co-creating a story with Telmaker. However, there are some future improvements. For example, the scene set vectors used by our hand generation method were learned on a specific corpus of photo captions, which may have its own shortcomings and biases that could potentially be transferred to player stories. It is therefore worthwhile to explore other scene set vectors learned on other corpora and evaluate their potential for improving the story co-creation process with Telmaker. Also, we would benefit of increasing the game space and allowing for more efficient flow through its phases. This would enable conducting more elaborate experimental designs. Currently, more or less, the game session lasted from 1 to 3 hours, so it's a long time. We also think that it is important to put in place appropriate moderation so that stories do not feature offensive or inappropriate content. And just to wrap up, what I presented in this presentation, a novel mixed initiative approach that addresses challenges commonly encountered in traditional digital storytelling games. We demonstrated this approach with Telmaker, an online multiplayer game that allows a group of players to playfully co-create an open-ended story. We also introduced our hand generation method, which selects tokens in a way to strike a balance between supporting players' creativity, maintaining story quality, and ensuring the competitive nature of the game. Players reported that they were stimulated for story authoring, and that the perceived Telmaker created stories they perceive the filmmaker created stories of considerable quality. And last, the digital and live nature of filmmaker can easily lead to a steady flow of stories being created, and those stories are freely available to the research community. Thanks for your attention, and if you have any questions, please do not hesitate to ask. I would also like to invite you to play our research prototype at telmaker.ai. Thank you.
Thanks for this. This is really exciting work, so I'm very happy that you presented it. I wanted to touch on maybe this is a scientific question, the tokens, the bags that you use. One thing that is missing, I feel, is your lateral thinking, so some sort of novelty mechanic that is actually contextually relevant. So random is random, right? But anthems, for example, might be interesting, right? You might want your story to have, if you have a knight in your story, you might want a wizard or something like that, a castle, or sorry, that's but beyond the anthem, right? Not policeman. So, are you thinking of using that as another dimension? No.
I was thinking a lot about you when I was thinking about lateral thinking because of your papers. You talk about that. So it's like having negative examples. Actually, well, we mostly have what is related, which are positive examples. And this is a very interesting point. I think that would be an interesting back to add as an additional back. One of the things that it's also nice of the application is that we can play a little bit with it. We can maybe add more bags or see what actually helps. And it's also like from a research perspective. We can investigate, and that question is very interesting. What will help lateral thinking, and it's maybe a negative related back. Yeah, cool. Yeah.
Any more questions?
Yeah, really interesting game. Thank you for that presentation. I guess I just couldn't help but reflect as you're talking about all of these sentences with the tokens, and the tokens were so neatly laid out. Where have I seen sentences with tokens before? Large language models. So I was wondering, have you had any thoughts on how you could be engaged in large language models, either sort of the generation side, or it seems like some of these relations among terms might come from the interior, attention layers in some of these large language models as well.
So, just if I understood correctly your question, like if I also try to engage with the natural language models, so
your work across natural language models.
Yeah. Well, I was thinking that also would be interesting to have generative language models. Like if you have a story that is being created by players, like you could also say, okay, what is the next sentences that would make sense to this story? So I also can extract tokens from the language model, so I can use them also to give it to the players, so they more or less also have an extra bag of generative language models, which is very interesting also to apply these flows, the negative related back. But because we use mostly the tokens itself, I would be just extracting what are the essential words from that generative outputs of the language model. Did it answer your question? Or?
Perfect.
Okay, thank you.
Any more questions? Okay, so let's end this session because we are over time and we'll come back at noon. So thank you, Michael.
Thank you. Logged out because just left my login details in the computer. Anyway, I can actually, I found yesterday that I can, oh yeah. Wait. Why nobody can take it?
I don't know.
I don't. Why? If I can.
You can come back later. Let's see.
Yeah, don't worry about it.
This is dark, not so dark.
Dark.
And this meeting is running within 14 minutes. Almost. That meeting, I should start it. But this meeting doesn't have anyone, which means it might be the wrong meeting.
It's the wrong one.
So it ended when the position started.
Yeah, I saw when I kind of crashed.
And then I just say if you want to start. But then no one joined.
No one joined.
Again, and at the same time I couldn't rejoin. So I didn't know what's happening. So if
you want me to try to join?
Yeah, try it again, because maybe I have the wrong link.
Just to see.
Yeah, it's
from one, right?
Yeah, so this is doesn't work from the website. Did they send us one email? The hosting is in. So I don't know if they started wrong or something at the beginning, and this will end in like
before the next session.
Yeah. Don't end in the next session. I don't want to restart and start again. Restart instead of
yeah.
Let's end it anyway because no one is joining this one. I just
So that's what I did. Room 1 on the start. Try to join again. It's just like I don't know what to do right now.
You try to join from the. No, it's you try to join from the website instead of from.
But like, okay, let's try that. But then why is it calling the FDG Room 1? So, can you try that? Because in the email, it seems like it's also, and it's like, maybe it's update the one of those guys. Right? This one there. Yeah, because I try to do stuff and try to. It's not. It's like oh,
So it's wrong.
What does the heck happen? Okay,
We're not the actual
oh, yeah, we know it works. Like, how does the heck happen? Okay, don't know anymore. And the problem is the next session has
the next session
have one online. Because the update system online. And I don't know if you can do it. Yeah, so if I know. I don't know. I tried to find it.
What's the difference between the
Yeah,
you see, if you see here it's like 0, 1, 0, here it's 1.
Okay, so not to take all the time from the process, we need to have them set up. I need to talk to online. Yeah, sure.
Let's put it here.
Yeah. It's not like a sheet. So if there's viruses, it's fine. I can do whatever. Do whatever you want.
Where's the folder? Is there a folder for it?
They didn't. That's out. So just like do it on the desktop. That was a panel. I didn't do anything. Just kind of went over time. The website. No one is showing Zoom. Can't find them. What else is?
Can you put the action?
I'm gonna do that. But I got an announcement. I'm gonna come.
Okay.
Can you send me the Zoom link from the email to Facebook or anything so I can send it from my Discord? There is no Discord.
Somewhere?
Design the website.
You designed it, but it doesn't. Okay. Yeah. I got it.
We have updated that.
Oh, okay, I just read it wrong. Okay.
Updated. So these are in
but it seems to be
Oh, yeah.
yeah, so this
You can ask Sam that.
is the hand.
Yeah, I have Discord.
Okay. Because I wrote to Discord Sam and like that Sam.
Okay.
It's not fun.
Sam don't mind, and he's not, right?
yeah, I'll stay here. But it's about you were finishing. No, I've been looking sort of for 3 days. It's true for the last 5 6 years. But I'm also going to be 3 years ago, I started my as well. A lot of my work on extraordinary methods and more you see, actually, yeah. There is this
Right. So you want me to, I got it, I'm sending a message to Sam. That was, I can get Mark. Okay.
That's the
Yeah.
or even just this tries to you come up with
Yeah.
oh, yes.
Oh, you want to go?
Are we starting?
No, we have to start.
Okay. I know we're stuck in nature, and I'm here a week right now. Yeah, exactly, that was the problem, like, that's not fair, it's not, this is me, all me. Oh, okay, good. I got my sleep unintentionally.
You see the sunglasses? Good luck. Where we are.
Sorry, the next session?
Yes. Oh, it's the same session. Yeah. Well, awkward, yeah. Let's see.
Do you want to take over or something?
I'm good. Thank you, though.
Jesus Christ.
Can you shout into them?
Yes.
What was that?
Maybe the mic from upstairs.
Is it turned off?
Okay. So this is a Pro version. So
Yeah, it was in the middle of like the second speaker. It's like 40 minutes. I don't know why.
So it's not my personal room. But in any case, this is a Pro.
Yeah, I know it shouldn't be there.
Yeah.
It just took my name. How's it going?
And this is the correct room.
You can go down to the hold it, it would be like all in. Yes. All out. All out. Okay. Alright. Let's practice it. Okay, so this is what terminates that room.
Should I
is there a way to know this like through like options of room?
No, I mean, you can see here, the duration is, for duration, okay. Hopefully it won't happen again. Yeah, okay, I'll stick around anyway, because the other room is finished. So, I don't know why this happens.
Sorry about that. But like,
no, I'm sorry about that. Yeah. That's why we bought 3 different licenses.
Αυτό το έχει ξεχάσει κάποιος, ήταν πάνω.
Τι είναι αυτό προφανώς.
Για απολογιστή λογικά,
Είναι για απολογιστή, εδώ στα μια κάμερα. Καλά.
Να ρωτήσουμε κάποια στιγμή.
Θα το θέσουμε εδώ.
Ένα Sony Vaio είναι της Command.
Ο υπολογιστής που είναι εκεί αριστερά είναι στο Mac.
Ωραία, εγώ τα πήρα τα άλλα, εντάξει. Απλά αυτό εδώ δεν ξέρω.
Έχεις κλειδώσει τώρα πάνω.
Ναι. Και θες κάτι, θες να αφήσω.
Όχι, δεν θέλω κάτι. Μήπως τα αφήναμε εκεί αν το αναζητήσει κανείς.
Ή το βάζουμε εδώ με τα πράγματά μας.
Εντάξει, ωραία.
Το αφήνω στην τσάντα.
Στην τσάντα του πράξη.
Ωραία, γυρνάω, πάω να αφήσω αυτό.
Δεν καταλαβαίνω αυτό γιατί σταματάει.
Τι έπαθε.
Σταματάει, λέει το stream, ενώ λέει κανονικά 9 με 7.
Μήπως συνέβη πριν, ήταν κάτι προσωρινό. Κάτσε, θα δεις τώρα τι θα γίνει με αυτό το σεκ.
Ναι, έχεις κλειδί, τηλεκοντρόλ και μικρόφωνο. Εντάξει, τέλεια.
I mean, it sounds like you're good.
Goes
We feel I'm like a bit of hundred. It's not perfect. Well,
no, I sort of, it might be sort of like a case of like, there's complex so much wrong with that, it's so much help. It's just like,
I think I don't have a choking reaction anymore. I might have the blue poisoning sucks.
I don't know.
Don't show up. You show for like 20 minutes.
No, everywhere, speakers would be that.
So Alberto just
There's something there.
So stock.
I know Paris is here.
Paris,
I know. So I don't know what you're exactly. Okay, I got some random upstairs. I got some orange juice.
So hi.
It's not the same room.
No, you just had that problem.
One of the speakers is missing. Or
Yeah.
all of the speakers for, there's like 4 offers on paper on the right now.
Yeah, I got my anyone from the next. First, seen him talking next session.
Probably. One of them, Sam Devlin. I saw him at that everything was so cool.
Like, do you know any of them? Besides, Emmy knows them better.
Isn't Mark Ferguson a speaker for
Mark
keynote
Ferguson's
speaker?
name is familiar to you.
I started as a keynote speaker.
Yesterday? No.
No?
Not yesterday. It's
His
like,
name is familiar.
it's the car Simon yesterday. And today is some videos. So that person knows actually like maybe 15 minutes. Over Twitter.
That's so funny.
We talked a lot. We did this talk for the last maybe 5 years, but like
So
I know
funny.
them from a long time ago because they used to write reviews for games on indiegames.com. And because they were doing that, I was doing making games to do features of my games. So I know them.
That's so cute.
But then they are now like urban design for the games. And they have really cool virtual cities with the analysis of virtual cities.
Hence the topic.
Yes, that's right. And for speed. Yes. You have the I never took them. That's good. So you need to find myself. So there's
Get it from my backpack.
Yeah.
Or whatever, and then I'll put them out like.
Thank you.
Exactly. No one. I'm. No one's.
Do we know who's presenting? It was also a session because if you can read changes online, then we need to Discord, because they're not deserving.
Maybe you can send the link.
I sent it to the school, yeah, Discord.
So if they're online, they can see.
But do we know who's gonna present?
No, no idea. I can recognize the names from the meeting. Okay, if they don't show up, give them like 5 or 10 minutes.
Okay,
And proceed with. I don't know if they join. Just make sure you monitor the chat.
Yeah.
Because, yeah,
Yeah,
I have some
I'm-
issues, with people muting this.
Okay.
So remote participants couldn't hear anything.
Okay.
They were so frustrated they asked for response. Which makes sense, of course.
Yeah, it makes sense, like, they could-
So, but, yeah, it was scary.
And is there any like comments or stuff comes up on YouTube?
We haven't actually advertised the.
Okay,
It's
just
mostly there
last
for.
night,
for
like,
recording.
4 a.m. our time. The boys started in the bachelor party.
Okay, because this is the only audience that.
Okay, because it was
Because they didn't know that.
Nothing good came in the last time. It's a madhouse. Bunch of mad lads doing mad things.
I mean, that's how a bachelor works.
Yeah, we went to a bachelor party sometime.
I went to a bachelor party and we went to golf and laser tag and a bar.
It's pretty tame.
That was C.
That was the he's going.
Yeah, run this way.
I'm not gonna eat it or what? Just
I don't know what it is, but it's like after a certain point. It's getting old. So we get out from there. It's just super tired. It's fine. You have a great cortisol, so you're working faster, crazy. That's what I want. That's the best way.
I sent it up in the school.
Yeah.
Just wanted to check.
No.
Make sure. Again. I'm going to show you for
Nice.
Sweet, yellow means in person.
Yes.
Well, that.
I mean,
That's that. Yeah.
So the parents changed it.
Yeah.
Online.
It's not wrong.
What just happened?
Yes.
I have this loaded as a last time.
Yes, they changed. I used to it.
What happened?
I'm saying there's two participants. So I remember that's you at the computer.
Oh.
I was like, I just like, like
You get so excited.
awesome. Are you just getting through this?
What's happening?
There is a chocolate for
Sorry. There's a chocolate on the speakers.
I'll turn on these, so it's not.
It's not this chocolate. Which one is it?
Hot chocolate. The only one that I had in one.
Every other thing came from Becca.
Yeah, I think that's like half of us, like more than half of us, like directly.
Yeah, like everything was asking
You're gonna
yeah, so it's
Like right before.
it's like a nice friend. Also, is are you good with competition? Okay, if you want anything, you have a break.
After like before the summer break. I need to find out how I'm going to transfer I got a stick actually. Like a lot.
So just put using sessions. So just just with
Yeah, the lunch second that's all.
yeah, and like
Yeah, exactly. Thanks.
Do you want to
Yeah, I can do that.
Just saying, if you want to do it.
Yeah, I don't mind.
Remind people that it's chocolate.
Okay.
Only for the speakers, not for the speakers.
Not on the mic, so we don't have a phone number.
No, we won't. No.
Oh, no, I mean, if I say, oh, there's chocolate, and then everybody in the audience. How you doing, son? Are you learning?
Same
I'm not
line.
learning.
I think that this would feel like at some point.
Good.
Last session.
I'm rolling.
It's just first, the stream stopped, and then we forgot to share the screen.
Oh, the screen share, no.
That is share,
Okay.
it's very clear.
Oh, yeah, it wasn't
Yeah, I forgot. But then now you just go from this itself.
Yeah, that must have.
And the first speaker in the next session
It's not here.
nothing. So I think we'll give 5 minutes just waiting. Need something.
Okay.
Otherwise, we just continue. If they join data, so that's why we need to move them. Yeah, just move it. It's very sensitive. So we can just not like that.
How long?
So yeah, like usually I just install it with the same. If you don't know how to pronounce something, you know how to do it. You don't need to see. Exactly. Yeah. I don't think it was not like this here. I know.
For the first session, or the first talk, or
Exactly. So, I know. Symmetry. I don't think that. Paris. But Paris should, one of them should put their presentation on that laptop. On that laptop. Let me talk to Paris.
Okay.
Okay. I will use this.
No.
No, just pretend that. This. Take this. It's dangerous to go home.
Bueno, he's taking it back on. Yeah, what? Yeah. What do you? No, he's taking them, I don't know why, I guess because they need to like clean up the plates, the session, the cockroach ones over there. Okay. So he's presenting online. Oh, hi. No thanks. Hello. Hello.
guys need
Sweet.
That's pretty cool.
Ah.
So I'm stopping the share now. Okay. So that Mark. The only issue is that someone needs to keep the microphone close to the speakers.
Oh.
No, it's not connected. Everything okay, Mark? Mark, can you please speak so we can check the AV here? It seems to be okay. Also, if you want to speak so that the Zoom people can hear you, you use this microphone.
Yes.
Okay. Or is that we can pick up the sound from the AV?
Let's try.
Which one?
Yeah.
So I'm gonna go sit there. Wait, where am I? Okay, thank you.
It's a weird. This one.
So, okay. I talked about this one? Yeah, okay. But this is also used to transmit from the speaker to. Oh, okay.
He doesn't need
Yeah.
Yeah, it's no, not on this paper.
Okay, so we're gonna start our next session in like about 2 minutes. Right. No. Oh yeah.
Like experiments, they're like
Why is the mouse crappy? Okay, so we're going to start our next presentation, and it's by Mark Bergson. He's going to be talking about imitating playstyle with dynamic time warp implementation. So take it away, Mark.
Thank you. Hello, everyone. My name is Mark Ferguson. In this talk, I'm going to look to kind of answer the question about how we can learn triggers to learn a given playstyle from a set of demonstrations, even in situations that I'm actually demonstrating in private demonstrations. Actually, this was great. So the first natural question is why do you want to be able to do this? In my opinion, there's many possible applications that it's useful to do in gaming. And within this slide, I'm going to look at layout companies and possible applications. The first possible application would be for the automatic game content testing. Within the literature, we've seen sort of a growing interest in the use of AI agents for testing content. However, it probably requires the level of capability to decide kind of certain top layers of testing. The idea of this one is potentially apply some post-flush player data in order to sort of be able to tailor the playstyle testing based on the playstyles you see in player not actually having to have any game knowledge. The alternative option would be to develop NPCs. This could be decided as a direct approach or using these kind of playstyles to control NPCs. The idea of giving them each what you feel. The alternative, more direct approach would be to use these kind of models during like the training or testing NPCs to try and check that they're able to sort of cooperate with the range of playstyles that they're likely to expect me to deploy into the game. The first sort of action point of this work is to try and work out what kind of playstyles we'll be looking to imitate. Within this work, decisions are made to kind of look at self-based game, sort of based in literature. There's sort of a few playstyles are chosen, and we call these camouflage game and stealth. On top of these, there's some big variables that kind of change traits and sort of can be sort of constructed through training. With the idea that kind of combination of these can be used to kind of gain a rough understanding of what the players do. In the table below, you can kind of see how it's one of the playstyle based on these sort of game variables. So by the camouflage was a naturally set playstyles at a complete level, and this is kind of shown by having to complete game variable 1. However, if you look at the camouflage playstyle, it looks to sort of utilize camouflage just past techniques. And this is kind of represented by resident of one which shows camouflage is used, and also lack of takedown required. So on the other hand, if you look at the takedown style, it doesn't be used as camouflage, as a zero gate variable. However, it takes down these is represented by the two takedowns. The reason for this too is actually in our base game level, is to use the player encounter as some effect of things. The final style we can take use of spells, and on the other base sort of tries to avoid the use of low camouflage and takedowns. And this is reflected by the two zeros in both of these game variables. Now, we have got understanding of the playstyle, it would take important to have the kind of game design to allow each of these kind of playstyles to be used effectively. So the left-hand side here, kind of base level design of the game, and we can run that how the base idea works. The idea is that the player is represented by the blue triangle to try and navigate the gold green square, while the main counter enemies are controlled back and forth and shown by the kind of red triangles, or a sort of stationary lookup position shown by the orange. Further, the players choose to try and pick up the camouflage packet. This kind of simulates the idea that the players are in disguise and sort of represented the player by the eye contact together. This means the players know along sort of coordinate this line of sight of the enemies. On top of kind of this base level, we look to design some sort of type of level variants, each of which will kind of design a challenging imitation of certain play styles. The first level variant, move camouflage, in this case, the sort of camouflage is simply moved just up to the black. This was actually going to channel the camouflage playstyle to kind of ensure that the playstyle will learn that they have to pick up the camouflage, also just following it set up to where it normally was. The second one we call move exits. In this case, we come in a shift where the player will exit the group. This will sort of change the path of the playstyle again, so affected more equally. And again, this is just trying to make sure that changes you might see, depending on where it came from. Another playstyle variant example is split through. In this case, the actual secondary is split around the entry hole. This playstyle itself, some left variants designed to challenge more like takedown playstyle. As in this style, the player is required to kind of circle hanging before the takedown, so it has to evaluate where the enemy was and also move to the correct position. The final two groups based on actually a single benefit system. The first one called left and only. This is expected to have not much effect because all the collective demonstrations utilize this method for selling. But the more interesting one was actually wide benefit. As I said, the demonstrations we use this hence we're churning the algorithms in order to try and evaluate the use of this method, consider similar playstyle, even not use to see if we can imitate these change levels. So now we've got our basic standard of what we're imitating where we're doing it. Now let's introduce our proposed method called dynamic tunnel imitation. In this slide, I'll give a quick breakdown of our key components, and in future slides, I'll give a little bit more detail about some very important aspects. So first of all, we have sort of standard foundation demonstration stored. Within this work, these are essentially demonstrating the playstyle we want to imitate performance on the base level. When you have got these demonstrations, the next step is unsupervised learning approach to training the coder, how it benefits learners from the beginning, and then for the rest of the training, this was frozen. And this encoder serves two main purposes. Firstly, it is used to transform demonstration into representation, and also for our sort of agent, you can convert the environment observation to representation. This representation itself is then passed to policy. Policy then looks to make two main predictions. So the standard QI you should expect, which is kind of 5-step prediction for the next sort of rewards. These two values are then fed into the explorer, which was looking to try and look to balance the idea of exploration and exploitation based on predictions, and using those kind of predictions to choose the next action. And this was then ultimately fed back to the standard map. So this loop will be continued to sort of circle around until the episode is completed. At this point, you end up essentially in sort of representation trajectory, the agent's trajectory through the game, and the idea was to compare these different demonstrations a significant amount of data being collected. The briefing document can be sampled from, and then it's all used to update policy. So next I'll look to learn a bit more detail about how the Explorer works. So as mentioned, we kind of get forward predictions and policies, and on the right here you can see kind of an example of these predictions at different points in the episode as well as through time. The way this was sort of set up was ultimately decided to try and predict a discounted 5-step reward. However, if the episode was to sort of terminate prior to those 5 steps, it would repeat the last action, last reward value. The reason for this was actually the way the reward structure is set up. Maximum reward you get per step was 2. And hence, when doing this, to ensure that this is a theoretical reward, which was always possible. And within these graphs, it showed this sort of dotted black line. As this sort of idea here was if the agent to get this effective match reward, this would essentially relate back to basic perfect max demonstration. So then you can predict based on choosing that to be selected epsilon or treatment predicted based epsilon in order based on the difference between prediction and theoretical, and use this to kind of gauge how much more integration is required. However, this sort of prediction makes that important to go straight after the epsilon use. It just on the right here, you kind of see how the epsilon value could sort of behave through training. Initially, kind of in the episode, this epsilon was just automatically held high to sort of encourage more exploration. However, after this initial phase, they looked to sort of take a value between the sort of previously discussed predicted epsilon and the sort of standard decayed epsilon. The reason for having to introduce standard decayed epsilon is because given we're trying to take situations which aren't quite the same as the demonstrations, sort of perfect maps is always possible. Hence, it's just ensured the epsilon decay. However, sort of like the prediction based system can for the state of the certain values. The next step is to define expensive action metric in order to try and extract an idea of how simple each solution was. So this was done by comparing the demonstrations to the trajectories. The initial filtering process was applied on demonstrations that kind of approximate best, and then the full dynamic time process was applied, which can turn both sort of like similarity scores as well as matching part of how each of the states are matching. The ultimate reward was then calculated based on a combination of 2 scores, the similarity score and the heritage score. The similarity score is essentially just a way of evaluating how similar the projection was. Essentially, it's the average similarity of any stable state pairs that are given each of these state pairs. So if we've got x0 is equal to e0, but x1 is equal to e1 and e2. The second sort of component was the mismatch counting. This was introduced to ensure there was progression through both gauge and demonstration trajectories. This was set to alternate value of 2.1 because each use of an additional step could cause a maximum reward of 2, hence it's 2.1 short of the benefit of confirmed. So next we'll look at the results as mentioned before. Each of the kind of level variables is designed to challenge certain base targets within that exposed most of variance. Which first with the sort of new camouflage, it can be seen that you can kind of minor idea of camouflage just on 2 squares and actually cause issues with some of the future methods, namely BC and delta. Next we look at the kind of group variance. You can see that they're actually WI is able to complete this. However, on investigation, there was small complete, but it just wasn't quite consistent with based on completely. This was kind of represented by actually one of the 2 who did take counts. Next, you look at length, this was the kind of length variable well expected to have any issues because it's still provided the length which used the demonstrations. Interesting, the space masses seem to struggle here. So this is just actually changing stuff that doesn't directly affect place levels and cause issues. The final level variable was the point and again, that if pace when WI is successful. This is quite a promising result. It shows that this method is able to evaluate the use of the event, still be considered a similar style and utilizes this for training. However, it should be noted this evaluation is successful about 1 to 3 rounds. In the full paper, And in this case, you can see that not only did they not successfully imitate the style, but they don't actually mimic the camouflage buckets or struggle to for certain angles. Additionally, it was noted that actually these details that are taken this is not actually required, so again, this reinforces that sort of even edits should affect the next style angles issues with image. Finally, I've tried to conclusion. So as stated, the idea was to try and allow us to imitate a play style sort of new situations. Basically, results we look at kind of combinations that each level varies, a play style each level varies like sort of challenge. So you've got average, DTWIs that outperform all of these different methods. And finally, I'd like to tell you that future work actually would be nice to try and test this imitation of games to fully test with the system method. Further, within this work, it was actually really trying to imitate a single play style at a single time. So potentially it could be shifted to a multi-modal approach to try and learn how play styles are correct. The idea being a bit more information. Finally, sort of that motivation, it'd be nice to try and use these kind of policies within the training of formative agents to see if it's going to improve the agent's ability to approach humans even if they're in different places. I'd like to use some extra thanks to my co-authors, Dr. Samuel, Dr. Daniel, Dr. Jane Walker for their help and advice on the project. Thank you for your time. I'd like to open the floor for any questions.
Thanks so much, Mark. We have questions? Questions from Mark? So I have a question. So you mentioned that there were like different play styles and different like strategies that the agent had to learn. Did you think about sequencing like one after the other, like having it have to go through an event and then maybe have to do a takedown right afterwards too? Hello?
Yeah, sorry.
Did you?
Was I much as I was like on my side.
Oh, sorry. So you mentioned you have different play styles for the different agents where they have to do different strategies, like go through an event or explicitly go around the NPC in order to take it down. But it was kind of only one action kind of room style. So did you think about sequencing these one after the other as it's occurring in stealth games or something? Like figure out, all right, do they need to do one strategy first and then apply a different strategy?
Within this work, we kind of just focus on the assumption of kind of a pure play style from a whole level. That was something interesting, given that they kind of able to imitate each style for each level. It would be one thing to kind of these mixed styles would tend to be possible. But that would be something we look at kind of future work.
Awesome, thank you.
Any more questions?
Thanks so much, Mark. All right. Next speaker that we have, Alberto Alvarez with story design for mixed initiative tools for creating
I cover those. No, it's that one.
Can I extend?
Yes.
All right, everybody. Welcome. My name is Roberto Alvarez. I'm presenting my paper, well, our paper, with Jose Font and Julian Togelius called System Stream. Sorry. Yes, but resume share. All good? Yes.
Thank you.
Okay, so I'm gonna present my paper, our paper called Story Designer towards a mixed initiative tool to create narrative structure. Myself, Alberto Alvarez, Jose Font, and Julian Togelli. This paper comes from it's the mixed initiative implementation of a paper presented in the PCG workshop called Trope Twist. And Trope Twist is a way of encoding narrative structures into graphs. This is the mixed initiative version of this. So there's going to be some repetition from that workshop, just to kind of get everyone at the same level. So the motivation for this paper is simply that there's common elements and narrative among different games, but identifying this and being able to define them in different ways is a hard problem. Many games are very different, very similar structurally, but they might look different. They might be different type of games. They might be different type of system, not only the overarching narrative structure, but also the particular narrative structure within different levels within the game. So for this problem, basically we propose the use of narrative structures, which is similar like the Vladimir Prop's 31 Marines of the Russian folktale, that is trying to encapsulate certain elements that are recurrent in this type of narrative. So in our case, we're using tropes, which are concepts in transmedia storytelling that are basically patterns that are in media. And we take tropes from a website called TV Tropes, and we put them as nodes in this system, and then we start to elaborate and create different type of graphs from them. From that, then we have certain patterns that arise when we are starting to combine these different nodes together with different connections that I will go in just a second. And we represent these graphs as we represent these tropes and structures as narrative graphs, and then we use them in an evolutionary algorithm called Mapelits, and we encode them as graph grammars. So the main part of this is that we can now, it's very difficult to evaluate these narrative graphs by themselves. So we try to get the subjective evaluation of what the designer is doing, and then adapting the fitness function of Mapelits towards what the designer is actually creating. So trying to have a surrogate model of what is interesting for the designer, what is coherent, and what is consistent. So very quickly, in Trope Twist, we have all of these nodes. That was something happened.
Oh.
Okay.
Spoiler.
So in Trope Twist, we have all of these different nodes, and they are divided by the base type, which is the hero, the enemy, the conflict, and the plot devices. And within those ones, then we have a lot of sub nodes, basically, that is kind of refining that basic node. So in the hero, we have the 5-man band, and then we have Neo, the chosen one, and so on and so forth. Then in the system, we have different connections. We have a direct connection, which connects one node to the other one. We have a bidirectional connection, which connects two nodes, and then they have reflective behaviors. And then we have an entail node that basically, when you connect it together, then it's saying that one thing entails the next thing. So as an example, if we have a hero, conflict, and enemy, if we connect them together with the normal connection, then we have that the hero has a conflict with some enemy. Using the entail connection, then we have that the same graph, but adding the Drake and the Empire. Then we have that the hero has a conflict with the enemy, and because that conflict exists, then that's going to entail that appearance of a Drake, which is like a mini boss, you might say, and defeating that, depending on how you defeat it, does not define in the graph,
then you encounter the empire. So within the system, we have different patterns that are helpful for us to evaluate the graphs and what we're trying to evaluate with the fitness functions and how these graphs are actually being composed. So we have micro patterns, which are structure, character, and plot devices, and they are basically the individual nodes in this case. Then we have the meso patterns, they are the conflict, as I told before. A conflict is a composition between characters and a conflict that combines them. We have the derivative, as we saw before, that something entails the next thing and that entails the next. So in this case, enemy entails a break and break entails a neo. We have the reveal pattern. That means that one character becomes another character, and that changes different type of conflict. So it might be in the story or that might be in the graph. Then we have active plot device. So a plot device in itself is one type of element that is important in the narrative to be searched for or to acquire by someone, the hero or the enemy or whoever character it is. And we define this as active once they have actually functioned within the graph. Right? So when some character has some type of actions with this plot device, and that plot device then happens something after that. So either entails something else or actually is to be given to a different type of character. And then we have the plot twist, which is simply a way to see within the graph things that are changing the graph and the structure of the narrative in general. So in this case, we define plot twists depending on the meso pattern that we are trying to look. So it can be that there's a plot twist in the reveal pattern, in the active plot device, or in the derivative pattern. In this case, the example we show here is that because the Neo is a character that is a hero and is different from the other micro patterns that are all enemies, so to say, then that will entail some type of plot twist because it's not a natural progression that you will keep encountering enemies, but you actually encounter a different hero, which might be the change of some other hero or a new actual character hero. And finally, we have the auxiliary patterns, which is simply a way for us to kind of check within the narrative graph what is, if something is not really being used or it's not working correctly. So when it's nothing, it's that there's a node or a micro pattern that is not really connected to any type of meso pattern. And broken links are micro patterns that are not connected to anything else within the graph. So the main thing with Story Designer is that we implement Trope Twist, the mixed initiative system, on top of a framework that is called Evolutionary Dungeon Designer, Edit. So in Edit, it's a level design tool where you can actually generate or build your own dungeons and all the runes that compose those. And then you have a map-elites algorithm to the side, suggesting different runes for the designer that is being adapted to what the designer is doing in this case. And the designer can choose different type of dimensions, and the designer can change the granularity of these dimensions and then pick suggestions if they want to pick them. So Story Designer, what I'm going to present here, or what I have presented, is Trope Twist on mixed initiative. Then we have a map-elites algorithm that is a particular one called interactive constraint map-elites that we use in Edit for levels. We adapt that to evolve grammar graphs. And we implement this within EDD or Edit, which have a level design component, which means that we're trying at the end is to intertwine level and narrative assets together. Very quickly about interactive constraint map-elites. In our system, the user can select 7 dimensions. It's very similar to how it is in the level design part of it. The dimensions that we are using, that we implemented, are interestingness, step, diversity, plot points, plot twists, plot devices, and conflicts. The designer can change the granularity of these dimensions, and there's a continuous evolution, so it's continuous adaptation to what the designer is trying to do. One thing that we're doing here in this paper is that we're trying to see how can we constrain the design, the search space of the ICMap elites for narrative graph using level design components. So what we do to constrain the search space is that we actually use the level design components as feasibility measurements within the ICMap elites. And finally, the fitness in our system in Story Designer optimizes for cohesion and consistency of the narrative graphs. Quickly, this is how we encode narrative graph. Basically, is we have a genotype, which is a set of production rules, and then a sample in what we call recipes, which is very similar to Dorman's work, where they also have graph grammars in their case. And then we apply these recipes to the action. In this case, the action for us is what the designer is creating. And then we're trying to get a final phenotype that is the final narrative graph that is going to be suggested to the designer. So this is more or less how it looks, or not more or less, this is exactly how it looks in EDT. So in the Story Designer view, the designer can create and compose their narrative graph as they want. They are not limited by the constraints of their level design. And to the right, we have the map elites running that is adapting towards what the designer is creating and suggesting a set of graph that they can use and replace or use as inspiration as well. In any time and any given moment, the designer can change these dimensions, can change the granularity, and can replace their design with the ones that are proposed by the algorithm, right? And the constraints of the level design are only for the ICMap elites. It's not what the designer is creating at that moment. So in our paper, what we evaluate this is through simulations. So we don't do, or we haven't done yet user studies, but we simulate how the system will work step by step and with very conceptual type of graph that we have. So the three on the top are from trope twist that we implemented in Story Designer, and then we implemented with constraint elements from the level design, which you can see down here. And then the second part of this image is the step-by-step changes that we're doing in the narrative graph and evaluating how the evolutionary algorithm is responding to the changes. So the three first experiments is where we encode, the first one encodes Super Mario Bros. The second one encodes the Eastern Palace of A Link to the Past, and the last one encodes the Ocarina of Time. What we evaluate this is with expressive range analysis, where we're trying to see how the algorithm is being able to be diverse, but at the same time exploit the high-performing individuals. And what we see is that we're trying to compare what happens when you use all the dimensions possible and just using a pair of dimensions. In this case, we're using interestingness as depth as the pair of dimensions, and then we evaluate how it explores the space in contrast to using all the dimensions and also using level constraints or not using level constraints. So what we can see is that, and in the paper we have a table that kind of summarizes all of these results. What we see is that the exploration when we are using level constraints or not using level constraints are very similar. They don't change that much the search, the coverage, and the type of high-performing individuals that are generated. But the final graphs that are generated by the map elites are all constrained by this by the level design components as well. Finally, the experiment 4, we in the paper we go one by one, trying to evaluate how each of the changes is actually changing the expressive range analysis or the expressive range of the algorithm. We can see that the first graph that is simply it's only conflict meso pattern, which is hero has a conflict with an enemy. It's quite a basic type of structure, which means that since the algorithm is adapting to what the designer is creating or what we are creating in this case, then search space is quite reduced, quite targeted, and local to what the designer is creating in this case. As we advance and we start complexifying this narrative graph, and in different things, in this case, we change the enemy to the bat, then we add a MacGuffin, and then we add another enemy, then the search space starts to be more complexified because it's able to find, it's given something from the designer that is able to search bigger space in this case. Because the information that is getting is a lot richer than what it was before. And finally, what we're trying to show here is that we are able to easily change definitions of how a narrative is, or how a narrative graph and structure is. In this case, we have that the hero will have a conflict with the bat, will have as a goal to get the MacGuffin, and will also have a conflict with the Drake. But these conflicts are not particularly necessary, or our interpretation is that this conflict might not be a primary objective of the designer, of the player. But once we add an Intel connection from the MacGuffin to the Drake, that means that once the hero gets the MacGuffin, then it's gonna have to face the Drake, making the Drake, in this case, a primary objective as well in this narrative. So just some conclusions to wrap up. A story designer allows us to have adaptive evaluation over what we are finding in the maplets, the search space, based on what the designer is creating. We have found a simple way to kind of constrain the narrative space of this generator, intertwine level and narrative assets, and there's no big difference really when we're trying to use constraints of the level design or not constraints of the level design. And we can, step by step, as we showed before, just to have a quick definition of how a game structure and quick definition of certain elements within the game as well. And finally, our future work is actually to, of course, do a user study that actually can evaluate and assess what is possible with story designer and how complex it might be for a designer to actually be doing level design, constraining the narrative space, and going back to the level design space. That's it. Thank you very much.
Do we have any questions?
Nice. Great. Thank you very much. On your third experiments out of the graph, you are basically also on the fourth one. It looks the space you are covering is mostly the lower half of the interestingness.
Yeah.
Which is kind of very good. Can you explain why we see it and what something higher in that space?
So the main idea is that since we're adapting to what the designer is doing, then as the designer starts with a very simple graph and then it starts to complexify, that graph that the designer has created is very low on interestedness. Then the locals, since the algorithm is adapting, trying to recreate, or not recreate, but trying to make the same graph but better with mesopatterns association, then the search space remains very much constrained by the area where the designer is actually creating space, because we are using what the designer is creating as action for the rest of the evolved graph that we have. So that's why we see that what we're generating is very much on the left side, because it's low interestingness based on our metrics, of course. So it's also very important to say that these metrics are, of course, not replacing the human subjective evaluation, right? There's expert knowledge. We're just simply using these mesopatterns that we're calculating the plot twist, plot points, and this derivative and active plot devices, trying to, from that, extract what can create something interesting from this type of graph. So trying to do some twists. That's why the name is structured. Thank you for the question.
Thank you for your talk. Very nice presentation also. So what I understand now from the that they're rather abstract. They represent like a narrative perspective on these structures, the data structures, but they're open to multiple interpretations. So does it mean they're underspecified, and that actually means that there are a lot of narratives that conform somehow to these structures? And how do you see the research going forward when you would say have like very concrete narrative structures with interactions, and would this view on those data structures also help debugging them, designing them further?
Thank you for the question. Yeah, indeed, the narrative graph are very abstract, so to say. They represent very much generic parts of a story or of a narrative in this case, and they represent very much like generic parts of what a narrative will be, and then it's very open for interpretations of what might be. Our interpretation when we use intermezzo patterns is that it's a particular one about just structurally analyzing this, right? But we're not really doing so to say, a semantic evaluation of what is actually this meaning, and we're not doing interpretation in that case. So as I said before, like when I said that now we have an entail connection between the MacGuffin and the Drake, and that creates that the Drake is now a main objective. That was definitely my interpretation of what I was looking at, right? And then that might vary depending on the designer in this case. But I think one, or at least what we think of this project, is that it really helps the designer have a lot of use the system as more of an ideation type of system, right? Like where the designer can really just play around and then just creating these structures and just getting these suggestions that might be something that they can use to interpret whatever they're trying to do, but not really as a way to just work by itself. So in itself, the story designer is not really prepared, so to say, to be able to be integrated back into what the level is. But the idea is that as the designer is creating heroes, or is creating NPCs, or is creating quest items, or treasures, or enemies, then they are added here as constraints that then can be assigned to the particular nodes that appear here. And it's the same when we use when we have like the derivative and we have the entail connections that appears like enemy, empire, and then the chosen one, and then whatever else. This chosen one can be interpreted as a new character appearing, but it can also be interpreted as one character just changing its role, right? So that's definitely part of our future work, to try to see how can we actually connect all of this together to make a more usable use of this. Thank you.
Thank you.
Thank you.
Oh, shit. Okay, that's fine. No, it's fine. No, it's fine. Okay, so our next speaker is Dmitry Batsaki, and he will be presenting an internet-assisted Dixit playing AI.
I don't get it. Okay. So, no, I mean, you need to start the presentation.
No, it's not sure. Yeah, it's not.
One second.
No, not screen.
Yeah.
Not screen two. Not screen two. Not screen two. Screen two is the yeah. No, screen two is not. Yeah. Okay. Because it's not showing up.
Sorry. No, that's fine. Okay.
No, that's the.
Actually small.
No, it's showing too much. This one. Okay. Now? Make sure it's not changing. Oh, there. Okay, it's all right.
How my son? Like this?
Yeah. Sorry about that.
Hello, everybody. Good afternoon. I'm Dimitris Vatsakis. Thanks for joining me in my presentation of our research that we conducted in Tilburg University with professors Mavro Mustakos and Sprong. And it's about Dixit AI agents that plays the voting phase of the Dixit game. I hope that you're familiar already with Dixit board game. Actually, can I see some hands? People that are aware of Dixit already? Okay, so I have to explain it here. Oh well. So the game is a board game played with cards. It has 84, as you can see, bizarrely illustrated cards. Here you can see a sample of 4 of them. It's a award-winning board game, and the main theme of the game is creative storytelling. And why Dixit AI? Well, the community of AI research have beaten most of the grand challenges of the past for deterministic games. It beat the great test of the kind in chess and only recently Go. So we think that now is the social board games era, and Dixit is a epitome of a social board game because it has multiple layers of social elements. First of all, it requires the players to communicate actively and to transmit messages, encoding, decoding messages and meanings, and also to be socially aware, meaning to follow the news or understand social references like historical references, even personal and inside jokes. But this depends on the familiarity between the players. And here I have placed an example of a card. Here you can see multiple themes that appear in the card, like Lincoln and vampires and Truman Show, that people are using to describe the card. But you will see in the next slide what I mean by that. And because of the many themes that appear inside the card, there can be multiple interpretations. And that's why it's difficult even for people to play it. You cannot even imagine how difficult it can be for the machine. So the game is played between 4 and 6 players, but technically can be played by multiple players. And each player has 6 cards on the hands. In each round, there's a storyteller, picks a card from his or her hand, and gives a hint about it that will kind of, and keep this word, kind of describe the card. Here we have the example. The hint is Einstein, and the player has chosen the middle card. Then the audience players must do the same, given the hints, must choose the card that best fits the hint that was given from the storyteller. All the cards are delivered to the storyteller, and after a good shuffle are presented simultaneously. And here we have all the pool of the cards. Now the audience has to cast a vote, and the goal of the audience is to find the storyteller's card. And the storyteller's objective in the game is that at least one, but not everybody, has to vote for his or her card. And this is the crux of the game, that the hints must not be too abstract nor too descriptive. And worth mentioning is that, again, our system will only play this part of the game, only the voting phase. We will be giving the system the cards, the candidate cards, and given the hint, must decide what will be the storyteller's card. Now, in the technical part, we have also to mention that even though Dixit is a rich a visually rich game. We won't include any computer vision in the system. So the system is image agnostic. We only use text data for hints, and we have attributed a numerical ID to every card from 1 to 84. And after analysis, and as experienced players can say, the cards have included inside the cards. You can see multiple themes appearing. Most of them are cultural references because people need to pass the meaning, but in a hinted way. So you can see here some themes appearing from pop culture like Beauty and the Beast, Rocky, the Fourth, I don't know. And also some everyday words and emotions like love and passion. But these are the outstanding themes. Also, there are hindering themes within each hint. And we needed a combination of algorithms to grasp both words, both the most prominent and also the hindering ones. So we created an amalgamation of models. The first model is the keyword similarity model, and it's based on TF-IDF algorithm. TF-IDF algorithm has the ability to extract all the keywords and discard all the useless information from text. And it will be used to grasp the general perception that people have for the cards. And we have also done already in the previous years another research, and it showed that TF-IDF can be used to play the game of Dixit. And the second part is the web similarity model, which will scrape the internet and find information in order to grasp possibly the news from Google. And also we want the interpretation of the hints from Google side, and we hope that they will grasp all the hindering things that are appearing with the card. And by saying hindering things, it's like Rocky. Somebody gives the hints of Stallone. It's not here into the word cloud, but maybe Google can identify that Stallone is good. Nice. Can identify that Stallone is the main character, plays the main character in Rocky movies. And we test our system given the benchmark of a baseline model, which is not completely random. It doesn't include data, just picks the frequent card. And of course, the greater goal is the human intelligence prediction rates. And this is a schematic of how we trained the model. We have the hints and explanations that some people gave for the cards given to TF-IDF. We created 84 huge corpora with all the hints for each target card. And then TF-IDF parsed all the corpora, discarded all the useless information, and created 84 unique vocabularies with the 84 unique identifiers of each card. And we saw here, you can see here that 1100 is the optimal amount of keywords per card, because after that, it doesn't give any value to the model, maybe overfit. And we also did it for Google. We retrieved from each hint the 10 first results, and we kept only those that led to fandom in Wikipedia as popular encyclopedic websites. And we only kept the URLs. We're not interested in the text so far of the content of the websites, on the URLs. And this is a schematic of how Dixit AI was tested and how it works, but I think it's better if I show you with an example. So here we have the hint Nesquik with ABC, and the candidate cards 76, 48, 55, and 17. And for your reference, these are the cards. So you can imagine not even humans can identify what is Nesquik with ABC, even by looking at the cards, how we do. So first of all, the hints are going to the vocabularies, each word, and with every match, we keep the score, the TF-IDF score, and then we aggregate for every card. The best two scoring cards for TF-IDF are the output of keyword similarity model, and then again, on the other side, We asked for Google's interpretation. Google gave us the Wikipedia of Nesquik. And then we searched how many times this specific URL appears with each target card. And we measure it with the frequent appearance inside the training URL dataset. Again, we keep the best two scoring cards. And we pass them to decision model, which is the final step. And decision model is a heuristic algorithm governed by some rules. And here you can see them, but I think it's a long talk if I keep saying about this. Maybe you can ask me for more details in the break. But you can see here we have chosen for some conflicts the majority votes, because in a sense the two models are rivalrous, they don't cooperate, and we have to choose only one card out of the 4 suggestions. So we needed to resolve any conflicts, and here are the rules. And here we can see some interesting results. We are also interested into the individually to each model, and both of them scored better than our baseline, which is 25%, you can say, for 4 cards prediction. And on the last table, on the bottom, you can see that in most of the cases, both of the models were giving the same output. And when it happened, we had 66% of getting the correct prediction. But when they disagreeing on the first predictions, the rates were dropping to the half, like 34-35%. And here are the aggregated results of the Dixit AI. Unfortunately, we don't have enough data for human prediction rates. We only have the format of 4 cards and 5 cards, but here you can see Dixit AI with the darker color are surpassing every model and human predictive ability. And to sum up, we are really optimistic and positive about this research. It's really early stage of social board games research, and the results are promising. We saw that neither of the 2 models were predicting well, better than humans, actually, but in combination they do, and we believe this is because each other fill each other's gaps. And we suspect that we cannot have a large increase in the prediction rate because this is the nature of the game. The hints must be abstract, and also there can be some hints with inside jokes, inside information that the computer cannot identify when this happens. Also, some limitations of the model is that we all know that Google works in a time manner. So Google results for the same query will change over time. So let's say US elections in 2012 will have significantly different results from US elections in 2020. And because we are passionate about this social board games research, we suggest that Dixit could play indeed the benchmark role for the next AI Grand Challenge. And we suggest people follow this path, and also to make better models than based on our work, to improve them by giving more websites to look into search for information, also to include more models like computer vision, or to create a complete AI to play all the parts of the game. And that's pretty much it. Thank you for your attention, and can't wait for your questions if you have.
All right. Yeah. So this is great work. Well done. So I was wondering whether you have considered photo completion. I think it's a great idea. Whether in the future
versions of the competition could include image generation, card generation, so that you augment the data set and thereby make it more challenging as the year go by.
Yeah, that's a good idea, and I think it can happen because we don't have enough data. The cards are limited. Even though they're generating new versions every now and then, because okay, why not, to make some money, I guess. We're not judging, but yes, we can do this one, include every card, but also generating to create new cards. I think it will be the best solution with the current state of technology, and to create a more powerful AI. I think yeah, it's feasible. I think this covers your, but also to incorporate all the cards of all versions. I think there must be a bunch right now.
Question?
Have you also considered for future work kind of doing the inverse where the agent has to select a card from all the available cards and give a keyword in order to get players to predict which one is, or try to like basically win the game.
To be the storyteller.
To be the storyteller, yeah, exactly.
Yeah, of course it can happen, but I think it's more difficult. Or we didn't choose to do this right now. We were focused on the voting part. I can sense that it's more difficult to do this, but an idea is to just create a data set and generate from inside this, the easy way. But of course, with text generators, maybe it's feasible. And of course, it's up to the community to follow this work. I think it's a really interesting project.
Yeah, awesome. Thank you.
Thank you very much.
Okay, that's it. Okay, so we break for lunch, and then we'll be back at 2 o'clock. Yes. See you right. Oh yeah. Oh, okay.
Mike, give me the presentation to put on the computer. Okay, maybe you want to. Oh, yes. That's a good thing. Thank you. Sorry. It's good to
Oh, no. I have
check, make sure that you can mute.
Are you playing
Those work.
Yes, I think so. Oh gosh. Exactly. Oh gosh. Okay, both of them. You have everything in mind. You know what you have.
What is it?
Stream is running.
He's not first though.
It's not first. We put both of them. The first one is my super cat, is my student.
Oh.
Both of them are mine.
Oh, that's why you're present.
Yeah, so I know.
That's funny. And they're both persona based.
That's
It's even funnier.
Yes.
And you're both second author on it.
Yes.
Might as well do it and then the next, and then the next.
That would be fun. I think the whole session.
This is always
One second.
Yeah, and then it's like, as soon as you make it hybrid. Yeah.
Ωραία, μας έχει
Κοιτάξτε, μπορεί να δει τη φυγή σωστά, αν και δεν είναι κάτι πρόβλημα στο σύστημα.
Χρωστάνε ή θέλει να δώσουν.
Χρωστάνε για να το δώσω τώρα στην εξεταστική συμβουλή.
Yes.
Then just quick line on how we got so just so that I'm not coming back to that same and then later on. Moving to workflow. Chat very briefly about the implementation of workflow, what we do to others, just doing it step by step. Explain everything. I mean, it's good. Yeah. I try to simplify the words here so I don't get. Oh, you actually I made it to English. So like instead of like RP and RE, quick reward function. Again, I'm bringing up the thing this is I'm not really talking about also send it to yeah, so just starting the fact that we still feed in the states of our human model or outcomes means it's anyway somewhat of a piece of the outcome based on the solution but you know, it's just really runs up the performance. As we expect.
Yeah.
One-on-one.
cases where pretty poorly. The summary was like reiterate what's next and not the this is I guess like a stretch.
Yeah, if you look at some like if you want to read your screen, like the results.
Yeah, I have set up.
It's fine. Just say,
Yeah, no, I have that shorter. I have like a general concept. Let's say like 5 hours on this concept.
Come on.
How do you get the certificate of attendance?
So you need to go to either seminar or courses. So they're the ones that can provide that. I'm just sharing the session, so I don't. Hello. Everything good? Seems fine.
Can I just make sure that like all the animations are coming through?
Session. Go right ahead.
Yeah.
Yeah,
Oh, I'm
come on.
sitting up here.
It's a very awful question.
I was going to say that's not.
This is running, so. The animations are running.
Yeah, it's fine. I just want to make sure that video's all in play. Yeah.
You're gonna look at me as I want to be like algorithm. Neural networks.
Chris, it's a milkshake and that there is step half.
Yeah, it's just like algorithm. So you're wondering.
Yeah.
I was scared it was going to be tiny.
No. So as long as you lock into the lower area,
Yeah.
it's cut.
This is the one I'm curious about.
Yeah, this is at the beginning won't be very apparent. This one is okay, but you have to read.
Yeah,
the colors.
maybe I can.
Like agent and human, you have to read them. You can leave it, but you can just.
Yeah, I just don't know.
Like, no need for editing now. So
Yeah.
just be aware.
Yeah.
Anything you have written down there, it might be not easy.
Okay.
Yeah, we're just gonna wait. So if there is nothing to inside, stuff back.
Yeah, and then you'll set the mic down in front of me.
I will always sit here.
Yeah,
So
exactly. I won't
as soon
touch
as
it.
you, yeah, if you're sitting here and talking, because this is fixed for
the Zoom, yeah, and this one's for the broadcast system.
For the speaking, your voice is not very
Yeah.
That's why I'm doing this question. I figured out I can just
Yeah, and I'll try to address it so far as I reply to the question.
don't need to worry. Like, it's gonna be picked from that.
Yeah. Yes, and I
presented.
like 15 minutes, right? That's fine.
15 plus 5, it's important.
Yeah, I it's like around 15 minutes. I mean, I have around 15 minutes. So unless I trip up or something. No, I've got my phone. I'm gonna just start the timer. So
Don't
no, but it's more for me.
Okay.
Like,
But anyway, the PowerPoint will do that for you. You don't even need that because
it just makes me more comfortable knowing. Yeah, but this is the problem. Like to start next or anything. I'd rather just have it.
I'm stuck with myself. Sorry, I'm stuck with no, so they want and then and if you guess and so this was
Oh, did you turn my laptop?
That's what I'm saying.
I'm not sharing right now.
Okay, welcome back from lunch. And now we're going to resume our Q&A session. First speaker is Matthew Quartet, who generated the result that we gave an experience in agreement, and also on that papers.
Hello everyone, and thank you for the introduction, and I hope you all had a good lunch break. Yes, so just jumping straight into it. There we go. So if I had to distill the motivation for this work into one sentence, it would be that so far, procedural personas have largely ignored the value of their experience and have mostly focused on imitating either some form of optimal behavior policy or imitating human players, which we feel doesn't quite realize the rich nature of human-computer interaction.
So in our approach, we actually combine the imitation of human player behavior and the imitation of human player experience into a single agent. And we do so using pretty cutting-edge reinforcement learning algorithm called GoExplore. And what you get is something neat like what I'm showing here, is that you can actually visualize the agent's trajectory to the level, its human-like behavior, and at the same time view which portions of your content are either viewed as high or low, in this case intensity, but it could be any experience metric. And we call this approach GoBlend, and on a high level you can break it down into these three components. And the first is actual human demonstration data. So we use a data-driven approach, and this is where work by a colleague of mine called David Malhart pretty much forms the foundation of this project. So he created what's called the Again dataset. It consists of 124 players who were asked to play 9 different games, which span across 3 genres, and these were driving, shooting, and platforming. And basically the game sessions were 2 minutes, and after they played the game, they were asked to annotate their gameplay using the Pagan tool. And in this case, we used arousal or experience intensity, like I mentioned. And alongside these traces of experience, you have detailed gameplay logs that actually sync up with these. So we've got these 2 facets. We have behavior and experience, which we use to feed into our training. And of the 9 games for this paper, we chose Solid Rally. It's arguably the most complex of the bunch. It features real-time control of a rally car, and the objective of the player is to drive around the circuit as fast as possible and through any means necessary try and come first. So anything goes here. You can hit the brakes and slam into cars, you can send them flying off the track, as long as you come first, basically. And as you go around the circuit, you're awarded points. So every lap gives you 8 points, and these are determined by checkpoints around the circuit. So moving out of like having our foundation set in terms of a test bed and human data, we moved into actually identifying human player personas from this data. We chose to do this for 2 reasons. One, we found that the distribution of play styles and trajectories in the players was actually quite large, so the competency of the players was quite varied. And this would introduce a lot of noise, so we decided to restrict which type of player the RL agent would imitate. And it also lets us see the scalability of the algorithm. So we can see that GoExplore is capable of either imitating someone who's really good or might be not so good at the game. And just for the sake of getting us all on the same page, I included an example from Crash Bandicoots, just showing 2 very different players. But when I say identifying human personas, I mean this idea of grouping them together by some play style. And since we're using a very data-driven approach, we use a clustering algorithm to do this. And in our case, the Again dataset consists of 38 game features, so we're clustering on those feature traces. And the result is these 4 different archetypes of players, which we labeled from beginner to intermediate to advanced to expert. And you can see there's quite a big discrepancy in performance. So the beginners don't even manage to complete the race distance within 2 minutes. And all the way up to the experts, they actually complete the level with 30 seconds to spare. So we're actually testing our algorithm on very different player types. And with that covered, we can actually move into how we're doing this. So for those of you who aren't familiar, GoExplore is probably one of the most, at least in my view, promising recent reinforcement learning algorithms. And since its inception, it was actually published in Nature last year. One of its most notable achievements was that it managed to achieve superhuman performance in games like Montezuma's Revenge and Pitfall, which were ordinarily very difficult for AI to actually even complete levels in. And one thing that we noticed is that Go Explore as a whole was mostly used for optimization, whereas we're actually starting to adapt it towards imitating not just behavior but experience at the same time and seeing how the two ideas correlate together. And this is, okay, you can see it properly. This is just a high-level overview of our approach. Before I jump into the step-by-step, I'm going to zoom in, don't worry, is that the algorithm works by maintaining an archive of promising game states. So each cell in this archive represents something that's unique in the level, like a unique state. And alongside each state, there's the rewards that's been assigned to that state, how well it does, and also the instructions required to actually replicate that state. So Go Explore never forgets promising areas of the search space, and it never forgets how to get there, regardless of how contrived the path the agent needs to take to recreate it. But going in step by step. So first, it's actually quite a simple loop. The algorithm randomly selects a cell from the archive and just boots up its state. From that state, it essentially just takes a part of random actions to the level, and at each action it identifies what state is occurring at that time point. It's important that we actually capture which state we have because we feed this into a human model. So we essentially take this game state, compare it to the k nearest human states in the data set, and from those k nearest states, we're trying to generate, in our case, an arousal value that corresponds to this time point. So we just use distance-weighted k nearest neighbors, which essentially means that the closer the human state is to the current state, the more it impacts the current arousal value. And these are important because we need to actually calculate the rewards for behavior and experience. So I showed you the mean score trace of the personas. That's our target behavior trace. And also each persona has a mean arousal trace, which acts as the target trace for experience. And those two reward components actually feed back into the algorithm, and we use that to calculate our lambda, which I'll get into on the next slide. But once we have these reward values, then we just decide whether to keep these game states. So Go Explore uses a very simple method. If this cell is unique, insert it into the archive. If it has a better reward than the current existing cell, update it. Or if it has the same reward but is more efficient to get there, update the state. So that's making sure that we're prioritizing efficiency, not just reward. And yeah, this process just repeats for as long as you need to, and the result is one or more cells that are going to be very high performing for your cause, but they're also assuming that you're operating in a deterministic environment. So if you want to move into something that's stochastic, you actually need to incorporate this optional phase for the robustification phase. But in our case, we actually determinized the environment, so we didn't really need this. Okay. And just a very quick line on the reward function. So as I told you, it has two components. It's got the reward for experience and the reward for behavior. And the lambda is actually the weighting parameter. So the more you increase the value of lambda, the more priority is assigned to imitating experience, and the other way. So at R0, you're basically telling the agent imitate behavior and ignore experience. And anywhere in between, you're blending the two rewards together. Okay, so with that done, moving into how we actually evaluated the algorithm. So we compared the three rewards. So of that lambda value I just spoke about, we tested R0, R0.5, and R1. And the objective of these agents was to imitate individually. We had agents imitating the 4 different human personas. The target traces, like I mentioned, were score for behavior and intensity for experience. And we also compared to just a random action behavior baseline just to see how essentially a noisy agent would compare in the results. And yeah, these are the results. So on the left, you have the results for behavior, and on the right, you have the results for experience. Looking at the random agents, as you might expect, a random behavior agent in a racing game is not going to perform very well, so it achieved very easily the lowest score. But in terms of experience, it actually didn't perform too badly. That's because it's querying the same human model, and regardless of which behavior, it's still retrieving realistic arousal values from the human model. But as soon as you move into R0 and it's just behavior, the performance increases quite dramatically. So we're imitating all 4 clusters of players very well in terms of behavior, and even the experience has taken an increase in performance. And the same goes with the blended agent, so it manages to actually improve its experience capability, so it's more representative in terms of the effect side of things, and the behavior still manages to keep up that similar level of performance. Then on the R1 agent, where we're just looking at experience, things get a bit more there are a bit more outliers. So on the beginner side, the imitation was actually quite poor, but as we move up in terms of the capabilities of the target persona, the imitation in terms of experience actually increased to the best of the bunch. And even if you look at the expert persona of the R1 in terms of behavior, it actually managed to learn good behavior, even though it wasn't trained on any behavior reward function, which was quite interesting. And we can make it out. This is actually a recording of one of the agents. So this is the blended agent for the experts, and you probably can't see the bottom very well. But in blue, you have the agent score on the left, and in orange, you have the target human score. And on the right, you have their arousal trace as they move through the level. So it's trying to balance and imitate as accurately as possible on both fronts. So probably a bit difficult to understand what's going on because a lot's happening, but essentially over time you can tell that it's actually taking actions to how can I put it? It's taking actions that make it correlate more with how the user might feel in that situation. So if it needs to increase its arousal value, it might try and crash into the opponents around on the track and stuff like that, essentially. And yeah, just to quickly sum up, in this project we've tried to introduce this idea of combining the notions of imitating behavior and experience, not just doing so independently of one another. And we've tested it on what's quite a complex real-time test bed. Obviously, there's more complex games out there that we'd like to move into, but for the time being, this is a good foundation to live off. And yeah, we saw that there was quite a good imitation accuracy across all the personas. Outliers excluded for the R1 agent, but yeah, we believe that through this tool, you can generate some agents that are more believable in all cases, in the sense that you're better realizing this idea that your behavior is not just done in silo. Your behavior is also impacted by how you're feeling in that situation. And we think that's a very strong and valuable asset for automated agent playtesting and experience-driven content generation. And yeah, I've listed a couple of things that we're planning on working on in the future. Actually, the first two, so implementing more complex reward functions specifically for the experience side of things. And using experience as a self-selection mechanism is something that we're going to be presenting at Aki this year. And further on down the line, we actually want to transition into stochastic environments that are a bit more representative of real-world games. And also see how well this agent can actually integrate into experience-driven content generation systems. But yeah, thank you. I hope that can answer.
Any questions?
Okay. Could you show me, I was a little confused looking at your results. Could you just walk me through one of your charts?
Yes, this one, right?
Sure. Yeah, so what is I probably was half asleep at some point from lunch, but what are the RB and the y-axis, and how are these meaningfully, how are these bars meaningfully different?
Yeah, so the RB is measuring the similarity of the play trace of the agent in terms of its behavior, so how well it can imitate the score trace of a human, as they play through the level. Whereas on the right, the RE is the arousal trace. So it's completely independent of how the agent is behaving and more about the arousal values it's generating as it goes through the level. So how well that arousal trace correlates to the human trace that it's trying to imitate, if that makes sense.
Yeah, it does. Thank you. Did you say that so are there one or two different human traces that you're comparing to?
So for each experiment, it's comparing to the persona trace, one trace. So it's trying to imitate one persona. That trace that it's imitating is actually like a mean of all the arousal traces that are made up in that persona. So trying to average out according to that player group, if that makes sense.
It does. Thank you very much.
Hi, I was wondering if you could expand a little bit on what kind of, you said at the end that you, as future work, you may want to visit the more complex reward functions. Could you expand a little bit on that?
Yeah, so at the moment, what I mean by that is at the moment we're doing very simple for the experience side of things, focusing on that. We're just doing very simple regression, so how well you can imitate that trait. So in the work that we're going to be presenting at Aki, we're actually looking into taking into account the uncertainty of the arousal values generated. On the behavior side of things, this is not something at Aki, but something that we've been talking about is actually going past just imitating score. So maybe doing some form of imitation on the feature vector of the players as a whole. So you're sort of imitating the whole play style, not just the performance of the player.
So you're thinking the models of capturing
more complex representations of the player, basically.
Right. And what about other types of it apart from arousal circle? Do you think other types of measures would make sense in this strategy?
Other types of measures in what?
It's apart from arousal.
Yeah. It obviously depends on the game and how well the game can elicit those emotions in the players. So if you can generate meaningfully different traces between players for that game, then whatever metric you come across should be useful.
Okay, thank you. So our next speaker is Mike Green. He's going to present persona-dependent dominance of certain integration. Let's hold the single answers there. Yeah.
Yes.
Sure, I said.
Everyone can hear me okay? Great, awesome. Hi everyone, my name is Michael Cerny. My fans in the back here. My name is Michael Cerny Green. I am a former NYU PhD student and an avid FDG connoisseur. I'm an author on this paper called Persona-Driven Dominant Submissive Map Generation, or PDSM, as we like to shorten it to. I also wrote this paper with Ahmed Khalifa and Charity, and of course my former advisor Julian. I'm a bit of a visual learner, so I decided to bring some props to really drive home some of these concepts. We have submissive maps, and we have dominant maps. Can everyone on the camera see these? You have a little 9 tails and some 8 tails. Let me put these here, just so the rest of the room sees them. So what are we doing here, right? Everyone's just like, what the crap, Mike? So we're trying to generate tutorial levels. That's the main goal of what we're trying to do. And I have some experience with trying to do tutorial stuff. This is the short list of papers that are in this space. I'm a big fan of trying to merge video games, AI, and education. So tutorial levels are one way that you can try to teach players how to play. Mainly what we're trying to do in this paper is we're trying to generate levels that encourage or discourage certain play styles. And by play styles, I'm using Mario here as an example. By play styles, I'm talking about these patterns of player behavior, right? So different ways that people engage with the same game content. So in Mario, for example, you can have over here on the left-hand side, you have Mario going around and popping off Goombas. You can also have speedrunners and compete with world records. You can have a bunch of coin collection. Maybe you like seeing your points go up. People engage with games with their own intrinsic biases and motivations for what they enjoy. So we have different play styles. So we want to try to generate levels that encourage or discourage these different play styles. Now, why would we want to do this? Is because we want to build tutorials with them. We can also merge a bunch of these different levels together in a sequence to build kind of a curriculum that could teach maybe a single play style or discourage the use of a certain play style, get a player over whatever bump that they're struggling with while they're playing. You could also, if you're not generating these on the fly, maybe you have a library of these, you could do some sort of dynamic difficulty adjustment. So as you're playing, if you're struggling with certain content, I can give you content that can ease you into a new strategy. We could also do more experience-driven content generation, right? So I could generate these things on the fly and feed them to you as you're playing. For the purposes of this experiment, we're going to be using a favorite of mine called Mini Dungeons 2. Mini Dungeons is a 2D roguelike dungeon crawler research game. You can kind of see the controls over here on the left. Some of you in this room may have taken part of a user study that we've done on this, because we've done a lot of research with this framework in the past. But you're this little gray soldier, and you're getting chased around by a minotaur who just kind of slaps you right there. And you go around and you can collect potions, you can slay monsters, you can collect treasures, and your goal is to make it to the exit, which he's about to do right there. And that's how you end up winning the game, and you have health. You're trying not to get slain by monsters while you're playing. There's 3 different play styles that are recognized officially in this framework. There's others in there that may be, like merges of different play styles, but these are the kind of the 3 main ones. There's runners, people who try to get to the exit as fast as possible. There's treasure collectors, people who go around trying to collect all the treasure. That kind of makes a lot of sense. And then monster killers, which you try to slay as many monsters as you can without getting killed. So again, we're trying to build persona-dependent levels, and we're terming this for the first time as the levels that promote or dissuade certain playstyles. It'll scope your playstyle behavior into a small experience. And to do this, we're going to use a list of procedural personas. Procedural personas are artificial models of player behavior. So they're like agents that can play like a specific archetypal player. To generate these levels, we're going to use an algorithm called MapElites. It's a quality diversity algorithm. What that means is that you can evolve high fitness solutions and then organize them according to behavioral characteristics, so you get a diverse set of solutions. In this particular area, what we're going to do is we're going to use the health of each of these archetypal agents as our dimensions, and our fitness is going to be our simplicity. So our evolution process looks a bit like this. We're going to have our 3 different archetypal players. They're going to be playing some maps that are getting generated. We're going to grade them based off of how simple the map is, and then we're going to organize them based off of their ending health, which goes from 1 to 10. We're going to be looking at balanced levels and unbalanced levels for our results. Balanced levels are where all 3 personas end the level with a similar amount of health. So on the left, we have a level where the runner, the treasure collector, and the monster killer, which we kind of split into R, TC, and NK. They just have to do the same thing. There's really nothing else to do on that level. It's pretty blank. On the right-hand side, however, nobody can win this level. None of the personas can win. No matter how they try to play, they're going to get moved down by these wizards that'll be casting spells in the lower right-hand corner. So nobody's going to be able to really escape that and beat the level. On the other hand, we can also look at unbalanced levels. This is where it gets fun. So this is where we're going to get into the dominant levels, which are levels where the persona, so if I say like something is persona dominant, that particular persona has a very high health compared to the other personas. And if we say, persona submissive, that means that they have a very low health compared to other levels. So you may not want to necessarily play as that persona for that particular level. We have a couple examples here, but let's walk through a couple of these. So this is a runner dominant level, right? So the runner has an advantage here, and we're going to show off exactly what the runner would do. The runner is in green, the monster killer is in red, and the treasure collector is in yellow. So in this particular instance, the runner just has to move over to the left. It's like 3 moves to win. It's a very simple level for a runner to beat. So the runner's going to have a very high health score. I think this is from 0 to 4, actually. I think we're indexing at 0. So the runner has like the max health that you can walk away with in this particular level. But if you wanted a challenge, you could try to play as a monster killer, who we highlighted in red, who will go after the first ogre at the very top, and then the second ogre at the bottom. Or you could try to be a treasure collector, who would go for that treasure chest, probably get seen by that ogre, and then get chased by that monster for the rest of the game. Did I copy? Sorry. Okay, sorry, this one. On this one, this is a treasure collector submissive level. In this instance, you wouldn't want to be a treasure collector because you would get destroyed by this wizard who's going to be nuking you with spells the entire time. So you probably want to play as either a monster killer to first slay that wizard, maybe with the javelin or walking over to it and hitting it. Or you want to be a runner because you could get right behind that wall there and get out of line of sight of that wizard. And so this particular level would try to dissuade you from playing as a treasure collector, whereas this level would try to persuade you to play as a runner, right? On the other hand, you can have extremely unbalanced levels. This is another treasure collector submissive level. And this level would heavily dissuade a player from playing as a treasure collector because, as you can see, their dimensional value is 0 for a treasure collector. So a treasure collector walks away from this level with barely any health remaining, if any, at all. Meanwhile, a runner could, again, very easily beat this level by going straight to the exit. And if you were to play as a monster killer, which would be a real challenge, you have to strategically use javelins and other map features in order to get around. Maybe if you wanted to play as a treasure collector, you first go and slay all the monsters, and then go collect all the treasure, rather than try to one-track mind yourself to the treasure. So how do we do tutorial-wise on this? Well, we looked at our big swath of maps, and a lot of these maps are simple because of that fitness pressure where we were trying to make things very a lot of these maps are simple because of the fitness pressure where we're trying to grade these maps based off of how simple or complex they are, where we're punishing for more complexity. Maps where the personas have high amounts of health should, in theory, be simpler for that particular persona. And you see maps where our dimensional characteristics are very similar to one another, where we maybe have 4s and 3s and high levels of health. We'll use like this gentle a flavor to kind of nudge your behavior into a particular direction. But those more extreme examples are more like a firmer, heavy play pushing you into a general direction for your strategy. But we looked at the correlation to difficulty for these particular maps, also an important feature of tutorial levels. In theory, tutorials should be simple and easy for somebody to play. And what we found is that having lots of HP at the end of a level doesn't necessarily mean that for that persona, that level is easy, right? Low HP, however, typically means that that level is pretty hard. And I guess the way to think about this is to think about HP as a currency that you're spending in the game. There's actually a concept in game theory that's called strategic headroom, where you can spend a currency in order to enable yourself to go have more choices in the game. It gives you more flexibility. So if you think of HP as that flexible currency, that allows you more options to take, more routes that you can make for yourselves in these maps. So if you have low HP, you have lower currency to spend, therefore things are a lot less flexible for you. So what we could do with this in the future, this is where I get really excited, is you could build this into a persona-dependent pipeline. This thing could basically feed itself. You could put these persona-dependent scenes or scene generators into, you put it down here in the lower right-hand corner. But if you were able to classify a player's behavior, you could then feed them maps and build a sequencer that could allow them to either get better at the particular persona that they're leaning towards, or try to dissuade them and encourage them to play as a different kind of persona, right? We actually built a classifier in an earlier piece of work. Oh, I forgot to cite that off, and I'm just realizing that. Oh, crap. So there's another paper out there that if you guys want, you can come up to me and ask me about that one, where we can actually classify play style behavior in players. But the idea would be to build this pipeline so that you can feed somebody in real time maps that correspond to what they're playing as. Other future work is we could explore not using simplicity as a fitness function. We're looking into the curriculum generation. This part down here where we're selecting TC scenes or non-TC scenes, that's more of a sequencing curriculum generation problem, which we haven't really tackled yet. That could be a lot of fun. And we can evolve new personas at a human player self-play. In fact, we're working on a project like that right now where we're trying to evolve personas using neuroevolution to try to discover their persona space. That's all that I have to share with you guys today. That was really fast. I hope you all enjoyed my talk. Questions, comments, cries of outrage? We got a question. Hey, Sean. No one wants to talk. Do you want one of these?
I'll just keep it here. Really interesting point. I was wondering whether because when you're using archetypes like personas,
yeah,
real humans, as you pointed out, are not just one thing, right? Is the dominant or submissive space that you create a good opportunity for one persona to become another persona? If something is closer to you, then you might switch to this persona. Or
yeah.
Is this something different?
That's so one of the this level right here that I was showing up. This would be an example of where like you'd want to play as one persona and then maybe switch to another. In fact, if you wanted to do any treasure collector at all, you kind of would have to on this particular one. That's not something that we study, but we do see a lot of examples like this in our library, our corpus of levels that we were generating. And that's something that we want to study future. But that's where the neuroevolution problem that we're running into, it can get really interesting because you can create a map elites matrix of different persona styles and you start merging these things exactly. So it gets really exciting there. Any other comments? Anybody from here?
Objections?
Okay, nobody's saying anything online. Great. Nobody has anything else. Thank you so much.
Thank you. The next talk will be ring talk, so we'll just set it up and then I'll speak.
Oh my god.
I want to move them to the school. Or just something in the school right now.
I mean, it's showing up.
It's showing?
Yeah.
No.
Oh. Yeah, no.
So next speaker is Nathan, and he's going to talk about evolving behaviors towards co-creative evolution of behavior trees for game NPCs.
Go ahead, Nathan.
Hi, I'm Nathan. I'm a PhD candidate at Oxford, and I'm really glad that I can virtually be here to present this paper with collaboration and co-authors on behavior. In this paper, we created and evaluated a tool for designers to evolve behavior trees with their non-player characters and only one people, with the goal of helping game designers implement behaviors that meet their design goals. So, how and why are we trying to do this, and what has been tried before? Well, game devs have their work cut out for them in creating complex, non-player character behavior to meet their design goals. And computational co-creativity is a type of human-AI interaction. It's specifically about people collaborating with AI-supported tools to make something creative together. So we hope that we can combine these and that co-creative tools can help game devs create more robust AI behavior. Behavior trees trace back to dominance that work on Halo 2's AI system, and they've become a common technique for agent AI in the game industry. They allow designers to clearly and explicitly specify behavior in particular situations by building a hierarchy and structure for decision-making and behavior in a human-readable and visual form. So we thought behavior trees could be a useful and well-established framework for our tool to evolve. We're not the first to apply evolution behavior trees. Early efforts to do this for specific games focused on small individual decisions or using grammatical evolution to constrain the results. And we're hoping to explore more flexible evolution that can work across multiple games and with more complex trees using a technique called genetic programming. Genetic programming is a particular type of evolutionary algorithm designed to work on programs. In most other evolutionary algorithms, the chromosome is a linear list of genes. In genetic programming, however, it's a tree. And because the chromosome is a tree, genetic programming uses crossover operators that swap entire subtrees and point mutation operators that replace, add, and move or modify individual nodes on a tree. Genetic programming is most commonly used with parse trees for programming languages, but behavior trees are trees. So we can apply genetic programming to them. We're not the first to think of this. Recently, some researchers have applied genetic programming to behavior trees in specific games, such as simple 2D games, strategy games. I've listed a bunch of them here, and there's more references in the paper. These efforts usually focus on simple metrics, such as winning the game, and often constrain the structure of the tree as a builder. These don't generally focus on designer controllability. The most similar approach to ours is by Pyro and Pyro. They created a tool to evolve behavior trees for 3D games and to allow for human-in-the-loop filtering of the resulting trees. However, they focus on player-centric goals like adjusting the difficulty of the game dynamically, rather than on designer interaction and meeting the designer's goals for the behavior. So our contribution is to create a designer-focused tool for evolving behavior trees for 3D games developed in popular Unreal Engine. And we compare experimental results with human design trees and with a random baseline algorithm. And we do this through both quantitative and qualitative evaluation. So this brings us to our tool, Evolve Behavior. Here's the overview of the Evolve Behavior system. Essentially, designers provide an initial behavior tree and a set of initial nodes or instructions to generate nodes. They can also then control the parameters and mutators for the evolutionary process. The tool then iteratively generates trees in each generation and provides them to the game through simulation and tracking of fitness, allowing the tool to repeat the process with the most effective trees. designer gives the tool a hand-designed initial imagery to start the tree, with a library of extra methods that can be swapped in implementation. Next, the designer also sets up the parameters of the image, such as mutation types, probabilities, number of generations, and selection cover of parameters, etc. Finally, the designer to provide a fitness function to guide the evolution towards the desired behavior. Focus we work with is a simplified representation of the behavior tree. Designers can provide fully specified pre-made methods, which we call maps methods. And for these, in the chromosome, we just replace each node with an ID that points to the actual node, so that we can translate it back to the correct unknown behavior tree nodes that we use actual simulation. Designers can also specify more flexibly how to create generated methods. They'll specify a new type, and set properties and possible ranges of values. The tool can then generate methods with random values for those properties, which will be set on the node by reflection, and we translate it back to a real data tree. This way, our algorithm can change the internal properties of those methods. In the reproducer, we select parents using tournament selection, a simple method of biasing for selection with the higher frequency individuals, but still giving almost any individual chance. We use the crossover operator from genetic learning to manually swap assumptions. We specifically use a crossover as suggested by the genetic learning literature that uniformly at random choose the depth of the tree first, and then select a node from that specific depth. This prevents bias in the selection towards the leaves, which encourages more of the tree selected outputs. As described, we randomly mutate individuals using point mutation. In our case, we replace the random node or add complete nodes. We also provide mutators for randomly perturbing properties inside generated nodes, such as flipping booleans, perturbing integers, and floating point variables, and selecting between internal binary variables that are useful. So that's how the tool basically works. Now, how do we evaluate it so far? We ran an experiment in a test bed game, comparing evolved trees with human designed trees and with a random baseline hardware. The example project we used to demonstrate the system is built on top of a basic open source third-person shooting game called Epic Survival Game, created by Tom. It has some simple zombies that can control, try to chase you as you make your way to goodbye, and they damage you as they catch you. Acting as game designers, the researchers provided a stub of a complete behavior tree to start from, and then we let the zombies evolve based on different descriptions. And we will discuss the limitations of researcher tactic design today. For this zombie survival game, the fitness function is set on incorporates these factors. We tune the fitness function to encourage zombies to attack the player, but also to move around the level if possible, control the last communication, and avoid oscillating between chasing and random control. We also added a penalty for overly reverse chromosomes to encourage the behavior tree to remain simple and readable if possible. We tested the evolution in 9 different experimental conditions to compare 3 human design behavior trees, each created by a tech researcher acting as a designer, trying to meet the design goals for the zombies, those same goals that we just talked about in fitness function. One researcher had gained industry experience as a programmer, including implementing NBC AI, 2 did not have prior experience with designing and implementing NBC. We ran 3 runs for each experimental condition, consisting each with 1,000 generations of evolution. We also generated trees using a random baseline algorithm. Basically, it's the same as the evolving algorithm, but with no fitness function. So parent selection and mutation, you just put them on guide. For all grammar details, check out the paper on supplementary material. For each run of the evolution and random baseline, we selected a single best tree, the highest fitness tree and the highest fitness duration at the end. We then tested these selected trees in 100 generations of fitness testing on the same experimental condition, just by copying that same tree in all the zombies level, to provide a more stable fitness value for that specific tree, rather than just using a single level fitness comparison, basically you can see that all of the forms are going up to the right, and the random baseline values are just oscillating around the surface one. Here are the descriptive statistics as proximity plots for the final average fitness results for the best trees for each algorithm and experimental condition. The evolved behavior trees are visibly much better when the random baseline. You can see the I2R interquartile range is outside the upper range of the random baseline. However, the evolved tree is looked to be a bit less successful, at least on several of the conditions of the main trees. We used non-parametric differential statistics as general recommended for evolutionary algorithms to test this more closely. A frequent sign mixed test showed significant differences among the algorithms with large effect size, so we performed a post hoc test on all periods of algorithms. Post hoc test found that there were significant differences between evolved and manual R2, and between the random baseline and the manual trees, but it didn't find significant differences between evolved and manual R1 or R3, nor between evolved and random baseline. Therefore, we turned to a qualitative evaluation of the resulting trees to more thoroughly investigate the comparisons. For our qualitative evaluation, we had 2 researchers evaluate all the trees with 3 of the 9 experimental conditions. For manually designed trees, the researchers saw that all 3 had zombies manually wandering around the map, and then switching immediately to chase making as soon as they spot them. The manual R2 tree used a specially made custom node to combine selecting and moving to random nearby locations. We did not provide this node to the evolution because it combined all of that logic in one node, which trivialized the implementation of random wandering. And manual R1 tree had logic to specifically stay close to and search right around the last known location where it was seen when it was tracked. Random baseline behavior trees do not show nearly this level of complexity in behavior. They never successfully switch between random versus chasing intelligently. Almost all the random baseline trees only chase enemies, with a few exceptions of trees that do a bit of wandering like movement, but never chase enemies. Sometimes the random baseline trees use behavior tree nodes that just move directly to its location without pathfinding, so those zombies often get stuck in obstacles. You can see the one on the screen there is a very similar tree. The evolved behavior trees did, at least on many of the conditions, exhibit successful switching between random wandering versus chasing enemies. In these successful cases, they exhibit behavior fairly similar to human designed trees, and especially to the manual R3 tree. They did not successfully evolve this in some conditions, especially on the small map. On that small map, most evolved zombies just chase without control. Also, some evolved zombies, like some random ones, use the nodes that just move directly to its location without pathfinding. And we don't see any evolved zombies that successfully patrol right next to the last known enemy location, like the manual R1 tree. So, outside of just evaluating how it works, what do we learn? We saw significant challenges for future research to make this tool more effective. These challenges involve helping designers with defining functional parameters, visualizing and selecting resulting trees, speeding up development, selecting how granular the behavior tree node should be, and creating MPC logic that runs outside behavior trees, perception, etc. We also should consider the ethical implications of the experiments around this work. So first, we developed evolved behavior only for games, but behavior trees are also used for the simulation of robotics research, including some related to military health. Now, we've taken a small step towards preventing this use in our work by including a prohibition against military and law enforcement use of evolved behavior. Secondly, when we build tools to automate part of the work that humans currently do, especially under current conditions of capitalism, we risk harming the people doing that. Thus, we aim to use co-design and recursive co-design to develop evolving behavior with the direct input of game developers, especially developers working in small teams and who are marginalized by the economic industry. Finally, research on evolutionary algorithms has been metaphors that relate virtual evolution to real-world natural evolution. But these metaphors not move forward, they were actually to add evolution on those two genes. Now, we did not have room to fully explore these complex issues in the paper. There's a little more detail than what I just talked about. We support the call by Cook for further work to evaluate these sorts of issues and further this conversation in the future. This experiment still has several limitations which give us some ideas for the future. First, dog behavior is pretty simple. We can easily construct a tree by hand. So a more complete game would be better for really testing usefulness and limitations of the system. Also, researchers serve as game designers for the study, but gathering external perspectives from actual practicing providers will be important. So we expect to perform future studies with independent game developers for that. Finally, we do not have enough experimental conditions to reveal statistically significant differences between all outputs, at least with the non-parametric statistics we used. We do believe that our qualitative analysis helps to verify the results, but we do expect to perform future testing for revalidating the effectiveness of model behavior. We released the evolving behavior tool in the example project to be downloaded today. The code is available on GitLab. We'd love to have you use it and try it. It's coming back. Thanks again to all my collaborators who worked on the larger evolving behavior project. And thank you all. What questions?
Any questions? I have a question. Is that tool, like that module you add on the, can you edit the trees in it easily after you generate them, or like it's not a big deal?
Sorry, can you repeat it for you? Sorry.
I was just asking is it easy to edit the trees and generate them so you can define some of the behavior after you got the output from the fitness and everything, or like there's no UI right now in the tool?
Yeah, so thanks for asking. So because we're working with Unreal, which already has built-in behavior tree editor, you can visualize the trees directly in its editor, modify them. It does all that for us, so we didn't have to write all that stuff in it.
Thank you.
All right, got another question.
Thank you for the interesting talk. I was wondering if you could comment on, so this technique works on visual programming language for that is applied to games. What are your views on using visual programming languages for games and performing research on that in a wider sense? Do you believe there are more opportunities for that?
I think I heard the question.
Can you repeat that?
Sorry, we had to run down. Can you repeat the answer again? Sorry.
Yeah, so yeah, I think this technique could probably work with other visual programming language kinds of things. We haven't tested that obviously, but especially if they have like a tree structure, if they have loops and graphs, things like that, that might change it, might make it more difficult. But I think it probably could be done or worked around with maybe a modification of this could work. And I think visual programming languages have just a great accessibility and they're being used a lot in Unreal and Unity. So I think it's a really good avenue for future research.
Awesome. Thank you, Nathan. Are there any more questions? Yeah, okay. All right, give us a second, Nathan.
Hello, thank you for your talk. I was wondering, I didn't quite catch this from the talk, but when you were evolving behavior trees, was there ever issues with generating invalid trees? Was this a significant issue you had to overcome?
Just 1 second. You only have one mic.
Sorry.
Oh, the last part. What's the last part?
Invalid trees, when is evolving. When you're evolving, were there any invalid trees or stuff that didn't work?
Okay, go ahead. Were there any invalid trees that just didn't work with the efficacy taker, with the evolution there? Yeah.
Yes, sorry, thank you. Yes, so there are probably many invalid trees, or trees that don't really act at all or don't move the agents at all. But because we're generating hundreds and hundreds of trees over the course of 1,000 generations, most of those invalid trees get filtered out very quickly, or only last for a generation or two. And there's other trees that do have take some action, get some higher fitness. So yes, you can generate a lot of invalid trees, but hopefully you can just kind of filter those out and focus on the ones that do work. Now there is a risk of generating trees that are like infinite loops, and we ended up having to remove one node that was causing like generating trees that had infinite loops in them that would just crash them or infinitely hang the system. So it might be worth investigating like how do you make sure that the tree system can do that as much as possible. Obviously, all the departments you probably can't do for sure, but how can we avoid it for the most part? So yeah, it's an interesting question. Thank you.
Awesome. Thank you, Nathan. I think that's all the time we have for this part. So give Nathan a hand. Okay, give us a second to set up for the next talk, Marcus. Everybody can see me. How do you do that thing with the? Oh, never mind. All right. Oh, hang on. Give us a second, Marcus. Screen, maybe? Marcus, I remember there was like one way in a window. Oh, there we go. Okay, cool. Okay, Marcus, can you hear us? Okay. Give us a second. Give you a proper introduction. Okay, so this is Marcus speaker with Instant Architecture in Minecraft using box split frameworks. So take it away, please.
Okay, well, thank you. Let me start by saying congratulations to the person who did this. But I would get that FDG was so people and I'll talk about my work for just like this architecture. I'm not using box split frameworks. I'm not using from hardware. So what's it? It's basically a development system that uses frameworks to essentially generate content. So the structure is very fine. If you're not familiar, frameworks basically consist of words that describe what you take a piece and replace it with smaller pieces for the big languages. So here, for example, we have words that say you can take the soup or S and replace it with the sequence of saying S lowercase a. Usually, the algorithms are very, very similar to some soup words. So basically, what you have to do is to repeat between the S, replace it with lowercase a, or followed by A, or other word E, followed by S, followed by B, or you can replace it with epsilon, which is not. And as you keep replacing the S, you basically get the content of the string. These memory systems are easily popular to generate text because well, they're created for parsing whatever language text. You can also see this as a binary computation. Basically, you say I have S, and what was chips with other pieces of chips according to this rules. Now, the problem with this is, in order to apply it would have to perform some complex geometric theory to see if the shape that should be on the left-hand side of the board occurs anywhere within possible left-hand. So let's start with that. And this is where the view of grammars as an alignment operation comes. Basically, what we do is say, well, what is a building? Building consists of multiple floors. So you can say we have a larger thing, the building, and then we split it into smaller pieces, each of which is a floor. And then we can take each floor and split it into smaller pieces to turn four basic floors. And then for each floor, maybe we can split it into smaller pieces that define where different pieces of furniture. And that's basically the idea behind split grammars. Now, an additional problem to present itself, if we talk about 3D structures with text, it was rather easy to just say we have a string and we split it in left to right, left to right. The matter has only one dimension. But when we talk about three-dimensional structures and we want to split the three-dimensional box into smaller pieces, we need to somehow define not just in each dimension, but also what the size of the pieces should be. So that's basically the idea behind split grammars. We take a box, we define which dimension we split it into, we define the size of the smaller boxes, and then we give each of the smaller boxes another variable assigned to it. And this next variable defines what further goes to the data. Okay, so completing for this example, we take a box, and the box started to be labeled as an N. One of the possible words that we could apply to that box might be this one that says take the box, split it in X direction, where the first piece will have 1 unit of size, the second will have 2 units of size, and the third one will have 1 unit of size again. Then, so the size, then you assign the label, the variable A to the first piece, you assign the variable E to the second piece, the variable C to the third piece. And then there will be further rules in the grammar that define how these smaller boxes are then subsequently split. And at some point we just say, well, we have a box with label B, let's say, and we replace it with a complete material. So that's the idea behind split grammars. All of these has existed before. The problem with this, one of the challenges with this is how do you actually write this as some sort of code, some sort of input. And what I've been working on is basically a system that allows you to write such grammar rules as Python code, and then use it within Python. So, how does a rule like that, what would a rule like that look like in Python? Basically, each of the rules in the split grammar is a straight formatization in Python. You just say the left-hand side of the word defines the function name, and then on the right-hand side of the word you say which operation you want to perform, which split among which direction and with which sizes you want to perform, and then you can apply the labels to each of these new boxes by calling the corresponding function. So this is nice because you can literally take a formal grammar definition, then something that may come from elsewhere, learning you may have maybe another generator that generates grammar rules, whatever way you can write it, and you can translate them straightforwardly into Python. Now, one thing that looks kind of weird here, right, is I said there could be multiple cores or non-terminals. And how do we associate the box with a non-terminal super in our system? We just call it a function. So if you think about function cores, they would just take a specific piece of code and execute them. But if you want to use it for content generation, and there are multiple cores that would apply, mentioned is decorated with a special decorative function or which itself actually decorates the function, or actually defining the function for n that is specific this will register this function in the dictionary, and then later on when you word n for another word for a, it will look up all the functions that are defined with that name and pick one of them. This is kind of like for programming, this will be very good. Programming is never constant. For residential content generation, this is very useful because now you can do things like, oh, define or both, and then define 5 different modes for different styles of schools. And whenever I want to do the move on the building, it will pick and thus we get variety. But it goes even further. Because this word decorator doesn't just pick any of these defined words, it picks one that is applicable. What does applicable mean? Well, in our example so far, it has been negative. But in addition to just being able to define words, like straightforward words, we go to place constraints on them. So, for example, we will recast, we will have candidation, or what does that consist of? We basically have order and it's order and so on. Depending on whether the board has even or odd length, the calculations will be different. Right? If you have odd length, you start with again. The last piece will also be between them it's a 4 again, it's a 4 again, and so on. If the length is even, then the first or the last one will be a gap, and on the other end you will have a piece of 4. This is not a very big distinction. This is like the simplest application for these word constants. And you can express them in our Python code by saying, well, on this word there exists a constraint that says the x dimension when you divide by 2 has to be made of. And then we have a word that applies in this situation. And then we might also have a different word that applies in the neighborhood by 2 is 0. And then what this word decorator will do, when you call this calculation functions, it will check which context is according which box is applied to, and it will only apply one of the functions where the concept is set. You can also do other things with this word decorator. You don't have to calculate each of the words with equal probability. You can say others different probabilities for different instances of each word. So you have 2 words per n. You can say this one it's probability 4, this is not really probability. The other one is probability 1. Each of these values will be taken and normalized. And this again interacts really nicely with word constraints. It actually first checks the constraints and then takes the probabilities for the applicable words, normalizes them with probabilities, and then corresponds them at random depending on its probabilities. So this interaction is really nice. And it allows you to do things like I want a particular style of word decoration, but not too often, and I only want situations that are big. So it can only occur on the surface. What the focus of this project was to provide a system that can be used within Minecraft and specifically within MCA. But the system itself is domain agnostic. So there's a large on-screen grammar system, it's this word decorator that actually was sort of splitting and so on. There's a bunch of things that we'll get into, like you can have loops really nicely, you can have relative sizes, you can change the coordinate system and so on. And in addition to this larger system, there's a tiny adapter that defines how you use it in Minecraft. What does this adapter do? Basically just says, if you have a kernel user, how do you actually use it with you? And how do you get the initial ones? But since those are the only 2 things you need, you can also integrate it really nicely with whatever other piece of code you want to use. If you generate an entire city if the product is around, then if the product is behind. So behind this product is a chamber, there's standard chambers, and you can express all of these with words. You can have three constraints based on how high is the temperatures, depends on the products, etc. So with just a simple pair with 40 words, you basically generate light and eye with different temporary layouts. And note, basically the same you select the box into the size of the camera and determines which kind of camera would fit within that size. And this is just a selection of the view that we generate. Of course, I both sides. This is like temporary style of that marker. And I hope when you see the tutorial, you can see the little article, you can compare it to this. It's actually really nice. And I don't have to have that on slides, but it's only 40 words, 20 words is software and everything. Okay, so this was my presentation. You can find a lot more details about all of this in the paper. You can also find it on GitHub, slides, websites. You can ask me Twitter or Discord if you have questions or if you have time now. I also have questions. Thank you.
Thank you, Marcus. Do we have any questions in the audience?
I could just like say very loudly. I don't know if it's gonna be. What? I don't know if it's gonna be.
Give us a second, Marcus.
Hi, Marcus. Okay. Hi, Marcus. Hi, Marcus.
Can you hear him?
Hi.
Okay. Yeah, I can.
Okay.
Just give us, yeah, hang on.
Hi, Marcus.
We have one mic, sorry, so we're just kind of going back.
My question is there a possibility to learn these rules from existing structures?
Did you hear that? Okay. You know what we can do is just third question. Christoph asks, is there a possibility to learn from existing structures?
So, yes, one of the purposes of this entire exercise is that the course is actually Python available in order to allow learning from complete examples and actually selecting course from other data sources. So, machine learning system uses a bunch of topics and maybe so, yes, absolutely. I didn't actually know this in other language because it's Python. You can also do a lot of irregular things, and the grammar system actually works really nicely. You just do bits and pieces of it. But yes, the main purpose is to make it regular, make it generated.
We only have time for one question, but thank you so much, Marcus. It was fantastic talk. Okay. All right, and our next presentation is by Robert Bishop on the effects of human-like modifications to heuristic action evaluation in video game pathfinding. You ready for us? Can you raise your mic a little bit higher? It's still a little bit low. Sorry, we have a really bad AV system.
No, that's fine.
Oh, that's perfect. Yeah, perfect.
Okay, excellent. Hello, everyone. My name is Rob Bishop. I'm presenting on behalf of myself and the attorney from the University of Newfoundland. Sorry, we can't be there. And we'd like to share your findings on the effects of viewpoint modifications to heuristic action evaluations in video game pathfinding. So we're going to take you through here at a high level to why we chose this area for research and present some of our findings. So, a brief talk
Super Mario Brothers and difficulty in the modern age. In 2009, Nintendo introduced this new feature called the Super Gun, where if you were failing in a level, a prompt would come up, you could hit a button, and you could watch a human being play through the level from beginning to end, pre-recorded. This was, human recording beforehand. So obviously that takes a bit of time, human hours to put that in the works. That's obviously not ideal. We should see that thing if we automate this. More recently, they've introduced the Super Mario Maker series, in which anyone can make an arbitrary Mario level and put it online. But before you can let other people play this game, you have to play it yourself and beat it to prove that it is beatable. And then after it's beaten, based on your playthrough and the playthrough of other people who play it, the difficulty is determined dynamically. And importantly, that difficulty is not static. So there have been situations where a player has played a hard level, trying very hard at it, can't get it, they're frustrated. You come back a day or two later and you see, oh, now it's been classified as an expert level. It's very frustrating. So of course that begs the question, can we automatically determine how to play through a level? And of course, yes, you can. It's been a thing for a while. This is a video that went viral on YouTube called Mario, in which neural network was trained to play Super Mario. But part of the reason I think for its virality was not just that it's an AI play Mario, but because the play is so obviously weird and superhuman. It doesn't play like anything living, it narrowly avoids danger. It's strange to look at. But that's where it was intended, of course. Pathfinding is an optimization problem, where reaching the goal is the only goal. So what do we do to maybe change that? Well, the biggest entry to this sort of question was the Turing Test back in 2012 Mario AI Championship, which I believe was run by some people at this conference, in which AI agents were arranged to mimic human play every junction, as per the Turing Test by a panel of human beings who didn't know if they were looking at human play or AI. So we wanted to go in a bit of a different direction for this. We want to generate AI guidelines for arbitrary levels. So similar to what you saw in the Turing track, we want the play to be reachable. We would like it to avoid danger, but we don't want to focus on emulating flaws, like stopping for arbitrary lengths of time or exploring areas that aren't related to the goal. We want it to be parameterizable, so we can change it and adapt it to different levels of play. So we are essentially trying to make a Mario GPS system. So to this end, we constructed our own engine in C++ that allows us to save replay files as a list of actions, and it lists the frame on which those actions occur, very much in the Doom style of replay. We've baked in our own custom A-star implementation, and it can be used on any arbitrary. The pathfinding system knows nothing about Mario, platformers, jumpers, none of that. It just gets actions and saves. So one of the things that's fairly industry standard when you're doing a heuristic search through data states like this is the concept of simulation frames or skip frames. So when you decide to take an action, move right, then instead of advancing to the next frame and making another decision, you make a number of simulated frames. This is done to reduce complexity, but you can still achieve great results. As you can see here, the Google DeepMind target used 4 simulation frames, which amounts to one action every 67 milliseconds, and was still able to outperform humans on many days. So one of your first thoughts might be, okay, you can increase the simulation frames, match it to human speeds. So with 250 milliseconds given the typical human reaction time, let's just set 16 simulation frames to see what happens. Well, as you can see from our legally distinct Mega Mario here, that's not very good. He's told to move from that height on the top right to the platform on the top left of a jump in this engine that can be easily made, and yet you get this circuitous movement. And that's because a very high level of skip frames causes misalignment. Your movement essentially becomes discretized. And in order to realign yourself with the grid, you might have to push yourself up against an edge. You might miss these Goldilocks zones. So we completely discarded this as a useful modifier. So what we did end up finding were a number of action value modifiers. So these are multipliers to the heuristic cost function of the A-star algorithm. We're trying to punish what we call superhuman play by inflating perceived likelihood of difficult paths based on the frequency and timing of actions. So we present 4 here today, the action gauge, consecutive action, and progressive consecutive. And I'll show you where they come from and what they look like. It is important to note that in our case, an action equates to pressing or releasing a button. So performing no action doesn't mean do nothing, it means change nothing. So if you press a button down, and then 4 frames later we say, what action should you you're still holding the button down. It's kind of important. Because the first one we're going to be looking at is the no-op modifier. So this conducts a search with a low-level frame simulation, but we emphasize doing nothing. So the do nothing or change nothing for action ends up being stored artificially low. So paths that have longer stretches of doing nothing are seen by the pathfinding algorithm as shorter. And this is kind of what that looks like. So you can see the default behavior here in black, and then the no-op modified behavior in white. As you can see, it's more inclined to not readjust as quickly. It looks pretty good. Unfortunately, if you set the values too high, then paths of doing long stretches of nothing become really attractive. So you end up with a path that, yes, might be smooth, but it's very unnatural. So then we try the inverse of this by what we call the action change modifier. So rather than incentivizing monotony, we punish taking action. So anytime you choose to take an action, the perceived length of the path becomes artificially lengthened by the heuristic. And here's a bit what that looks like. So in the black and white path, every time it changes from black to white, or vice versa, that means a button has been pressed or released by the system. And as you can see, black and white, which is default behavior, has 9 changes of actions throughout this path. Red and green, meanwhile, obviously making fewer jumps, only has 5 action changes. So this is fairly promising. However, it's a problem we discovered when we were investigating it, and that's that it can be a little funky. Because the penalty is applied directly to actions, it has a tendency to do long stretches of nothing and try and catch up at the end. And that's what this looks like. So red and green is our modified behavior with the value set a little artificially high. But both of these paths have exactly 3 actions, but arguably, in this case, the default black and white is much more natural. So that led us to this idea, the second action modifier. So rather than penalize taking an action at all, we're going to penalize taking actions shortly after taking the previous action, with the idea that we should hopefully spread them out along the path. And this consists of 2 values this time. We choose a frame window, number of frames in which you want to penalize another action immediately, and then a penalty, a multiplier value, which is the perceived length of the path. And here's what this looks like in another example. Again, we have default behavior in black and white, and we have our behavior in red and green. And as you can see by limiting the number of actions as well as the frequency, it tends to spread them out. Red and green are fairly evenly spaced. And again, it takes 5 actions in this case versus 7 for the default. And the last one we had a look at was the progressive consecutive action modifier. I know it's a bit of a mouthful, but essentially it's the same as the previous. But rather than use a strict threshold, as you can see in this simple visual example, rather than a strict threshold, has it been as many frames punched? Has it been as many frames not punched? We do a linear flow off of the multiple value in hopes that maybe this can generate more natural paths. But at this point, just right-clicking in our engine, looking at it, could tell us which was objectively better. So we decided to run on a fairly large-scale experiment to directly compare each of these modified behaviors against the default behavior. So we downloaded the entirety of Super Mario Bros. Original NES game from the VGLC video game level corpus, an excellent online data set. We select a random start and end point about a stream and a half away. And then we run each instance of our search, we gather a bunch of data, and we repeat this a lot of times. We tracked a large number of metrics, some of the most important of which happens to here, obviously total number of actions, how many buttons were pressed throughout the experiment. The mean time between actions, or if you prefer. This third one is the shortest duration between actions per path. That can be a bit confusing, but what it means is once a path is selected, how quickly would you have to press 2 buttons to get through that path? So you might have a long stretch of doing nothing, but then at the very end, if you have to make 4 frame per jumps really quickly, well, the average time between presses would be high, but we would still think that is a difficult path to try and perform ourselves. So we're looking at the shortest time there. We track the total distance of travel time, and then a concept called robustness, which we'll get to in a bit. So here we can see the total number of action changes. These are the modifiers as I put from left to right. The rightmost is a combo multiplier. Because all of these modifiers are simply multiplicative values to the heuristic, you can actually provide any amount. So we ran a search, we found the best values for each of these individually before we put them together, and we took all of them together, simply mixed them together to make this combo super strong. And yeah, as you can see, there's quite a bit of fallout, especially when we get to these last 2 elements. These are what we call window elements, because they include penalizing subsequent actions within a window. And they were fairly promising. as you can see, they get better, especially again with our combo being the best. Now, one of the questions you might obviously have is, well, simply lengthening the path to do this, right? You can just take longer paths. And we found that no. In fact, the distance between default behavior and the longest performing behavior, again, in this case the combo, was less than 2%, which amounts to about 4 seconds over the 16.5 minutes of real-time gameplay that was generated here, which is enough to beat the original Super Mario Bros. 3 times over, which is very fast. So now we get to the concept of robustness. This is a form of sensitivity analysis where we want to see how sensitive these paths are to small changes in conditions. So what we do is we add offsets to keep our timings. So for example, if the search algorithm says, okay, you advance and you jump on frame 20. Well, what happens if you jump on frame 21? What happens if you jump on frame 19 instead? This emulates what would happen if a human being were to attempt to follow this path, because of course we're not perfect. And as you can see in this example here, it looks like the algorithm has waited a very long time before telling this character to jump off the edge. And certainly, by perturbing the paths, by changing the start and end times, a lot of them end up in that pit, which is not good. So we track 2 metrics related to this perturbed behavior. The survival rate, i.e. what percentage of the perturbed paths fall down a pit, as well as the sum and distance from the goal. So you take all the resulting paths, and then you sum up their distance to the true end of the path, and how far away we're. And these are both values we want to minimize. So here you can see the perturbed death rate. So in our default HR search algorithm, about 12% of the perturbed paths will fall down a pit and reach a fail state. And as you can see, that decreases, but it decreases significantly when you get to those window action parameters, less than half for the consecutive action modifier, which was actually the best. Similarly, the mean end distance of all the perturbed paths has a similar fall-off when you get to these last 2 modifiers, indicating that more of them are getting closer to the end result. So we were really excited about this because robustness was, unlike timing, it was not something that we explicitly programmed for. Resilience to noise and this survivability taking safer paths, this merely emerged as a result of us attempting to mimic human reaction time. And most exciting, we found that the resultant paths actually visually appear safer. Here's a very simple but I believe effective example of what we're talking about. Black is the default behavior, and white is that combo metric that I was talking about earlier. All of the different parameters combined to vary degrees. And it wasn't told avoid hits. It wasn't told that. It was merely told to space out actions, perform more like a human would. And yet the result is a path that's not only easier for a human being to perform, it ends up being a little safer to follow. So in the end, we've shown that we were able to produce paths with demonstrably fewer actions, a lower required reaction time to follow the path, and better resilience to noise. There's definitely some areas of study you'd be interested in taking this in. Of course, generalizing this into other games, there's no reason it explicitly has to be a platform. And we'd also like to use it, as I said at the beginning, for difficulty estimation by changing the parameters of this path and seeing if it's able to complete a level. We're hoping to get a sense of automated difficulty estimation, so players don't have to throw hundreds of attempts into Mario Maker levels. Okay, so that should be it. And if there are any questions, I'll happily take them now.
Thank you. Are there any questions for Robert? No, I'm just asking to see if there's questions. I have a question though. So, I know at the beginning of the talk, awesome, fantastic visuals by the way. It was very clear to see the it was Patrick where? Oh, awesome. Awesome. So the question is, I forgot it already. So you had mentioned the Turing test at the beginning of your slides. Did you ever perform a Turing test now that you have these really natural looking agents to see, all right, which one is like a human player and which one is an agent player?
That was definitely discussed by myself and David, but we haven't had a chance to get around to it for many reasons.
Okay.
But it would be very interesting for sure.
Definitely. Looking forward to it. Any other questions? Yeah. you have a question, can you give us a second? We're just like swapping mics between people, so. Okay.
Yeah, the question is whether you've thought about using this technique to make like a companion AI, sort of like in like the Lego, kind of game for which this companion is sort of along with you. I can imagine this maybe work well.
I'm sorry, I don't know what
Companion AI, again, like the Lego games that would like follow you around, like do platforming with you, if that makes sense.
That's an interesting idea. I hadn't thought of that now, but it definitely could be interesting because if you had a game like that follows you around, then believability in games like that is very important to the players. So I can see it being useful, definitely, but we haven't considered it for AI. We're just trying to generate nice looking guide paths because it's been a thing, especially as big like about cyber. It seems that generating natural human paths is still something to go with some data science.
Sure. Okay, do you have time for another question? Okay, I think that's it. Thank you so much, Robert. Okay, go on to the last speaker of the session. It's gonna be, yes, on the paper, towards non-technical design or control over PCG systems, investigating an example-based mechanism for controlling craft printers. Are you ready?
Can you hear me?
Yes, can you talk one more time?
Can you hear me?
Yep, hang on.
Yes, there is some covering from Zoom.
Oh, okay.
You know that's share the screen.
Yes, there's something covering your.
The Zoom parts are covering your shared screen, like the floating windows from Zoom.
Right. Are you sharing like a tab or your entire screen?
Let me try this again. Is it still there?
Yes. You have like a shared tab selection?
Yeah,
It doesn't seem to be showing up for me.
Okay.
See if I can do this.
That's pretty good. I think if you zoom out, yeah, it should work. Oh, that's good. Wait, is this still showing the?
Showing this one.
Yeah, it's still showing this. Can you minimize the participants window on the side that you have?
Oh, this one.
Yeah. Probably. That's better, yeah. Yeah, perfect. Okay.
Is that good enough? Sorry.
Yeah, that's perfect. Thank you. Sorry about that.
Sorry about that. Hi, everybody. My name is Abdulrahman Makur. I don't know my last name, Makur. Pronouns Nihan. I'm a PhD candidate at Northeastern University. Apologize for not being able to make it in person. Having an Egyptian passport sometimes causes some difficulties. But I'm grateful to be able to represent remotely. So today I am going to talk about sort of approaches for one for technical control of PCG systems. We're focusing on a specific graph grammar system, but some of these ideas will hopefully be transferable to other PCG systems. And so yeah, so that's where I'm at. Before we sort of get into let's talk about innovation and background, why you should care about any of this. Just a fair warning, controversial hot take incoming. PCG is hard. So a lot of times in research in this area, we try to focus on coming up with sophisticated AI techniques to come up with to generate these creative artifacts and the automated design process, which is cool, so we can do from a computer science perspective.
But in terms of coming up with a designer tool, we were not there yet. And so a lot of research is also focused on not outside just like getting the items to generate things, about coming up with ways to sort of avoid BCG systems that allow designers to sort of impart their design knowledge into the content generator or specifying the content generator. Things like SSL programming, which like is sort of like this logic programming, logic program that is generated, or grammar system, example of grammar system like Trisri, which I'm sure you've all seen before. And so these systems that offer sort of directly specify the design intent. They tend to be either sort of specific to a specific context, like Trisri is amazing, but you can't use it for everything. And MCSR programming is great, but you still need some sort of technical background to be able to use it. And so that's some of the drawbacks of these approaches. It's not another thing that's worth sort of talking about. It's sort of co-creative tools that sort of try to incorporate designers in generation process. In terms of exploring how designers are going to interact with AI systems. But these approaches.
Hello, Robert? Oh, yeah, okay. I think your slides are kind of dark, or a little, like, dimmed. Yeah, okay, now we're... Is
this better?
Yes, much better. Thank you. Sorry.
Yeah, sorry about that. So, so these co-creative tools to sort of focus on artifact generation and not helping designers come up generated. So despite sort of exploring model requirements, it's still kind of difficult for game heads to sort of incorporate them in the game design pipeline. So some papers sort of exploring why that is. But one thing that is natural, and it's also another controversial thing, is that game dev is hard. And so in addition to all the concerns that game devs have to deal with, like functional designs, getting characters not all, and gamers do gamers, they probably, it's probably a common aspect of also thinking about various complicated AI techniques. And so it's kind of important to have things be sort of useful for gamers. And so naturally, a lot of the content generation systems we're using game dev are things that either have an established system built on top of it. So most of them are based on programmers, like City Engine, for example, which is like this very established commercial software for generating buildings and cities, or SpeedTree, which is sort of like an industry standard for generating trees, or specific niche parameters that generate, if you want, come up with parameters that generate specific type of content, like the grammar used for borderlines. And that has its own issues. And so grammars have been sort of useful and sort of relatively easy to incorporate in one game dev pipelines. But grammars have this one drawback, is that grammars is hard. They might be easy in concept to understand, place the left-hand side and the right-hand side, but reasoning about grammars and how they sort of operate, how they, each rule in the grammar affects the end product is not necessarily a natural method. It takes a little bit of experience and understanding of how each rule affects the end. And so some work that tries to address this sort of looked at measuring the quality of grammars and trying to sort of come up with tools for debugging grammars. As each one of the slide work is, it still requires a set of technical expertise to be able to do that. And so one thing we were trying to tackle is sort of how to get non-technical designers to sort of use and interact and possibly define content generators. Another relevant work that is going to be sort of pivotal for the system that we'll be discussing is going to all work on generating solver levels. So this paper talked about this pipeline for generating function levels or solver-like levels, where they separate the generation process into multiple phases. The two main ones are emission and space, and the order, configuration, what we do in the level spaces, where we do it. And so the mission is sort of this graph representation of what you do in the level, and drawings that all propose these graph drivers to generate that, and that's sort of the artifact that we're using generating this data work, and sort of demonstrating the system using. So generative grammars have also this problem of, have this consequence of having a lot of possibility spaces. You get one combinatorial story of possibilities, and so be able to control generative grammars is also propose a way for designers to sort of control it using these things called recipes, which we will talk about a bit more detail later on. But essentially, what these recipes are is that instead of saying the grammar, hey, apply whatever rule is applicable, you say, you basically specify exactly what rules to apply and in what order, and the stochasticity comes in when the rule gets applied, and you also have this other parameterization of apply the rule X amount of time, where X is the distribution. So the question that we're trying to answer is, how do we provide a means to control these two systems that allows designers to reason about the endpoint explicitly? So a lot of these things that we talked about sort of have come from thinking about the underlying attributes. So in terms of grammars, we're thinking about how grammars work, how grammar rules work, even with designer recipes, the drawings also work. We still have to think about grammar rules, which is useful when you know what grammars are, but it might be less useful because you still have to make that mapping. If you're not familiar with grammars, you still have to make that mapping between how the rules affect to generate specifically. And so things that, ways in which we reason about the end product of generators is this thing that you might have heard of called expressive range analysis, in which you sort of have a generator and you sort of compute a metric for the things it generates. Those metrics capture something of interest. They may not necessarily capture the full nuances of what the area of redundancy is, but suits for cows. And you draw it like a heat map or a scatter plot or something. And so that's sort of very widespread in pieces of literature, of course, that you know. It's a way of evaluating, and also as a process, as a way for sort of guiding the design process of the So if you're like me, like if you want to walk in the development system, that uses expressive range analysis to sort of directly control the content. And then you realize that might beat to it. Danish, I don't know if this is Arabic or Farsi, I apologize if it's Arabic. Good way to mispronounce it. Danish is this system by Mike Cook and others that lets you sort of explore common generators here. It's an example of the Silver Automata system that so you can sort of explore the generator space of the Silver Automata, sort of adjust its parameters and see how it affects expressive range analysis of the expressive range of your generator, and it can also sort of have some functionality for addressing the generator for specific areas in the expressive range, but it doesn't allow for the exact interaction mechanism that we'll be describing, and it doesn't use the same wording mechanism. So what can we do? Essentially, we can summarize the work. It's in this 30-second GIF, where basically we have the system that sort of displays the expressive range analysis of the levels of a generated by a graph grammarly. This is the exact graph grammarly proposed to doing all work. And again, you see here, you select a region, you click train, and the generator sort of tries to generate levels that fit that region. And the way it does that is in the paper. I don't have time to get into it, but it's a relatively straightforward sort of probability. And so what they want to find out is that this interface sort of provides usable designers can control the shape of the general space, like the general space in general. And so we ran a study. We compared two interfaces. There's an example of this interface and the rest of this interface that we'll discuss in the next slide. And if for example, this system is more usable, at least in some design scenarios, then maybe it isn't. And so the interface is compared against this expressivity-based interface, where it's inspired by levels as well, where designers can sort of look at the grammar and the rules that the grammar has, And then once they've done that, they can write a recipe, and like two recipes are just exact rules of what the ground entails, and you can pick the rules that are applicable, and you can only pick rules that are applicable given the rules of the recipe, and then sort of apply the recipe and sort of do that to sort of, generate, also the generator will come up with specific substitutes. And so we ran a study of Northeastern students, students that were taking a generative design class. The students were familiar with what renders are. They covered it in class, but didn't have like hands-on experience necessarily. And they were game design students. Some of them had some design experience, some of them did not. And we asked them to basically perform 7 design tasks using 2 systems. And we asked them, took the generators, the resulting generators from those tasks, and compared the two, and also asked them about their experiences using those systems. 7 of the tasks that we had them do, out of 7 of them, 5 directly mapped to the metrics using explicit range analysis, applied using the system, and 2 of them are just things that require more nuanced control or fine-tuned control. And so our hypothesis was for those 5 tasks, the example-based technique would be a bit easier to use and also probably more effective in sort of shifting generators. And so how do we do? There's a much more details on sort of study and the results of the study in the paper. This is just sort of summarizing it briefly here. Essentially, example-based hypothesis is essentially like the example-based. This is like the average relevant metric for each of the system of all of the generators that the participants generated. And you can see for the example-based has lower needs when they were asking to lower needs, higher needs when they were asking to higher needs, and so forth. So for the first 5 tasks, the example-based systems will perform better. And for the second, the last 2 tasks, the recipe-based perform better. And when we ask designers what they thought, this is what they told us. This is like a summary of some of the responses that they gave us. Basically, asked them how easy do you think using this example-based system for accomplishing a task is able to set so Q0 is like how easy it is in general. Q1 to Q7 is how easy it was to accomplish each task. And you see that it's generally relatively easy to accomplish at least the first 5 tasks with the example-based system. The latter should be a little bit difficult. And with the recipe-based system, you see sort of the opposite happening, where the things that map directly to the exam, the metrics, are a little bit more difficult, while things that map directly, don't map directly to the metrics they find good to be able to. And so briefly before we go to questions, we can discuss the limitations of this study. We did not sell any boards. This was a company from this was not coming from the company I'm using for these slides. I found it was funny, so I kept it. So there are 4 main limitations of this work. One is technical limitation, where the learning mechanism we're using to adjust the generator is a simple sort of probability learning mechanism that can be sort of made more sophisticated. We're not learning grammar rules, so we're not doing any parsing. It's pretty straightforward probability based on the frequency of replications. The evaluation of the data with the novice designer and designers actually think of context. The metrics we use are simplistic. We assume spherical cows do not exist. And the system does require an established grammar, which if you don't already have a grammar, that might be a good thing. So that does not solve that issue. In conclusion, or brief to summarize what we talked about, we introduced this interaction mechanism using explicit range analysis and example selection. We hopefully demonstrate that this is has potential for being useful means for design control. And really, the thing that, like, if there's any takeaway from this talk at all, basically, we hope to encourage more work in the space of coming up with ways and tools for incorporating designers in the design process of the generator. If you want TCG to sort of be an artistic tool that designers use, I believe it's very important that designers are not just involved in creation of a single artifact, but generating the generator itself. And Obviously, the progress in making these things more useful and as much as the tool will make it more widespread and sort of increase the design tools that they have. But thanks to all the FDG reviewers, Nathan for being also people generally and how this work. Apologies for the technical difficulties and I can take questions now.
You did great. Thank you so much. So we have the keynote about to start in about 2 minutes. So we have time for a question from the audience. Give us 1 second.
So if I understand this system correctly, you kind of select a region in the expressive range graph, and then it kind of helps design the grammar to hit that area. And I guess my question is, do you have a sense of, like, I think sometimes those expressive range graphs can be a little, like, it can be a little unclear, like, sort of what the actual geometry will be like that comes out. And I'm just wondering, if kind of using that expressive range graph, if any of your designers or any of the people that are studying that.
Oh, wait, speak a little bit closer about that last part.
Right. Yeah. So for those students in the study, did they find it difficult to try and kind of design by selecting regions of the expressive range graph?
Did you get that?
We find it difficult to
select regions of the expressive range graph.
The bigger region of the expressive range graph?
Yes.
Yeah.
So in the study, sort of staff to sort of maximize the specific machine learning. And so they didn't necessarily find it difficult to pick a region. One of the things that design participants mentioned is that it doesn't necessarily push it far enough in the region that they want. And that is a sort of a consequence of how learning happens. Essentially, since we're not really learning that, the consequences of what gets generated doesn't really change sort of the shape of the distribution. How often each thing gets generated. Basically, you can't generate more stuff. The Goma can generate is still what the Goma can generate. It's just about shifting the shape of distribution. Right? You can eliminate certain possibilities, and then certain possibilities are much more common. And so, if you want to maximize a certain metric, right, there's a limit to how far you can go with the current one. So selecting the region wasn't difficult. I hope that kind of answers the question.
Yeah, he's a thumbs up. We have another question in chat for Chris, but Chris, I'm sorry, we might have to skip the question. We really got to book it out of here. Oh, sorry, yeah, Tristan in the chat has a question for you, Michael, but we have to leave the room because of the okay, sounds good. But thank you so much for the talk. It was awesome. Thank you to everybody that attended the Game AI session. It was great. Thank you to all the speakers. And yeah, so see you later and come to the keynote. He killed the Zoom and okay.
Sorry. Did you forget something?
No, I'm trying to figure out like what picks that up because like it's like it's way too sensitive. Yeah. So I was just wondering, like, there's like a box like somewhere within 50 feet that has a knob on it.
This is just outside. Maybe
Yeah, I think. Yeah,
this is very sensitive, so you need to speak like this.
If you go closer, that's
Otherwise, I can give you my USB stick.
Yeah, I figured that.
Sorry if I'm touching you on the back. Can you please? I am closing the Zoom for a second because we set it up. All right. Do you have you need to change it to
Estamos right now. So I discussed with the metaverse people about moving them to room 2. The workshop, because room 2 is empty. So next concept that I posted this on Facebook. Yeah. They asked them first, and they were very happy. Yeah. No one responded.
But this is not a global.
Revelation.
It's getting increasingly complex and lovely stuff. Time, don't worry.
I don't know. You want to set up something in the okay. So just start sharing. Just
just a second.
Like this?
Yes. Yes. So this is good. So we try to make it into how can you run it's like this? Yep, that's what we need to see. And it's not perfect in some way. So easy to play.
Yeah, sure. Yes, yes. I'll just hand one.
Greetings and welcome again. This is the keynote for day 3. And you're all alive and awake, and I'm very impressed with the turnout. So thank you and congratulations. Again, I'm very happy to introduce you with one of our keynote speakers, and today we have a representative of the local community. In fact, Konstantinos Dimopoulos. Please give him a hand. Let's go. He's a very interesting person because he was trained as a city planner and he decided to apply that knowledge to virtual worlds and game worlds. He is also currently the director of a game development school here in Athens, so again, connection with the local community. And he does a bunch of things and collaborates with a bunch of people who writes also on magazines. One of the things he's best known for is a recent effort, which is a virtual cities atlas, right? A book that recently came out, and I'm pretty sure that you will discuss.
I will briefly
discuss. I don't have anything to add at the moment, and I'll be happy to take questions once he's finished. Ladies and gentlemen, Konstantinos Dimopoulos.
So thank you everyone. I think I won't introduce myself anymore. I will be talking about Utopia video games and this rather semi-successful title, playing the building blocks of Utopia talk. First of all, I want to see if this works. Yes, it works. So, what I am and what Stefano rather accurately described is a game designer, but also someone who is specializing as a gamer. That is someone who applies the logic of real-world urbanism and city planning and civic geography to video games. And my main job is actually working on games and making certain that their cities are interesting and memorable and make sense and are believable enough to help immerse players in them. Working on a variety of projects, such as the latest one is Online Forger or Sinking City, made by Game News, which is this game by mid-sized Dutch indie studio that actually understood very well that depicting a city goes beyond depicting its roads and its built environment. It actually extends into the people, into the society, into how things actually function. And they managed to create a very interesting and believable and actually a live world for players to play. He also worked in a variety of firms. As Stefano said, I'm also the head of games at SA College in Athens, and I'm currently involved in a variety of tiring but also interesting projects, which include the writing of a book I will not be mentioning yet, but the book I've written is Virtual Cities. It's an atlas and exploration of 50 of the more prominent and interesting game cities, at least according to how I look at things. I've also contributed chapters to books such as Chris Makeman's rather lovely game writing compendium. I've dabbled in analog game design, with mostly with a game called Ex Novo, which I did with Martin, a friend from Germany. It's a city building tool and game to create imaginary settlements following certain rules and prompts. Again, I'm based in Greece, where game development is slowly picking up. We have an increasing number of very competent and very interesting game studios that are attempting to break the language and the geographical barrier and actually find an international audience. Some of them are doing pretty well at that. And also, working in Greece, even remotely for me, in most cases, is something that helps me enjoy life a bit more. Something weird, I can explain on the reason. Anyway, enough about me, let's talk about game urbanism, and specifically about what a game urbanist would do. So first of all, and rather obviously, a game urbanist is someone who will design different structures and environments and systems, civic systems, and simulations of video games. They are also someone who will tend to steal a lot from real-life urbanism and engineering and architecture and geographic knowledge and apply this stolen knowledge in the appropriate way in a game. Because they also will have to apply level of game design to make their spaces work in this specific medium. A game urbanist also tries to simulate civic life, simulate civic society, occasionally even imply an economy that would make sense. Always abstracts heavily. Even the largest of the game cities, think something from a graphics of a game, is tiny when compared to a mid-range town of Greece. I mean, if you compare them, if you see how many buildings a game city has, you would see that it's really tiny. It's all smoke and mirrors. It's a variety of tricks to imply size and complexity that never really exists. Also, we tend to engage in world building. We tend to craft histories. We tend to craft small local narratives. We are very often asked to come up with civic concepts for our teams to work on. And we tend to stylize existing or historical cities and make them manageable within games, but also to create our own imaginary cities. And occasionally, this is more personal, I tend to wonder on the interplay between real and digital urban spaces, though quite frankly, this is not something that keeps me up at night. I mean, it's interesting, but what really keeps me up at night is my daughter. This is the reality. Now, what are gaming's virtual cities? This is also quite self-explanatory, but let's run through the list. So each and every city and urban environment found in the game is a virtual city. They aim to be believable illusions, places that can convince of their reality. They are game spaces, so they have to be approached by gaming's major disciplines. They are simulations, so it's up to a point, and that point will have to be defined depending on what the game aims to achieve. There are definitely narrative actors, and there are diegetic scenery. That is a type of scenery that can tell stories, that can sort of, in an environmental way, pass information to the player. They can be very busy showcases of world building, and it's way easier to condense a whole novel, exotic universe in a city than to effectively one whole continent. Cities are places where, spectacle sort of condenses and spectacle sort of takes its perfect physical form. They're very varied, just as cities in real life are. There are definitely the stages where gameplay, storytelling, and challenges and puzzles and whatever will have to happen. And finally, that they are very complex configurations, even if they're abstracted versions that have to be made legible, have to be easy to navigate, have to be easy to understand. Now, there have been actual games called Utopia, and I found about the older one, the one on the Mattel television, pretty recently. But before actually discussing, utopias and dystopias and how they interact with video game series and video games and how they can be enriched, I would like to take a very, very brief look at the relationship between utopia, utopian thought, and urban. You see, the thing is that even though utopia or any hopeful political program does not have to necessarily be urban, historically it has been predominantly expressed by imaginary cities. I mean, you have everything from Plato's Atlantis and its very legible concentric rings. You have, Moore's classic utopian urbanized island called Utopia, and 19th century's classic utopian schemes and even socialist utopias. They all came with schematics and drawings and very specific ideas from anomalies, from Owen's communities to the Finance there, and they all came, in this more or less urban form. The thing is that even though political programs and utopian thought does not have to be expressed in a special way, doing so makes it easier to comprehend, makes it easier to imagine. It actually even makes them easier to achieve. It gives them this sort of probability that really helps people be more willing to accept something completely new, something completely radical, perhaps. And the thing is that utopia does become political when people can imagine it. And that is democracy. I mean, just as difficult it would have been for a Roman citizen to imagine life without slaves. Even the concept of a slaveless society would be completely impossible and improbable. The same thing happens with us. We cannot imagine things that we have not yet experienced. We even have difficulty imagining stuff such as different economical systems. I mean, even when we depict feudal Europe in our stories and our fantasy settings and whatever, we tend to express it in a very, very capitalist way, because this is how we know that things work, at least for us. So the thing is, when you see something, when you experience something different, you can be helped in imagining how this difference will be expressed, how it would work in reality. And this is why all classical utopian schemes came with a lot of plans. They came with flowering clothes and detailed architectural concepts and even models. You had everything that you could use to try and convince your audience that this is something that can happen. This is something worth trying to imagine and actually realistic in a way. The reason why things were expressed on stage was to actually give them the concrete form, to make them feel plausible, to help people and audiences, the poor perhaps imagine what was up to them and imagine. And this is something that still works today, or in the 50s in the case of Franklin Wright. when you are presented with an idea that's completely novel, seeing how it would actually look like, seeing how it would probably work, really helps you understand that, oh yes, this is something that can be done, this is something that can be achieved. The thing is though that since 1990, Utopia has lost much of its persuasive power. I mean, every hopeful thought has been submitted to the Thatcherite, there is no alternative ideology effectively. People tend to suffer not only under the lack of meaningful and concrete hope, but also in deteriorating material conditions. And yet they so far have failed to imagine, propose something that would change their situation. Obviously, I do not suggest that they turn into, the very prescriptive, very detailed utopia of the 19th century. I don't think it can happen, I don't think it has to happen. But we can look at what utopians did, and how they approach people, and how they managed to actually remind them that a better future is actually something that can be achieved, something, a dream that will remain valid. Effectively, as James O'Reilly wonderfully and very vividly put it in The Seeds of Time, we do have a crisis of imagination, and this is shown in every, for example, post-apocalyptic work of fiction, every zombie story, every weird space opera. We can imagine everything. We can imagine the end of the earth. This is easier for us than it is to imagine the end of capitalism. This crisis of utopian thought has sort of changed the course of critical political fiction. And nowadays, and for the past actually 40, 50 years, we tend to be discussing more in the terms of dystopia, which is effectively a reversal of utopia, the bad place, not the good place. You would say that actually dystopia really translated the bad place. And this has become prevalent. And this is a genre of fiction that actually takes our current problems, our current fears and anxieties and our estimates for the future, and extrapolates them into a good society without, though, taking away all hope. But that doesn't matter right now. The thing is that this is very, very prominent in all types of science fiction, including games. So what I'm showing on this slide is an artist's depiction of the city of Rapture, which is an underground city supposedly created by people who adhere to the abhorrent politics and philosophies of Ayn Rand. And the idea of the game is to show you just how monstrous such an objectivist, quote-unquote, utopia would be. How horrible it would actually evolve, despite what we know due to its submerged article skyscrapers. Then we have the very well-known classics like Huxley's Living World, we have 1984, and then we have movies like Blade Runner in Brazil, both stunning in their visuals and cinematography, but both sort of cautioning us against a possible future or possible aspects of a not particularly nice future. In games, we have had a history of over 4 decades in dystopian games. We have Infocom's text-only adventure game, and Mind Forever Mortgaging, where we actually get to experience the gradual collapse of a nice parochial suburban town in the US into a dystopian hellscape. Then we have Bioshock, the one I just mentioned. We have Cyberpunk 2077, one of the most recent takes on hellish cityscapes where life was cheap and people are desperate. And what I really like to point out here that's very interesting that not unlike Utopia, dystopia also tends to focus in urban environments. It tends to happen in cities. For some reason, which to me is just very obvious, in cities have all this condensed human experience. People tend to set their stories and express their fears via urban environments. And I think that's very interesting in dystopias, besides expressing the pessimism of the era, perhaps, is that they are always technological, almost without fail, generally progressive. They're always very, very spatial and very scientific-minded in their critique of the status quo. But what we changes them and sets them apart from most utopias is that they're not static. You see, utopia always implies that we have reached perfection, and perfection cannot change. Perfection is effectively a state of nirvana, a state where dialectics end, where every struggle has sort of been resolved. Nothing new has to be challenged by something old. Things never change. On the other hand, in dystopia, things always keep changing. Things always keep evolving. There's always hopes or fears for a better or even worse future. And it's very interesting because as it rose after the 90s, effectively, it also rose in direct contrast to the bourgeois narrative of the end of history, which thankfully very, very quickly collapsed and sadly very spectacularly collapsed too. And the state matter is there to emphasize the fact and triumphantly be happy about the fact that dystopias are very popular in video games. And that also means that they are very popular in an increasingly influential and active and I am almost to say persuasive element of popular culture. It means that it can actually show people, and a lot of people, that things could really get worse, and that maybe they might unless we do something. Moving on to connection between video games and the imagination of utopia, we first of all have to know that video gaming as a medium is actually defined by its ability to create immersive experience, to give the players the sense of being somewhere else, being even in a completely exotic, impossible place. And as players willfully suspend their disbelief, they get to experience those different and often impossible places and situations. And by experiencing them, they feel new things, they think new thoughts, and those new thoughts are unavoidably transferred back into the real world with them when they turn off the game machine, the computer, whatever. And maybe that changes them, and maybe indirectly that might even inspire someone or shape a bit of the evolution of society in itself. Of course, I do not argue that video games have to be useful in any sort of measurable way. I don't care whether they increase our hand-eye coordination and they perfect our reflexes. This is pointless. What really matters to me is that they are a popular art form with mainstream appeal, and that they are actually in a position to help us escape great situations. And escapism is often derided, but it's something that we all need. It's something that all art is aspired to. We want to forget, even at the perfect setting, we would like to forget your mortality for a while. And so by doing those things very, very successfully in most cases, they are also in a position, if they choose, to start discourses, to enlighten, to spread ideas. And what's really handy in my case and in our case is that it is in the nature and in the design sensibilities of the creators to actually present their audiences with synthetic worlds that are convincing, with spaces that feel real. They feel so real that can actually enrich imagination. They can actually add tools to our arsenal of imagination. So yes, games and utopia are very compatible. And they're immersive, interactive, and easy to navigate worlds of gaming can actually, they've already done so, inform the way we look at cities. They can also inform the way we look at life in general and society as a whole. They can thus they are thus able to even convey valuable ideas and actually view those ideas with a very fleshed out, very concrete in a digital manner form. Two games that I find very interesting, and one of them I actually completely love, which is The Single Game Everything by Jonas and Renate Beatriz, which is a game that is decidedly political, and though it does not force its politics on you, it does give you the room and the stimuli to actually think of what is happening around you and what could happen. And then we have more industrial games, which are pretty famous in their critique of also modern politics and society, to everything from unmanned drones murdering people in Pakistan, or like the drone-like existence of the everyday office worker. Good thing is that games are meant for players. And what players do is that they obviously play, and that they tend to interact in those, different and dynamic locales we create for them, and they tend to interact with locales not just 3D models. There are 3D models that come with systems that have AI integrations that change, that evolve, that react to what they do, and even that technical part is something that I would imagine any 19th century European philosopher would kill to have access to. This should have allowed them to really show off, exactly what a finance would look like before building it. You would just be able to walk in there and listen to the people and see how it changes and see what happens at night and see what happens if you, decide not to cook for a day and whatever. It gives you a very, very persuasive tool to make your point understood. Can actually liberate one's imagination, obviously to the point of picturing the applicable, and even if that is not something that can be applied to the masses, I cannot imagine most people deciding that they want to do future outside analysis, that we are in a revolutionary condition. Probably because you cannot do that via art, but you can definitely inspire some. You can definitely make an argument for something different, even if you're useful on a minority level. That's absolutely okay. What's also incredibly interesting to me, and it was an excellent point put forth by Alexander Galloway, is the fact that all video games are, up to a point and at a certain level, utopian projects. Why does he say that? Because they actually encompass worlds, they take place in worlds that pick and mix the laws and rules they're simulating. They actually choose where they are happening, they actually choose what applies, what would you like, what has to be emphasized in everything, and exactly this freedom to shape rules and the technical expertise to express them via a game engine, for example, is, according to Galloway again, the utopian scaffolding. What we can use to actually build and showcase our ideas. And that was a very, very popular in gaming circles idea of Brazilian's magic circle, which actually refers to the social context and the social borders where specific rules distinguish one type of social space from another. The standard examples are the tennis court, the chessboard, the gladiatorial arena, a temple or a church, or indeed the video games. Those are within their borders. What happens is not what happens in wider society. It sort of is a border that differentiates game or play space or ceremonial space from everyday life and everyday space. But exactly as a wedding that will happen within the magic circle of the church or the temple or the mayorship, does not lose its significance, does not lose its importance within civil society. Same thing you can say that would apply to a gaming experience. The experience is not lost. The moment you stop playing, you not instantly forget everything you've seen. You not instantly forget everything you felt. They're there with you, and you carry them with you, for whatever amount of time, to whatever extent you would like. But still, you are influenced by it. And play can actually move out of the playground's boundaries just as effortlessly and impressively as Bioshock suddenly sparked this wide discourse on objectives. And it sparked this discourse in an audience that you would not expect to be discussing this sort of things, right? And another example would be Pokemon Go, which had thousands, hundreds of thousands of mostly young people running around cities hunting for cartoon monsters and interacting both with each other and the game and the cityscape in completely novel ways. And then we could say that, SimCity, for better or worse, I would say for worse, has deeply influenced how people look at urban planning, how people think that zoning works, how people think that their problems are solved. The fact that it's, ideology and that its models are completely obsolete and pretty abhorrent doesn't mean that it doesn't work in that way. It does. And I do remember at some point looking at the curriculum of, I think it was a university in the States, they were actually using SimCity to teach first year students in planning I don't know, something wrong, obviously, but it was actually used as a teaching material. One of the reasons why video games are so successful in planting ideas or notions or creating feelings that we tend to remember a lot is the fact that they demand the participation of the audience. A video game will not conclude if you cannot pass its challenges, if you do not think the way it wants, if you do not react appropriately, if you do not explore as much as it wants to. Unlike a movie, even if you're not paying attention, it will just reach its end, and a book that you can read even though you're not understanding. When it comes to games, you have to understand them. You have to uncover the patterns that are demanded by you in order to reach your goal, to beat the game, to finish the game. And this exact demand amplifies this sense of agency that players have. They have to be taught rules, they have to be trained, they have to be tested and rewarded, and they have to solve problems. And this is actually what really engages them, what really immerses them in the game world. Fantastic example we have to be the classic stealth game series called Thief, where you have to be super careful to stay in the shadows and not to make sound, not to infiltrate Victorian palaces and residences. And this teaches players to really look out for the materials and know that wood floor will break, that stone is good for running, and the shadow might be a good place to hide. And by doing that, by constantly scanning their environments to see what they have to do and optimize the route and find the best route, etc., they actually engage with the world in a very, very physical way. They try to understand its architecture, they try to understand how things work, they try to understand how people in that world work. And that is what really makes them get to the place. Actually, it's player choice, and the sequence of constant player choices that we use in order to engineer the emotions we want to drive any game experience. Because we know that it is this agency that people create, and it is this agency that will amplify their feelings, pique their interest, and make them want to know more about their surroundings. And if anyone of you has played Dark Souls, which is a very difficult game, but by being difficult, it actually sort of forces players to play in replay segments, to pay attention to details, to find out every tidbit of hidden lore that they would have missed otherwise. So yes, this deep engagement of our audiences with our games is what makes them so susceptible to the power of the feeling created effectively. Another thing that's very interesting is that video games and the tools, especially game engines like Unity and Unreal, and also all the 3D modeling tools, and all the procedural creation tools, all those things allow us to actually take any utopia and turn it into an interactive 3D digital space. And this is important because we do not have to know how to read maps, we do not have to know how to read the architectural designs, we do not have to be able to know the nomenclature that has a given geography, but they can just feel as if they are, say, in Atlantis, as if they are, say, in that case, in 1920s Chicago, in Mafia, but they can actually get the sense of being in a place. And this is much, much closer to how we daily perceive physical space. And what happens in a way that we can really understand and empathize with, in a way that we can actually parse, is that we can see it as something that is, at the very least, possible. Obviously, those immersive experiences are carried over with us. And this is exactly why I argue that games and game technology can actually become the building blocks for any new utopian discourse. They can be like Lego bricks that did not have to necessarily nurture ideas by themselves, but are very good at expressing them. And they're very good at expressing them in a way that is actually interesting to people, that is actually enjoyable to people. They can be expressed in a very playful way. And I think this will have to make this pretty interesting and important, perhaps, distinction. We don't just want to create, fake virtual. When you say virtual, we sort of imply something that is imaginary, fake, or just, a tape that is simplified reality. What we can do is actually create potential virtual. We have to showcase not what is, but what could be. We don't want to make something that is just there to entertain, but something that is there to inspire thought, to convince, to perhaps convey images of a better world. For the creators themselves, what's really interesting is that they are actually liberated from the constraints of actual space. I mean, this is something I saw very much in my case when I stopped being an actual urbanist, especially in Greece, and had to deal with stupid budgets, maddening red tape, petty arguments between officials and corruption and all those things, but also things like physics and costs and sizes, and just having infinite space to play with, infinite options to model and remodel and redo and create all sorts of weird things. You can also create floating buildings, you can create citizen space. This thing is completely integrated for the creator too, because virtual architecture and virtual urbanism and level design as a whole do not actually have to adhere to the constraints of reality. They do not have to obey any law, they do not have to serve any actual human need, and yet they can always feel real. And just playing with them is bound to give you new ideas and bound to provide you with new insight into how things are and how they could be and how the things that are can be modified. Video games do indeed provide us with vast expanses of digital space, places where we can experiment with without the fear of them running out. Everything can be arranged anyway, and then rearranged, and then use all sorts of technology to breathe life into it and make it behave in a way that would effectively, again, quote, allow us to test this new reality, to see how it would function in the dark, how it would function under rain, this sort of thing. Of course, we do not have to stick to what the older utopians did. We do not have to just present them with our idea of a better future. We can actually let them play inside our future, let them shape this future. We don't have to create static descriptions, but we can actually take their choice in consideration. We have the tools, we have the programming techniques and ready-made libraries, if you want, to help the game world evolve along both deterministic and also procedural lines. And we can also, start and restart our worlds in an endlessly iterative fashion to see what many people could actually come up with. Sorry. And we do not have to be limited by what a single visionary, perhaps, or a single smart person could come up with. We can take this core idea and play with it. And we can actually have in-game tools that can be supported by systems. They can be presented in a more interesting gaming way, say via moral choices, and give players the options to tweak Utopia, break it, make it something new, or play with it in all sorts of interesting ways. That this will create a new sort of dialogue between the proposer of the utopia and the people who it's meant for. And this is something that could be a very interesting way of discussing the future. And then we have things and technologies that allow us to have massively multiplayer online games, MMORPGs, or I won't say metaverse, I won't say virtual worlds, because they come with a whole baggage there. But the fact that we can have real looking spaces inhabited by thousands or hundreds of thousands of avatars might be a fantastic lab we're looking forward to play with and experiment with new urban or civic or even societal ideas. Obviously, taking into consideration that yes, there are definite problems when one is trying to assign value or scientific value to the way people behave in a game, the way people behave in real life. But but still you can see what people can create collaboratively. What people can create, for example, collaboratively in Minecraft is amazing. It's jaw-dropping. You have whole cities rebuilt from scratch in 3D. You have fantastic worlds rebuilt collaboratively again in 3D. And this is something that we could at least try and play with and see what can be done. Now, in case you're actually interested in creating a virtual city, in case you're a developer or someone who would like to delve in, those are some very, very basics that are absolute fundamentals of what you have to keep in mind. So first of all, every city, every game city effectively has to make sense. That is, it has to be cohesive, even if it's exotic, weird, space, fantasy, inhabited by the undead. It has to be a place that does not contradict itself. If you have gravity, then gravity should function as gravity does. If you have a society, then this society should sort of function like society. Why do you want to do this? Because you want to create this illusion of reality, this sense that everything here sort of makes sense in a way you can understand. And this realization is what will lead to believability, which in turn might lead into this sense of spatial immersion you're always looking for. And then try not to think exclusively in architectural terms. This city is not a big building, even though architecture is very important in shaping its looks and functions, and as is city design on a small scale. You also have to try and think like urban planners and geographers, try to see the big picture and try to realize how that is structured and how that functions. Absolutely let your city tell its story and inspire your games, your worlds, your characters, your narratives, and of course, like the level design, the way where you actually make it playable. Definitely research your urbanism, and you will be surprised to find solutions to things you didn't realize were problematic. And try to remember that all urban centers have their history. They are all created by societies. They are thus always dynamic, and they never reach a state where they are finished. They are always constant works in progress. Urban functions are a very, very handy concept when it comes to designing. Urban functions are the reason cities exist, what they are meant to do, what they have to do. Cities are created to support and facilitate those functions, and as those functions, evolve, the cities themselves evolve. The classic example I like to think of is that in a medieval city, you would have the defensive and religious and residential functions as core. So usually the medieval map would have to be the circle as the walls, cathedral in the center, and the rest of the residences, more or less. But in a modern city, you would have to consider stuff like the circulation of capital, residents, and also administration, and access to water, food, traffic, and all those things that are absolutely necessary to have in a city for it to work. But you would probably in a modern city not care about defense. It's something you do not do on a city level anymore. So this is a function completely lost, or the function of traffic is no longer on foot or on horse or by a carriage, but it's by our cars, trains, also a bit on foot. So it's an evolution of the function itself. Absolutely have to ask yourself the four key questions, which is where the city is, when the city is, why it exists, and how big is it. It's a completely different thing talking about a town, a completely different thing talking about a metropolis, and a vastly different thing trying to imagine and conceptualize, a planet-wide development. Keep in mind that all urban space has been planned, maybe not institutionally, maybe for reasons that we cannot discern, but no one just puts a tree there. This has to be decided that it will serve some sort of purpose, even if this is a background. A city has to be approached as a whole. I would suggest generally thinking from the general to the specific. But while working, I can also add it or don't. I mean, I had at some point create a wider city along a single block, so never know how those things go. And we definitely remember that cities are entirely differentiated. You have specific districts, you have specific distribution of classes and ethnicities and all sorts of major differences that can actually differentiate space itself. Urban infrastructure is important. It is the skeleton in which the city rests, and without it would function. And infrastructure would involve everything from the roads and the pavements to sewage systems and telecommunication systems, and those things really shape how a city looks and functions. I mean, in the old days, you wouldn't have cities that are like bigger than a few kilometers because people would be able to walk further out than that. But when the train comes and it liberates cities from walking speed, you suddenly have an exploding size and an area. Remember that all settlements, small and big, have to have some sort of form that will effectively express their structure. And definitely, when trying to make them interesting, try to think of the inferences and how you arrive at a place, what landmarks people will see, and how the boundaries are defined, especially in games enforced. Now, when it comes to crafting urban history, again, we steal from reality. We try to realize that cities have the results of historical, geographical, economic process. Actually, if we have to point, simulate a listener brain, and then cleverly showcase to our players. I mean, if you had imaginary Athens, you would have to have the imaginary Acropolis there just to imply that this is a really old place, that this is not the first time people have lived here. We have to sort of, again, in our mind, try to have this whole process of the civic evolution from the village and initial settlement to the town to city to metropolis to whatever follows after that. And remember that in parallel to that, you also have political, economic, and technological evolutions and revolutions happening constantly. Of course, there's always a chance for a city to completely disappear following economic and historical changes. I mean, a hub city for the railroads would just die if the railroad stopped operating there. There's also the option that a city can indeed be planned and constructed as a whole out of the blue. We have the example of Brasilia, we have the example of Islamabad, we have the example of classical Baghdad, where the ruling class or the ruler decided to create something very impressive out of nothing and have this fantastic blueprint which sort of materializes on space and then quickly evolves by itself. Keep in mind that history and society tend to build worlds in layers, and this is exactly what archaeologists know very well with what they did at places to find. In Geneva, you have medieval Geneva, and then you have Roman Geneva, and then you have ancient chieftain Geneva. Progress and evolution absolutely never stop. Things always have to be built, changed, and reconfigured. And to close things off, here are the three approaches I would say one could take to create a city for a game. First approach would be to choose an existing or historical city and abstract it, try to discern its identity, see which characteristics are the more important ones, and then generalize everything, abstract everything, and present it to players. Two classic examples have to be the Assassin's Creed games, and of course, the Double Match New Orleans mostly. Then you can always mix and match and heavily modify or combine existing and historical cities, mix their elements, disguise them, and that's exactly what the version of New Orleans of being Mafia 3 did, and more famously, what Terry Pratchett's more popularly, and Terry Pratchett actually fused a bit of talent with Prague, some Victorian London, and a bit of 19th century New York to create this fantastical city. And finally, there's the option to create something from scratch. Again, you're free to steal from history and reality, and novels and films and everything, but you will generally have to start by asking yourself where, when, why, and how big the city is, and what would be the defining characteristics that make it memorable. Maybe then you go on to list its functions and try to express them as land uses and map them, and come with a first rough map and place a center somewhere and decide what it would be about, and then populate and be imaginative and make it interesting. And examples are all would have to be excellent examples. Midgar from Final Fantasy VII, one of the more legible cities ever created, but also know Macava and City 17, but also Rapture from Bioshock, yeah, a very, very strong conceptual city. And finally, anyone who would like to ask something, discuss something, those are my contact details. Feel free to drop a line, drop a tweet, or an email, whatever. And so thank you for your time, and anyone would like to ask something, please feel free to do so. Thanks.
Should anybody have questions, raise your hand. Oh, we have two already. Guy in front. So you can scream and he will repeat the question for people on Zoom. Yes.
So one of the players said that your city should be as little as possible. I was curious when, like, your city creation conflict with your gameplay designs, which part of the process should take place?
Okay, thank you. So the question is, when you have a conflict between the demands of the city design and capability and gameplay, which one would take precedence? I would say that generally speaking, I tend to give precedence to gameplay. Because it's the main thing a game would have to be good at. There are always though good compromises, and you would try to not do it too often. Right? It's very easy to overlook something that's odd once, or something that doesn't make too much sense, like what happens in one or two sections of the game. But too many mistakes start sort of eating away our willing suspension of disbelief. After a point, you just realize that this is just fake, it just doesn't work. So you have to be as careful economically as you can. But generally speaking, also just that gameplay would have to take precedence. That's it.
So you would draw the line on the suspension of
Yes, I mean, if it gets too much, you would then have to probably design it out, probably come up with some sort of solution without breaking anything more. I would say.
Alexander?
Yes, I wanted to ask, Animal Crossing, not quite the city, but it was like an escape for a lot of us during quarantine, and I wonder if it fits into the utopia framework. There's so tiny pieces of city, right? There's a tiny town hall, the shops, the museum, kind of thing stuff.
I would say that this is a very interesting remark / question is whether Animal Crossing settlement would fit into this utopian talk. Yes, I would say that. I mean, thinking of it now, it really does conjure this feeling of, calmness and certainty and, this small pastoral idea that is nice at least for a bit. And I think, yes, I mean, Animal Crossing could inspire me. I can imagine it could inspire you, I don't know, to move to the mountain and hunt bears, whatever it is you do at mountains. But yes, I think this is a feeling that when applied to something more complex could add to the utopian discussion track. So absolutely, this was a very interesting point.
Christoph first and then others.
You said there's a lot of scopes and mirrors of going in obfuscating the fact that in game cities are often much smaller than they would be in reality. Could you go into a little bit of detail or maybe explain like what kind of advice you give for game designers if they want to make a city like appear like a real big city while working with more limited space?
Yes, so thank you. So the question is what sort of tricks and smoke and mirrors we could use to make a model urban environment feel and look larger than it actually is, because it's always much smaller than it should be due to the cost of assets. So there are countless things to do. For example, never have straight roads. You have curved roads and they never show their end. You sort of imply that this thing goes on. Then you can have sounds appearing from outside the geometry of the game. I mean, you have this wall here, but if you listen to something that's coming from beyond the wall, you instantly know and you realize that something exists there. You never get to see it, but you get the feeling that it's there. You get the feeling that things are happening around you, and then you can cleverly abstract. I mean, say the average city block in Athens would have to be, I don't know, 10 by 3 buildings. So if you turn that into a 6 by 2 buildings, no one would really notice. You would get the sense, you would get the feeling. This is exactly what open world games like Assassin's Creed and GTA do. They abstract a lot. I mean, you do have a lot of stuff there, but it's much less than you would have in reality. So you don't have 15 factories, you have 2. And they actually act as symbols. And symbols is another thing you use a lot. I mean, you don't have to show, 15,000 homeless people to showcase the fact that the New York of J6 has a homeless problem. It's enough to showcase 2 people as a symbol for homelessness and focus on them. And then in Skyrim, for example, you have this, the beginning of the design idea was that there would be this nobles district. And this ended up being too costly for the Stormwind City, and they just substituted with a palace, which sort of stands in for the whole noble district. So you have symbolism, you have abstraction, you have sounds from afar, you have carving roads. What else can you say? You could avoid open world games. When you have a curated space, it's much easier to just show views of low poly assets, or even use procedural stuff for you, just fill in the blanks in the player's mind. Because what you want to do is, we're very good at creating patterns, right? So if you give people enough info, they will just fill in the rest for themselves. I don't know, do I cover you? Good.
There was Adonis, and I don't think Rafa will come for another question, but you can talk to Constantinos after.
Yes.
All right, I'll just build from symbols. This might be a long question. You mentioned on your last slides how to, you steal from the real world. Symbols. There was a few talks about, how you appropriate, different cultures into games, etc. Is it enough to just steal one symbol, or do you need to actually steal a bigger part of it?
I would say, I think the question is, how many symbols would you steal effectively, right? And I would say it depends on what you want to do. I mean, if you want, first of all, you have to realize which symbols would be useful for the story you want to say. I mean, if you want to talk about the blue future, you need homeless people, you need people dying on the streets, perhaps you need derelict buildings. So you have to steal the elements of reality that could really emphasize this thing. So you would have, this the barrel with the fire and 3 people around it. Everyone associates it with a homeless person. And then you would still, you would have the building with the broken windows and the graffiti, because everyone instantly realized that this is an abandoned, dilapidated building. So it really has to be on a project by project basis, I would say.
I think, unless you protest, I think we're out of time. And so Constantinos will be with us for a few more minutes, so you have a chance to engage him. Before we give him a hand and a round of applause, somebody lost this charger. So if you know somebody who lost a charger in room 1, no, actually room 2, sorry, this is it. Constantinos, many thanks for coming and enlightening us on design of cities as building blocks for utopia. And thank you everybody for being here. So
thanks so much.
Thank you. Well, it's just like let's not try before you say. Can I